seats in the front rows, if you can just occupy the seats at the front. Okay, thank you. So good morning, ladies and gentlemen. Good morning, ladies and gentlemen. Right, so happy to see you all back here in person. Thank you all for attending the Zak Engineered Timber Envelopes conference. We have a very unique set of audience today here. So we've got 50-60% of our audience, Façade people whom we already know from our previous events. I'll talk about that a little bit. And then we also have the timber audience over here. And I'll quickly talk about why this event and what we aim to achieve with this. I'll go back to the history for those who don't know us, at least the people from the timber industry. So we basically organize the Zak World of Facades conference. It's a similar kind of conference, but that's on facade design and engineering. We organize this globally across 32 countries to be precise. We finished 84 editions. We finished 6-7 editions here in the UK. It's all about facades. We were going on a roll until COVID hit and we had to put brakes. But then late 2019, we realized that there's been a lot of talk on the usage of timber, mainly in Europe, in Australasia, in North America. So we started exploring this subject of engineered timber. And of course, the lockdown came then and I had a lot of free time to research and talk to a lot of people. So we decided, let us do this event on engineered timber envelopes the way we want to show it through our eyes. So basically, the idea was we got to know that timber can be used in multiple ways in the building envelope, in cladding, in curtain wall. But again, most of the other timber events happening here were hardcore mass timber events and not particularly on the envelope. And the envelope is something which we promote globally, and we have our expertise in doing that. So why not make something fresh? Because what happens in a typical facade conference, timber is overshadowed. It's spoken little bit, but then you have GRC, you have stone, you have terracotta, you have other cladding materials which actually overshadow timber itself. So we decided, let's do this event, which is engineered timber envelopes. And then first when I announced this, people started laughing at me. You're doing a timber envelope event, that too in the UK, which has the most regressive building codes in the world. And to be precise, these were people in North America, especially in New York City when we first announced this. And I had a lot of people come up to us and say that, you know, are you sure you're doing it in the UK? I said, yeah, there's an opportunity. There's an opportunity to talk about this over here more than any other place, because it's a little funny that, you know, architects based over here are the best around the world, the architects, engineers here, but unfortunately they can't play around with timber much over here because of the regulations. But the same architects and engineers, you have them doing projects designed here in London but executed in other parts of the world. So we thought, why not we push this and talk about using timber more in the envelope. I know firms like Thistleton and others are doing their bit. They're making a lot of noise on using mass timber in the in buildings. But as a facade community, I think you guys can also join them in raising the voice, in making more noise, because as soon as more people start making noise, hopefully the people sitting at the regulatory authorities can take notice, and I'm sure once these regressive codes are removed in the UK, in no time you will see UK being one of the leaders in mass timber building. So that was the idea. We already had a connect with the facade industry. So let's join together and try to portray something from our point of view. And that's where this whole idea of this solo event came up. I'd like to thank our event partners. Of course, this event was planned last year, and nobody expected Omicron, so even we never believed, let's say, late December we could pull this off in February, but things improved drastically over here. I think the UK boosted its way out of, let's say, the Omicron wave, so we are here together. But this event wouldn't have been possible without our event partners, Accoya would. So Accoya is part of Accsys group. They have a very interesting engineered timber product. You'll be hearing about them a lot today, several references of them on various projects. AkzoNobel, from the facade industry, we know them more as a powder coating manufacturer, but here they have solutions. This is the wood division here. So they have solutions for, and adhesives for wood. Future glazing now, so this is interesting. So we have glass companies now integrating timber in their products to complement timber buildings, to complement timber facades. So this is an interesting product which Future Glass has on display over here. Gutmann is an aluminum curtain wall system, but then they have now launched a new unitized timber aluminum hybrid curtain wall system. So this is what I was talking of, the facade industry having one product which gets overshadowed by their other bread and butter products, but we've been successfully able to convince them to come outside to launch their specific timber-related product, even if it's in a hybrid model. That's something which we wanted to do with this event, and we've been, I think, successful in getting the aluminum system guys to come out and showcase their timber solutions for curtain walls. International Timber, it's a Saint-Gobain company. They're a distributor of many timber cladding products. Lindner is a global facade and building envelope contractor. They are also showcasing their unitized curtain wall solution. Proctor Group is a leading membrane manufacturer, vapor barriers and membranes, here from the UK. Rotoblas, they are stars in the mass timber industry. They have tapes, barriers, membranes, screws, you name it, everything. They've got all solutions for mass timber buildings. Schindler is a top-notch German facade contractor doing projects here and in Europe. And they are also showcasing a timber solution apart from the other timber cladding work they've done in Europe. So these are our event partners. I'm sure we could have had more. There was a lot of confusion in November and December with Austria and Switzerland going into lockdowns or looking at UK a little differently with respect to cases. So we couldn't get many suppliers from there because of those reasons, but eventually we'll get them in the later editions. Since most of the technology for mass timber or, let's say, complex envelopes in timber are from suppliers from Switzerland, Austria, Germany. So this is it from us, and just for to our facade people who are over here. So our next event is in Dublin, 6th of April. So again, it's a delayed event. It was originally supposed to take place in May 2020. Ireland had one of the longest lockdowns in the world. Finally, they are open, so we will be executing this long-pending event there on the 6th of April. We come back with the Zak World of Facades in Manchester in May. And then, of course, the London Zak World of Facades, our largest event. What's going to be special this year is it's going to be even larger. We've collaborated with SIPSI and the Society of Facade Engineering, and they have this globally renowned Society of Facade Engineering's Facade Awards. So that's going to take place after the Zak World of Facades conference via a black tie dinner. So we are hoping to get many more people coming to attend both the events. So it's a good co-location. We've been talking about this for the last few years, and eventually we've had a deal done with them. So I'd like to thank SFE and SIPSI for working with us on this event. We also have some special offers if you'd like to book a table for this black tie dinner outside. We have a booth over there. We can explain more to you. So I won't take much of your time. I'm done with my talking. I'd like to introduce today's event host and convener. It's Alan Dowdall. He's a director at Ramboll's Cambridge office. He's a mass timber expert, so he's going to be leading today's proceedings. So if I could request Alan to please come over on stage, please.
Good. Can you hear me? Sorry? Okay, good. Wow, a lot of people. It's good to see everybody. It's been a few years since I've been to one of these events, so I'm looking forward to talking to every single one of you later. I've been in the timber world about 15 years now, and it's been great seeing it sort of flourish and grow. I don't know when it happened, but over the last couple of years ago, it's been like an awakening, where it's sort of, rather than being in a small bubble of people who have passion and enjoy and working with the material, it's sort of spread out, and spread out worldwide, which is, I think, a great time to be in, a renaissance of timber. We're learning, again, what our ancestors used to use. So it's a brilliant time to be an engineer. My background is structural engineering. And I think a lot of people are appreciating the material, whether it's for its low carbon, it's a light material, if it's low, it's fast, construction, health and well-being, sustainability. It's all out there, which has created a demand. I think with the demand then comes an issue I think we have with our industry. That's supply. It's not supply in the material itself, it's supply in knowledge. So we need events like this to spread that knowledge. We have a small pool of people who can really work with timber and work with it, and they are highly knowledgeable. But that needs to spread out. And having events like this where they're recorded, people, so the generation behind us, they're going to be the decision makers in the future who are going to have to have the hard choices to make in the 2050 and so on. So we need to arm those guys with the knowledge of how to make low carbon and sustainable buildings and developments going forward. And luckily today, we've got a packed roster of people who are highly knowledgeable in their field, who know what they're talking about. And I know quite a few of them, so I can say this, that what the theme you probably see throughout the day is passion. There'll be a lot of passion out here, because when you start working with timber, I think you just fall in love with it. You fall in love with the material. I see Kelly's nodding, so we see a lot of that. And hopefully, when a lot of you people leaving here today will get addicted to that passion as well, because it is an addictive material. It is beautiful, it's useful, and really want to celebrate it and get more people to understand it and use it. So we've got a lot of people lining up. I'm your host for today, so I'm afraid you're stuck with me. Everyone else will come and go, but you've got me, so unlucky you. But first of all, we've got a Anthony Thistleton, who is, I suppose, one of the kings, the pioneers of mass timber buildings, and he's going to talk about time for timber, a tipping point.
Okay, thank you.
All right, cheers, Anthony.
Thank you, Alan. Thank you very much for inviting me to speak here. It's a fantastic pleasure to be able to speak in person once again. I don't know how many of you have had the pain of presenting over Teams or Zoom. At least if I get an eerie silence here, I'll know I've bombed. Thank you for that. Alan, what Alan was saying, I think sort of segues quite nicely into what I want to talk about. We use the term tipping point. I think in terms of the climate crisis, we're all familiar with what this concept, the idea that when certain systems enter a different phase, we can get a catastrophic collapse. So issues like the Atlantic conveyor or the release of methane from Siberian permafrost. But as Alan was saying, I think in terms of our story and our kind of struggle to get timber adopted and engineered timber adopted into wider use, we are, I think, at a tipping point. So my practice has been working in engineered timber for it's coming close to 20 years since our first cross-laminated timber building. And we've been talking about it and proselytizing about it ever since. And this is the sort of principal reason why. The use of engineered timber, in fact, any timber in buildings, gives us the possibility for long-term storage of the carbon absorbed during the material's growth. And of course, it's not just the sequestration element, it's also the fact that when we use engineered timber, particularly, we can avoid or minimize the use of high-polluting, high-carbon emission materials like steel and concrete. And for us, this big key is that the use of timber drives the whole supply chain and encourages forestation. We know that in areas where sawmills are set up, production of timber is increased, the forests increase commensurately to supply those sawmills. And we know that forestation is the principal way in which we're going to meet the challenge of reducing greenhouse gases over the coming century. So our journey in CLT, as I said, our first building was about 20 years ago, but Murray Grove, we produced this building. We designed this in 2008. It was finished in early 2009. And we made the argument to the local authority that if you calculated the absorbed carbon, the carbon that the building was storing, and you offset the carbon that the building would have cost in using concrete or steel, that would be equivalent to the carbon saving from 200 years of the building's use, in the 10% reduction through the renewable energy target. And this was an argument, as I say, we made this in 2007, 2008, and this was accepted as our renewable energy approach. And this was one of the reasons we were able to get our developer client, who wasn't that interested in the environment at the time, to use this material and produce this world's first building. I think I need to point, don't I? And so this whole calculation, the carbon footprint of this building, had we built in concrete, which would have been the standard approach at the time, would have had a carbon cost of 21 tons of carbon dioxide per unit, and we ended up with a 19-ton negative carbon per home, and that means that the building is carbon negative for the first 21 years of its life. So it was finished in 2009. So up until 2030, it will be a net contributor to reduction of greenhouse gases. And I think that was an argument we made 10, 12 years ago, and I think we were quite kind of surprised that in 2018, one of the foremost buildings, in fact, the winner of the Sterling Prize, was the Bloomberg office building by Foster & Partners. Now, this is in no way to discredit Foster & Partners. It's a fantastic building. It embodies many extraordinarily inventive and innovative ways of reducing the operational carbon, but it was described as the greenest office building ever, and no account was made of the carbon embodied within the construction, within the materials there. And we believe that has to change. And we were kind of dismayed that argument that we'd made 10 years ago was still not being adopted. But I think more recently, we're finding that the argument is, and I think this idea, this tipping point that we're reaching now, is coming to play. Here we have Marks & Spencer's headquarters on Oxford Street, a proposal published in October, or I think it got planning consent in October, for rebuilding the headquarters, a new building on the site. There was a big backlash in the press about the embodied carbon and the cost, and how Marks & Spencer's, who like to portray themselves as very sustainable and green, were producing this very high carbon solution. Again, I'm not talking about the architects, I'm talking about the culture that's changing. And of course, a month later, back in November, we had for the first time a building that part of the reason for its refusal in planning was the embodied carbon. And now, even more recently, in the last few weeks, the Citigroup Tower, a 30-year-old concrete-framed building, is now being refurbished rather than replaced, which had been the original plan. So I think that's a really exciting change that we're seeing. And it really comes down to this very simple carbon economics. And we understand that if we have a repayment if we have a large debt to pay, we don't go and borrow more money. And yet somehow we haven't been making that connection with the carbon. This is a very simple graph of a typical residential building. And what we reckon is if you build in traditional forms, we're actually creating a carbon debt that the savings in operational carbon don't really come into play until about 25 years into the building's life. And of course, we're constantly told, oops, I've jumped ahead there, but we're constantly told that 2030 is this deadline to moderate our carbon emissions in order to avoid the 1.5%, to limit global warming to 1.5 degrees, and avoid catastrophic climate change. So when we finished Murray Grove, one of our whole principles of our practice has been is open source. When we finished Murray Grove, the first tall timber building, we produced this book, which revealed all of the secrets that we'd learned in order to help encourage everyone else, other people, to embark on the same journey we had. And over the ensuing 10 years, we finished about 25 cross-laminated timber buildings, all the time refining our craft, understanding more about the material, and pushing the envelope of what it could do. And we were very excited in 2018 to publish this book on behalf of the US Department of Agriculture, where the UK was the absolute world leader in the adoption of CLT. This book of 100 projects in the UK, only 7 of which we put in our own projects. We did find space for 93 other architects and projects within there. But what it demonstrated was this is not some niche technology, but this is a well-established building method used by a whole range of architects, contractors, and clients. And of course, what we know is in the same year, the combustibles legislation came in, and the most progressive building codes in the world as far as timber goes. This is another building finished in 2017. I think in the end, we look back on this as the end of chapter 1 of our journey on CLT. It was the last residential timber building we did in the UK, all built of CLT, completely manufactured off-site and brought and assembled very quickly, very economically, and very low weight. But this is one of the last CLT buildings, CLT residential buildings in the UK, and hopefully not for too much longer. But also, I think the process was very much an analog process, and I'll go more into that a little bit later in my presentation. And of course, for us, I think the cladding was very much to do with the brick cladding was very much to do with the conservation area nearby. And again, I think it's part of an older process, and what we need to be doing, and in fact, I'm focusing here on envelopes and facades, we need to be looking at a building that is considered holistically in terms of its sustainability. And that brings me quite nicely onto the office building, Oarsman Road, which was completed in 2020, so last year, just as we were coming out of the first stage of the pandemic. And this building was conceived completely as a sustainable building. So our challenge to ourselves was, how do we actually create the greenest office building that we can? And it's not just about the embodied carbon, which of course can be solved with cross-laminated timber and glulam, but it's also to do with the operational carbon. And here you see on the south facade, deep-set ribbon windows to minimize thermal gain. But also every part of the building was considered in terms of the entire lifetime. So we designed the building for disassembly at the end of life, reuse or recycle of the materials, so all of the cladding was all clipped into place and can be unclipped and reused or replaced. But also thinking about the carbon cost of the use of the building. So we used this is a hybrid building using a steel and CLT hybrid. You'll see in later photos, you can see through the curtain walling on the north facade, the castellated beams. And the idea of this was that we could produce a building that would be as flexible as possible. So all of the internal partitions are component-based and can be moved around to allow maximum flexibility through the building's use. And we also, on the north facade there, that curtain walling system, the subframe for that is glulam beams or glulam members that support a glazing system. And as you can see, so all the partitions are removable and movable. And of course, the other thing about this building is it also addresses the new concerns that mirror 100 years ago, as the world came out of the last global pandemic, the new concerns for health and well-being. And we know that when you live or work in a timber building, you have lower stress levels, there are lower heart rates. In offices, there are lower absenteeism. So all of these things come into play in this office. And the lessons we learned from this, we refined when we move forward to a building that's currently on site and due for completion later this year. The black and white building, very close to our office, on Rivington Street in Shoreditch for the office group. It will be, when finished, the tallest timber office building in London. And this was designed for even greater off-site manufacture, the whole thing to be designed in detail and using and to maximize efficiency of the members. So actually refining all of the junctions, all of the structural members to be absolutely the very most efficient they could be. And so here it is, we're able to make an entirely timber structure with CLT slabs and beech LVL columns and beams. And again, looking at the facade, looking at the whole building as a timber building, we're able to build a curtain walling system that is, again, using a glulam subframe But more importantly, thinking about the operational carbon and the reduction of solar gain. Typically, in many buildings, that will be achieved using louvers, which are often aluminium. So you're talking about a large carbon cost to produce that carbon saving. We were able to, with American hardwood, tulip wood, design a set of timber louvers that are parametrically modeled to be, the depth varies according to the need for solar shading. And so this full timber facade. So the building is a holistic, whole timber building, all the way from the very outside to the timber cores. And this is the entranceway. And I think and here you can see our lifetime carbon assessment with just A1 to A5. And what you can see here is, of course, as we reduce the carbon of the superstructure, we then see quite the impact of the embodied carbon of the concrete. And here we have a large basement, which I think our preference is to move away from basements, because you can see here that the basement structure alone is responsible for 50% of the overall embodied carbon of the building. And I think culturally we need to move away from getting additional space from digging out in the ground, and we should be persuading local authorities, particularly, that let's take that additional story and put it on top, rather than put it underneath where it has such a large impact. So I think I want to move back now to talking about this need or the reuse agenda and retrofit. We have this legacy across the world from buildings that are now 50 or 60 years old, concrete frame buildings that are now nearing the end of their life in terms of a lot of the services, systems, the facades all need replacing. And the solution in most instances has been to demolish the building and rebuild, because that's the only way in which the developer, the owner of the building, can achieve a greater floor area and therefore justify the cost. And we know that not only considering the carbon considerations, which I've talked about at some length, but also in a city like New York, the logistics of demolishing an 80-story concrete tower block are pretty extreme. So we were very pleased to be able to carry out this funded project of research how one could take a concrete frame building that is at the end of its life. The problem being that the cost of recladding and resurfacing and completely refitting the building is not justified by the value of the floor area that's returned. So by using engineered timber, we can substantially increase the footprint of the building by extending vertically, and in this case, extending horizontally by remodeling the building, creating a brand new building on an existing concrete frame, and thereby justifying and creating the viability that the developer could only get previously by demolishing and building much taller. And I think this is a really important project. As I say, it's a study project, so it's not ready for implementation, but it does offer a solution to developers and the challenge of how we refit all of these buildings without creating even more of a carbon debt. And you can see the simplicity here, the extension of the concrete frame with a CLT frame. Also, we're putting in CLT for some of the new cores that are being used. And of course, the other benefit of this component-based approach is that we can omit, or we can at later stages take out pieces of the parts of the timber to create stairwells between two floors of a tenancy, or to completely remove them to create a double height space and create this kind of environment. Again, as an office building for the 21st century, I think this offers not only a delightful working place, which should encourage people back into the office, but also a healthy, sustainable place as well. And looking also at the facade, looking at how we can maximize the use of timber and create, again, a component-based system, predominantly in timber, where it can be used to create not only a low-carbon facade, one that reduces and mitigates thermal solar gain, but also is a beautiful asset to the city. Now, I spoke earlier about the process and how our use of CLT up until recently has been very much part of the analog process, part of the sustained failure of the industry to catch up on the R&D that almost every other industry has carried out over the last 100, 200 years. Essentially, we're still doing the same as we did 100 years ago, delivering a load of stuff to site, and putting it together in the mud, and using traditional building techniques, carting away something like 39% of the material that was delivered away as waste before it's even been used. So we were very excited in 2017 to be asked to work with Legal & General on their modular housing factory in York. We worked with them for a year or two to help devise the process as well as the product, and also working with Swan Housing on their modular product, a similar approach, although a smaller scale approach. And when this is the Watts Grove project in Tower Hamlets, which was the first block of apartments using their modular product. So a box made of CLT, completely fitted out internally, brought into place and secured by crane. And I think this opens up a whole new way of approaching architecture and looking at the industries referred to earlier and the development of the change in their process over the last 100 years, looking at how this completely will change our supply chain. And I think it's very exciting to be starting to work with suppliers and looking at how we can open up a market for them for completely new products that support this move into modular and component-based architecture. So this is an example of what happens in the car industry, a Mitsubishi base used across a range of manufacturers and 24 different car models, all containing the same basic fundamental component. And that is, of course, true across a whole range of the supply chain within the car industry, is that your car factories now, for the end product, are really just putting together a series of big, large components that were fabricated elsewhere and across a very diverse supply chain. And of course, the other thing about developing a system and refining it is we get this element that we get this iterative improvement on our product every time we do it. And we've already found that, going through the office buildings that we've done, black and white building benefits from the lessons we learned from our previous office building, and as we move now to further office buildings, more lessons learned, and that level of refinement, that means that the iPhone 10 is streets ahead of the original iPhone, because each time it goes through this process of being made better. And we don't do that traditionally as architects. We start from scratch, and we make the same mistakes again and again. So just going back a few years, this is our Vitzu factory, which again, going back to this, I've explained to you, very briefly touched on our volumetric modular approach, but I think for us, we think the component-based approach offers a real vision of where we are going and where we will be in the coming years. This is a warehouse showroom factory for Vitzu, the shelving company that produces and markets the 601 shelving system designed by Dieter Rams that most architects are very familiar with. And we were asked to produce this building and to look at designing a building that took the same principles as the shelving system of a small set of components and junctions to make a large and flexible building. And this is what we produced. It's a beach LVL glue lamp frame and a CLT external envelope. And this is the interior. So you can see the beach beams and columns are marginally larger than a steel equivalent. So we're actually getting the same now efficiencies as sort of older forms of construction, and producing again a space that not only is incredibly functional, is a friend of the environment, but also is a lovely place and a healthy place to work. And again, thinking of our other considerations, the lifetime cost, this is a building that can at some stage be disassembled and a large number of the components be reused in another building. And this is a system that then can be rolled out and used for other similar buildings elsewhere. And this is now our kind of principal concern. So this is a system we're working on, again, taking on the lessons from previous projects. We're now working with Lend-Lease on their Mind master plan outside Milan, which is a large commercial development, and we're working on one of the first buildings and devising this component-based system to construct the offices all the way from the interior to the facades. The facades devised here. We're in Milan. We're going back to these ribbon windows, moving away from the kind of traditional curtain walling system to minimize solar gain, using louvers and sun shading to reduce that. But then the whole the whole building being designed on this component-based system. So I showed you a typical floor. This is a typical structural bay, and then enlarging to the entire building. And this system is now, we are now at the sort of final stages of, we're sort of late stage 3, but this system will then be rolled out to the other buildings on the master plan, and I think but not to produce the same building. It's a system that is inherently flexible and will allow a multitude of forms and finishes. So there's a cross-section of the building as described. And this is a concern moving back into residential. We're very proud to be part of a large consortium of suppliers and across the supply chain for the building wood. It's a Horizon 2020 funded project, which we're about a year and a half into a 2.5-year program, to design a component-based system that is completely adaptable for use in residential. So can be used across a range of uses, and as indicated previously with the Milan project, a range of forms. So it doesn't dictate the architectural possibilities, but does start to benefit from developing the supply chain and driving down the cost, ultimately, not only the carbon cost, but the actual cost of our buildings. And this is, again, the whole project is to produce a system guide that allows this to be open source. The way in which this is going to work is that the components can be made across a range of manufacturers and used across a range of users, so that maximizes the efficiencies. And everything that we're producing with the rest of the team is being published on a website, which takes you through the guide. But as well as being open source, we're also effectively crowdsourcing. So this is one page to do with fire safety that we've touched on before. Here, a very simple diagram, but that under which there is a huge amount of data how to achieve compliance in the different building codes across the 27 EU countries. And I think by understanding the building codes and the fire concerns across the 27 countries, we're effectively crowdsourcing what the overall concerns are, and devising a system that can work with all of them ensures for us that we are meeting the best possible safety standards in terms of the design. And finally, this is a project that we're doing. We've mentioned before the issues that have resulted from Grenfell and the 2018 combustibles ban, which effectively precludes the use of any combustible material. Well, it does explicitly preclude the use of any combustible material in the external envelope of a residential building over 18 meters. But what it actually does is preclude the use across a range of building types, because it's created such a perception of safety concerns that it is for buildings which come outside the legislation, it's still very difficult to use CLT in the external walls. And the fact that the current legislation doesn't allow an alternative route to compliance. The fact that we have a combustibles ban is no bad thing. It is exactly the same environment in which the progressive US building codes now allow CLT and glulam, but they have an alternative route through testing to compliance, and we need that. But in the meantime, what we're doing is we've got funding to produce what we call a new model building, which is a building that we're designing in detail, a residential building that meets all of the building codes, and that we are able to take around fire brigades, warranty providers, approved inspectors, and demonstrate that the building is entirely fire safe and therefore can be built, and more importantly, insurers and warranty providers feel confident that they can warrant and insure the building. And what this involves is there's a set of principles, which is the bottom right diagram, which is this is the principles about how the building should go together, and we also offer a solution of one way of achieving this. And we're now at an advanced point of this where we are, I think, in the final round of consultation with warranty providers and fire brigades. And this will be, I think, a landmark which will demonstrate to the industry that we have a way of building not only compliant buildings, but buildings that are now acknowledged to be fire safe. And this is the LCA for this building. So the concrete industry acknowledged that the embodied carbon for a residential building effectively is about in the upper 700s of kilograms of CO2 per meter squared. And we can achieve in timber, we can achieve either with or without the sequestration, the LETI 2030 targets, and we can do that now. And that's really the end of what I have to say about this and about my practice and what we're doing. We continue to work to reduce carbon in our buildings, but we also advocate for change as well. This is the Climate Change March in 2019, where my whole office went voluntarily, and we took, amongst other things, we took this, which is my final point on the matter. One of the most popular things we've done other than our buildings, our most shared image is our little cartoon, again, produced in response to the combustibles legislation in 2018. Just a very simple thesis on how, not just CLT, but using wood in our construction and creating this long-term carbon store can help us save the world. Thank you.
Don't go anywhere. Don't go anywhere. We have to chat for a minute, okay? Oh, wow. Thank you, Anthony. That was very insightful. So we're just going to talk for a few minutes while they set up the chairs around here, okay? What I found quite impressive from your talk is you publish the lessons that you learn from there. Do you see that as a culture that can spread out where more architects such as yourselves will be publishing the information that you build upon
I think so. Our mission is to instigate and be part of fundamental change to the construction process. And the only way to do that is to bring in everyone involved in construction. And I think when we finished Murray Grove back in 2009, a friend of mine saw it. He said, "You've got to patent every single detail you've produced in that building, and you will make a shed load of money from it." But I think if we'd done that, we would have stifled the development of CLT. As it happens, the recession that came in shortly after we finished the building did quite a good job of that for the first few years. But we want everyone to be using timber, and I think there is this conflict between me as a businessman wanting to maximize the benefit to my business, but me as perhaps a suit-wearing eco-warrior to help to save the world. And I think for me, I will die happy if my business has not done as well as it could, because more and more people are experts in using timber, and we're building more in timber and less in high-polluting materials.
Great, thank you. One more question. The component-based design, I think, I agree with you, is the way forward. I guess there's a trade-off with trying not to link into just one supplier, but keep it open as much as possible. And how much can you make that component flexible to fit in as much of the manufacturers? Do you find that a bit of a challenge at the moment?
Well, I think we're at the early stages of the journey, but I think for us it's absolutely essential that, it's not about sort of creating very tight supply chains. It's about a broad supply chain where all suppliers and manufacturers are actually coming in to help to advise from their point of view. We looked at the iPhone earlier. The way you build an iPhone is not to design it and then work out how to build it. You bring everyone involved, from the component makers to the IT people, to the software people and the hardware people, to design a thing that works absolutely brilliantly in efficiency and takes account of every square millimeter of space and takes account of every small amount of material. And I think we need to be taking that approach in building.
Great. Well, thank you, Anthony.
Not at all.
Thank you. Give you a round of applause again.
Thank you.
Okay, I believe we're all set up for our next topic. It's our first panel of the day.
Just invite Phil, he'll call us panelists.
Yep, so I'm going to introduce Phil Obeya. Hope I pronounced that correctly.
Yes.
Okay, great. And you can introduce the rest of the panels. All right, thank you.
Yep, thanks very much. Great to be back, as everyone's been saying before as well. SOM began their journey in timber about a decade ago. We published a thesis paper called the Timber Tower Research Project, which we made again as an open source. It was our first venture into timber. It kickstarted a whole revolution within SOM that began with research. It led to changing the legislation in the US. It led to more timber in projects that we had across North America, across Europe, places like Switzerland, France. And really we're seeing that this is becoming a greater trend. And if we are going to reach our 1.5 targets by 2030, we're not going to do it without a substantially greater proportion of timber in all our buildings. Concrete may well catch up, aluminium will catch up, steel will catch up, but it won't catch up fast enough. So we can't say it's too hard, we can't say it's too difficult. We have to find a way to work together. And the great thing is, with a panel discussion like this, we've got architects, engineers, developers, insurers, all trying to come together and find a solution. So I think with that, we'll bring the panel together. I'll call them number one, okay? I'm obviously very well prepped for the event. Okay, well, first we've got Inga Brown, who's the Principal and Design Director for NBBJ. Kelly Harrison, the Associate Director for Whitby Wood. Sam Elliott, the Development Director for the Office Group. James Suter, Associate Director at Elliott Wood. And Karen Hessin of the Head of Construction at Eviva. So to start, I'll invite everyone to maybe tell us a bit more about yourself and what brought you to timber. So maybe we'll start with you, Ingo.
Oh yeah, hopefully that works. You can hear me. I'm an architect, a principal and the design lead of NBBJ's London studio. NBBJ, I don't know if you know, has about 800 employees around the world. We work a lot with corporate companies like Amazon, LinkedIn, Samsung, but also do a lot of healthcare buildings and laboratories, science buildings, which traditionally probably wouldn't be the type people think about using timber for fire reasons, for safety and vibration reasons, needing a lot of stability in the structure. Nevertheless, I think the reason I'm here is probably because of buildings we did 10 years ago. One was a science building at Queen Mary University. We designed 15 years ago, completed 13 years ago, which used cross-laminated timber for all the walls outside, replacing the stud walls, the concrete blocks you normally have. And I didn't think at that time we wouldn't, I thought we would do that all the time from then onwards, but we didn't. That's one of the maybe things we talk about, why is that? The next building was a science building in Southampton, which is entirely clad in Western red cedar, which the first time I presented 1 year ago, despite being 11 years old. So we went back, and it was one of those buildings which turned beautifully silver gray, and that was the intention, like what everyone, when they specify untreated timber, want. And it stands in contrast, I think, to most buildings you would present 10 years later with timber clad, which are most often nightmare stories, I think. And so why that is and why it's so different to any other cladding materials that conferences normally talk about, I maybe can add some comments later.
Great. Kelly?
Hello, is this working? Yeah.
It is.
Just checking. Hi, everybody. I'm an associate director at Whitby Wood. I'm a structural engineer. And I think I started designing timber buildings probably 10, 15 years ago, mainly schools, nurseries, leisure facilities. But I'd worked more and more on offices and extensions to existing buildings. And all the lessons that I learned from schools and smaller buildings and using timber, started to think, why can't we be, this material's great and it's healthy and it's light and it's fast, and it makes me really smile when I'm walking around a building site, a timber building site compared to other materials. And why can't we use that on offices as well and extend them and use its benefits for that? And so I did lots of work, lots of projects which did that. And through that work, became involved with the Timber Research and Development Association, which is now the Timber Development UK, and I'm on the board of directors for them and very involved in their educational engagement with universities, their sustainability group, their circular economy groups, and we're really trying to push out, knowledge and let everybody in the industry know about, and our next generation of the industry know all about how to design engineered timber and the benefits of it. So yeah, that's my history.
Great. And Sam?
Sam Elliott from the Office Group, and our experience in timber actually started on a project with Kelly in Borough, and it was a single-storey roof extension with a steel frame CLT slabs, and that particular minute, the whole building outperformed what we sort of set out to achieve, but that floor, particularly with the sort of exposed CLT soffit, absolutely sort of flew out and was a license fee rent that we couldn't have anticipated. So the next time we had a building to work on where we had a sort of, cut and carve roof extension, opportunity to build a 4-storey front extension as a bolt-on to reposition the building, we did it out of timber, and again, that portion of the building went first and went at the best rents in the building. So then when we had our first ground-up development, which is the black and white building in Shoreditch, the brief really was always going to be to build it in as much timber as possible. We didn't know then quite that it was going to be such a sort of pioneering, tallest mass timber office building, but a few months away from PC and already getting huge interest and excitement about the building.
Great. James.
Hi, everyone. I run a team of about 20 engineers at Elliott Wood. I'm a structural engineer. I have been involved in the timber industry for about 10 years now. And it was touched on earlier, the kind of narrative behind timber has changed a lot in that last 10 years. It is a very exciting material to work with. 5 years ago, the door was starting to open with clients and larger projects. And the industry was really building up a head of steam about maybe 3 years ago. A couple of years ago, beginning of 2020, things changed quite dramatically. And the last couple of years have been a real struggle, I think, to get the larger commercial schemes, the larger projects through from a timber and fire perspective. So we're working on a lot of projects in the office at the moment. Probably about 15 of them, all at different stages. And the one that's probably most advanced, our Berkeley Square project, it's on site at the moment, and we achieved compliance on that about 6 months ago, I would have thought. We had a lot of learning and a lot of bringing together kind of experts from across the industry, not just in the UK, but also further afield in Europe and America. We've managed to solve a lot of problems that we're probably going to be mentioning today.
Thanks. And Caroline.
Good morning. So my name is Caroline Hess, and I'm Head of Construction and Latent Defects at Aviva. I've been involved in the sort of mass timber building space for about 2 to 3 years. Aviva is one of the largest UK insurers of property developers. We also have a large investment arm as well. And to be honest, it is a challenge insuring some of these mass timber buildings. So we're trying to work collaboratively with our developer clients to find solutions to use more timber. Aviva are committed to being net carbon zero by 2030, and that's all the way through from our investments through to our insurance products. So it is very high on the agenda for us to work with people like yourselves to find solutions.
Great, thank you all. I'm going to pose a few questions, and anyone else who wants to jump in, by all means, I'll start to direct them just to get to a wide perspective. So the first one, Ingo, I'll ask you, what role do you see timber playing, mass timber particularly, in getting to our 1.5 degree targets, and what are its opportunities?
Well, it's absolutely critical when we compare it to other materials. There isn't a material like this which isn't just low in embodied carbon in the first place, but also triggers this regrowth of forests, which probably in the lifetime of that product creates another couple of trees which will take carbon out of the atmosphere and passively continues to improve the situation. There is nothing like it, so it'll have to play a huge role in terms of the quantity. Can we build everything from timber despite all the other struggles? That's a really important question, and it's probably not a solution which avoids us trying to make other products more sustainable, like concrete, which is making big steps in the moment. And we found at times, depending how you calculate it, concrete becomes very competitive against timber, actually. So it's not the only solution, but it's a super important solution which is totally underrepresented.
Kelly, yeah.
Can I go? I think we're in a time right now where we're at an emergency, and the carbon saved today is much. much more valuable to us than carbon saved in 20 years. So we can't really wait for concrete and steel industries, hard to abate industries, to get to a 0 point. I mean, that needs to happen because we need to still use those materials to their best, their best endeavours. And we still will be using those materials, perhaps in hybrid products with timber. But there's a huge lack of knowledge in the industry, whether it's architects or engineers or clients or everybody. And this is our time for everybody to get up to speed. We can use timber now on our buildings while that carbon reduction is its most valuable, and we can learn and then use it as appropriately as possible in future when the other materials start to catch up with its benefits.
Thanks. So following on from that, I guess question for you, James, how would you describe the difference between CLT and mass timber from our traditional understanding of timber construction? How does it vary? And I guess for a new audience, what are its distinctions?
I mean, I would describe the difference between stick system timber and CLT as timber has evolved in its technology. You can use it for plates, so it spans in 2 directions. It's much better on site because it's quicker, it comes panelized. And when you talk about fire, it's completely different, the narrative that sits behind, or the difference between how you explore the design of mass timber and stick system timber. There's a good analogy. Trying to set fire to small bits of wood, relatively easy, but going up to a tree and trying to set it alight is much, much harder. And that is very much the way we should be viewing the perception of risk when it comes to timber and fire. It's an evolution of the technology.
Great. And Caroline, what do you see as the main challenges, the main risks that the industry needs to be aware of and needs to be preparing to find the solutions to if we're going to increase that widespread use of mass timber?
So I think, the safety side is talked about a lot in terms of, are these buildings safe? And from a life preservation perspective, they are. From an insurance perspective, when we look at the material damage side of it, there is still the fear that actually these things do burn down. It's still made of wood that is flammable. There are lots of arguments to say, well, it's a plug-and-play system. You can take the bit out, you can replace it. Again, the understanding around how that works in reality. The material chars, it doesn't burn. But which structural engineer will sign off if it's been charred 3 millimeters versus 5 millimeters? Is it still safe? So the key from our side is really getting in at the early stages of design and working with the clients to look at how we can make it, say from a buildability side, off-site construction modularization helps. You're reducing the amount of hot works on site. The escape of water is a challenge with mass timber as well, so limiting that. So it's really engaging early, using a professional broker to work with insurers, to look at the risks through from design, build, and end of life as well, through operational. The operational side is a challenge in terms of the occupancy. I think we're starting to get comfortable with the use for commercial buildings. I think residential's a way off. Particularly when you look at breaching the integrity of the building, you'll start drilling holes, and that increases the fire risk as well. So,
and how much of that is coming down to perception? How much is lack of knowledge, lack of data? Are there gaps in the industry that we need to be filling to help bridge those concerns?
It's a bit of both. There is an increase in knowledge, I would say, but the reference point that people go back to are some of the high-profile fires. The University of Nottingham fire is one, and insurers unfortunately have very long memories when it comes to this. And there is a lot of work going on. There are lots of bodies. The Risk Authority has recently published their white paper on mass timber. The STA has got the 16 steps, which is helping us for information gathering. And we are trying to work closely with clients. We acknowledge that this issue does need addressing, and we are one of the blockers to it it progressing quicker than it is.
Great. And Sam, from your perspective, how do you describe the design process? So undertaking the design of a timber building compared to a more conventional building. How have you, for anyone venturing for the first time, how would you describe the things to be aware of?
Yeah, I think for us is the sort of the fact you're doing something slightly different, the sort of more probably focus that goes in at an earlier stage to making sure that you're working with people who've been there, learnt lessons before, and can guide you through it. And yeah, I mean, the engagement with the subcontractors probably started happening at around stage 2 of design. And certainly as clients and developers, we're not as close to the detail as the whole sort of front-end specialised design team, but there's far more conversations that you're having, actively challenging things and wanting to make sure you understand the design process, certainly than a sort of steel or concrete building would do. And
you're making that decision to move into timber at the earliest stage of a project, so before you've assembled a team, before you've assembled your expertise around the room.
Yeah, I guess sort of briefing stage, particularly for the black and white building, we were looking at something that was going to be a landmark thing for us as a flexible workspace provider, developing our own building out the ground, and knowing that we wanted to do something, we owned the building directly opposite it, which was great, but knowing that you've got an opportunity to build something that had a sort of an existing, a buildable scheme, but not a particularly good scheme, so a full sort of steel, aluminium facade, something that looks like it should be a standalone feature building in the city, not something in Shoreditch. And we wanted to go to something that felt like it sort of met the more creative, sustainable target audience in a Shoreditch area and fit with our sustainable branding as a business. And yeah, so I think we knew from the outset that as soon as we acquired the site, that after doing a sort of short-term meanwhile use for a couple of years while working up planning out the existing building, we knew that timber was going to be the brief.
Great. And Ingo, from your perspective, from a designer's perspective, again, how does that design process vary from using traditional construction?
Yeah, I think one issue, and also to the insurance and other aspects, is that there's total lack of knowledge and also differentiation. We just talk about timber structure and timber cladding. Alone in the structure, there are many different ways of doing mass timber structure. Some use glue, some don't use glue. And when it comes to cladding, I think there are differences as big as using aluminium or brick. I think a timber is a bit like a chameleon, partly because it changes over the lifetime. Buildings change appearance. But it also comes in so many different versions, in different ways. For example, let's say an Accoya modified timber coated, I think it has totally different requirements to detailing than untreated Western red cedar. It's like you thinking about brick or aluminium, and that knowledge needs to be there to detail these products properly, to relieve the client's worries about how will it look, how will it age, how will I maintain it. And it's great that we have a conference just for timber, because it's basically just saying like we have a conference for cladding. And within that conference we can have all these different ways of using timber in the facades. So I think it's lack of knowledge and generalization of this product, which we need to change massively.
And Kelly, from an engineering perspective, again, when you're approaching a timber building compared to other conventional materials, would you approach it differently? Do you find that there's known path, known data, or again, is it an expertise that just needs to be further grown within the industry?
I think the sort of structural engineering of timber and engineered timber and mass timber is well known. There's lots of products. CLT is a product rather than a material that we can design from a Eurocode at the moment. I think the Eurocode is being updated to address that, and CLT is becoming more standardized to also enable that to happen. But it's no different. We have to be able to design other materials. It's just that most people, of my generation weren't taught it at university, and so we have to get up to speed quite quickly on it. Luckily, there are quite a lot of universities now teaching timber, and so that's coming more naturally to the graduates coming through. But generally, I think that the early engagement of the subcontractor is a really key one that Sam mentioned, because with engineered it's an off-site material construction process, and so the logistics, where you store it, how it gets built, if it's a just-in-time delivery, the member sizes, the craneage, the connection points, are all really important, and you have to understand that as an engineer at the very beginning of the design, which is probably something that you would leave to a subcontractor on a steel building, say, that would be dealt with later. So yeah, thinking about the connections very early and thinking about how it's going to be built very early is much more important with a timber building.
Okay, and on that point, James, should we be thinking about all timber buildings, or should we be thinking about timber being a component and a growingly more substantial part of a building? And where do you see that idea of all timber or hybrid timber being part of our lexicon of buildings?
I think there's a place for both forms of construction. Generally, when you need to bring in steel, you're opening up the grids. There's a very interesting conversation happening at the moment about the size of grids. Generally, when you talk to an agent or you refer to BCO, the larger the grids, the better. But actually, that goes completely against sustainability kind of credentials. And so you need to have a sensible discussion about the grid. Something that's slightly more, say 6 or 7.5 meter spans is much more positive when it comes to designing a material. So I think designing with timber, you need to understand its strengths, but also its weaknesses, so you can get the most out of it.
Fantastic. And Caroline, as we started the day today, we acknowledge that the UK perhaps is behind in the uptake, and perhaps that's down to the way that the codes have evolved in the last few years. I mean, how do we try and learn from our neighbours, whether it's in Europe, whether it's in North America, or other regions where there is more timber? How can we get data that can be better accessed, can be better shared, whether it's testing, whether it's fire risks? What do you think we can do to try to look beyond our own boundaries and learn from what others are doing?
Gosh, that's an interesting question. So, I mean, in the US, they use a lot of stick construction, I've just had a message through today to say there's been a fire on an apartment block in Oklahoma, and did we write that risk? And I think that's where we as an insurance industry are taking some of our knowledge from is what's happened there. Scandinavia builds a lot of buildings out of timber, but we don't really have access to that data. Collecting data, even just from the UK, is quite a challenge. So there are various groups. The Loudest Foundation is one that's trying to really tackle this and try and connect all stakeholders in this to bring them together and share data and knowledge. Within the UK, there are a couple of groups. There's the Mass Timber Know-How group that's been established. And again, it's really through events like this and connecting people that we can try and share the data and the knowledge.
And Sam, as a developer undertaking a timber project, again, there aren't that many data sets to work on in terms of program, in terms of cost, in terms of risk. So how, as a developer, do you try to get more certainty, get more information at the early stage so that you're not dissuaded by the idea of delving into the unknown?
I think we had, again, sort of the selection of the team. We worked with a QS who'd done quite a lot of work in timber previously. So from a sort of, program buildability, prelim savings opportunities, comparing it against the cost of a steel and sort of METSEC slab system, we had quite a sort of good sense of where the cost to actually construct it was going out. Insurance-wise, I think we sort of, we committed to the project and got planning probably around 2017, 2018. I think the market probably has moved in terms of the premium. The question is just, what sort of value do we feel we're getting out of the end building to justify that premium cost? And I think we're confident enough that the quality of the building and the rents that it's going to achieve are justifiable to justify the cost of the insurance premium.
And you're finding that there's now better data from whether it's the cost estimating or from tendering departments or from agents to understand that value, that risk profile? It's
a tricky question to sort of, it's one of those ones you can't really answer. What in a given building of a given quality in a given location, how much more does it achieve in timber as a product than it would in steel and concrete. You can't know because you can't have the two things coexisting. And there's relatively little evidence, I think, of timber office buildings. I think ours is more sort of faith in our own experience in, I suppose, seeing within a building that we did in King's Cross and one in Borough, that the sort of timber areas of the building have got a premium. Again, it's difficult to sort of be totally confident that's the sole cause, because they also happen in most cases to be the top floor. So I think sort of, our faith and confidence is that it delivers a product of a building that adds a lot of value, and that is really popular, particularly with sort of, during the pandemic, wellness obviously became a sort of a thing that's forefront in occupiers' minds more than it has been in the past, and sustainability after COP26. So what we've sort of found as a business with having circa 50 buildings in London is that in the past you'd probably get 10, 15, maybe 20% of inquiring clients would have sustainability being in their sort of top three things. Now it's 70%, 80%, it's right at the forefront of any occupier's mind about how sustainable a building is, and something that is visibly sustainable with the sort of, the narrative of some of the things that Anthony was talking about at the start of today. The sort of that cartoon picture I've seen doing the rounds on LinkedIn, and it certainly, there's a strong perception. I think originally occupiers would sort of go, well, it's counterintuitive. How can it be sustainable that you're chopping down trees, and that's a good thing? But the sort of sequestration and the fact that it leads to greater forestation, I think that now is really understood and sells well.
So the question is no longer just about energy and people looking at their energy costs and predicted energy for buildings. There is a more intelligent demand. There's a more intelligent debate about sustainability that isn't just about that figure of operation. It's actually about the carbon. It's what goes into the building. Yep. It's what benefits it brings from a well-being and health perspective, and a more global picture of what timber can do, which is great. And Kelly, as an engineer, can we learn from other countries in terms of how they're advancing details, what they're testing? Can we bring any of that data back to the UK and learn from that as well? Or is that difficult because of the way that the fire regulations vary from country to country?
Yeah, it's a really interesting one. I'm working over on a university building in the States at the moment, and mass timber has just absolutely exploded in North America. They're doing it more and more, and they're becoming very sophisticated actually in the rules that they're setting for it. So it's been really interesting. We said earlier that the UK is the most stringent in terms of fire regulations, and it is in fire. But actually the building regulations in the UK were written to encourage innovation, and they're not actually prescriptive, apart from the new Grenfell cladding rules. But then I see over in the States, there are very prescriptive building regulations, and that's actually been a bigger benefit in, which is, strange to me, but there's actually a whole set of rules over there that my building is this high, there's this number of stories, I know that the cores can't be combustible, and the facade can be timber, but on the inside it must be have a non-combustible lining, and I'm good to go. And I know what I can design for, and I know that I have to make sure it chars for 90 minutes in certain areas and 60 minutes in other areas, and there's very well set out rules. In the UK, we just don't have that at the moment. There's so much unsure, building control officers, approved inspectors, insurers, warranty providers. They don't really know what the rules are, probably because we have this sort of innovation-led regulation, but this counterintuitive hard ban. And then that's only really for residential buildings, but it's being, in the public perception, it's being carried over to other buildings as well. Commercial buildings, educational buildings, etc. So it's from my experience, I'm kind of hoping that we get in the UK to a point where we have some of these rules, because it's actually, it's actually much easier for people to understand and to be comfortable that they're designing a safe building when we have them. And I think the Structural Timber Association you mentioned earlier, they have been working with OFR fire consultants, and they are starting to pull together a flow chart of rules. Is your building over 11 metres, 18 metres, is it commercial? Does it have sleeping accommodation? Then these are the ways that you should design it. And that's based on a testing regime. knowledge gathering from all over the world and a testing regime that's going on at the moment with, I think, Stora Enso, Trada are involved as well. And I'm hoping that some of the outcomes of that and from tests that have been done on other developer-led projects, as soon as we collect all that knowledge, we can get to a point where we have some of those rules and it starts to unlock.
Fantastic. And Caroline, tell us a bit more about the role that an insurer can play to help unlock these at the early stage of a project and help to move a project forward and help advance the design. What do we think? How can we change our mindsets as designers in how early we introduce an insurer?
It's early engagement. I think, insurance always seems to be the last thing that's thought about, and more often than not, we're being presented with details on a Friday, and it starts construction on a Monday. And it was great to hear, actually, from Kelly about subcontractor involvement at a very early stage, because that's our biggest fear, is the subcontractors and the control of them and the risk management of those on site. I mean, fire is one thing, but escape of water is another, who's being used on site, how they're controlling everything, that knowledge is so important. I mean, there are specialist brokers out there, there's one here today, who are involved in this and seeking that advice. They are getting the knowledge and they know who to go to market. And working with your insurer and your broker through from the feasibility stage. I mean, I've been working on a developer at feasibility stage concept, what they think about doing. We're putting our thoughts across, concrete podium, concrete core. That really helps. It reduces some of the arson potential during construction. It also helps with that sort of evacuation, life preservation piece from our side. The fire brigade has a big part to play in this as well, and how they will respond to a fire on site. Again, that's all about life preservation and not saving of the property and the material damage. So really, it's just, as soon as you're thinking about using mass timber, be it a new building or, as we talked about, the reuse and repurposing of buildings, and we're seeing that a lot more, is the addition of CLT flooring in existing concrete or steel buildings, the envelopes as well, additional floors on top. As soon as you're thinking about using it, just engage with an insurance professional and get their advice and guidance.
And Inga, how have you found that in your work when you've had that early engagement? How has it varied the way you'd approach design compared to projects where perhaps the insurance discussion comes much later in the design process?
Well, from an architect's point of view, it's a tricky situation, because very often in the past we would design buildings which we know are compliant. Clients would expect that they get a compliant building and would at some point engage a discussion with insurers to insure the building. And it's obviously, well, we can maybe, for architects to engage the insurers doesn't quite make sense. So we need to, so suddenly on us a task to educate the clients to get this discussion going early on, which is very difficult if a client doesn't care about what the building is made of. But we now increasingly have clients who are very aware of the issues we're facing, that we have to reduce embodied carbon, and who do like to use timber as a material. And that starts to help, that we can bring up that discussion right early on. It's still difficult because timber offers this huge, like I said, this huge range of ways of using it, and regulations are so flexible in a way. That was great for a while, but it's now really difficult, because do you specify a closed jointed timber cladding or an open jointed timber cladding? Has massive differences in terms of how this fire spread might perform, and you need to talk about all these variations early on if you want to give an insurer confidence, and that's not how the traditional design process, I think, works. So there's quite a few changes needed. Or we get more rigid regulations like in the US, where somehow we can still say, the building will be compliant, and when then the client comes to the insurer, says, well, it's a building in timber, following XX regulations, it's clear to the insurer, yep, we know what we're dealing with. That works better. And I think the US seems to be getting that right now. When we did the buildings I mentioned earlier, 10, 15 years ago, our colleagues in the US were, I think they were mainly puzzled that we were cladding a building fully in timber, a science and laboratory building, or that we were building the walls out of cross-laminated timber. They weren't doing that at all. Now it's flipped. We struggle much more here, while they really it's really taking off massively. So we have healthcare buildings there going up in throughout in timber construction. Even in Europe, I think that's still a problem. So maybe sometimes we need simplicity. Despite early engagement, I think it's better to have a simple set of rules people can follow and have confidence in. Early engagement can only go as so far.
And so whilst insurance often focuses around the things you can't do, have you found as a developer that discussion actually starts to unlock ideas of things that you didn't think you could do before, that actually it opens room for innovation and creativity as opposed to simply setting out the blockers that might be in place?
I don't know. I don't think in our case. No, I think we'd sort of come to the insurance conversations probably after committing to the scheme. So yeah, I don't think our sort of engagement didn't go there. I think it will in future projects.
And James, we've spoken about having conferences like this that brings the level of awareness and brings people together to talk about timber. In academia, in practice, where do you see the level of education? Where do you think the gaps are? What needs to happen for this to become not just a niche area of the construction industry, but to become more widespread?
I think collaboration needs to happen much more thoroughly across the industry. There are pockets of expertise across the industry, but that is not rolled out across the board. And I think if we're going to get to a situation where timber becomes mainstream as a material, we need to upskill and educate everyone across the board. Otherwise, we're never going to be in a position to be able to compete with, the steel and the concrete industry. We find on projects that the best way to keep timber in a project is establish a very, very firm narrative of why you're using it, and then establish that it is the best option for the project rather than the most sustainable option. And I think if you can establish that and you can upskill the level of education across the industry, it will be a very, very good start. I mean, talking about the insurance industry, we absolutely went out of our way to take insurance brokers along the journey on our projects, and it wasn't just a one-way street either. There was a lot of learning done by us as well about what is looked for, what is preferred, and we adapted our design along the way. So I think while there is definitely an argument for simplicity, I think that bringing more people together at an earlier stage, going out to the market for contractors and buildability, bringing in the insurance people early, it's definitely a good way of building up a more robust project and design.
Fantastic. And Kelly, we know that our buildings have to be safer. We know that our buildings have to be more sustainable. Often there can be times when those two desires, those two requirements come into conflict. So how do we try and address that? Continue to make buildings safer, but continue to make them sustainable.
I think all buildings have to be safe. That's on number one. I feel that the way that we need to go is perhaps with the off-site model, because then we can get that QA process in check. We can ensure things are signed off. There's the proper level of critique from everybody. The design team can go and see it before it's installed on site. We've come as an industry away from some of the health and safety procedures that we used to have. Having a clerk of works on site, for example, having peer reviews of the design. I think all of those things need to start coming back in a way. I don't want to create more fees and more for you, Sam, but I think everything's brought down to the wire, and perhaps that's just the economics of the industry and something that needs to change there, but we need to be more sustainable and we need to be more safe. And I think that QA and checking and offsite gives us new opportunities for that, but that's the way forward.
Great. Well, we've got a couple more minutes. I'm going to ask one last question for everyone to answer. What advice would you give to someone who hasn't undertaken a timber project to inspire them to take that leap into the unknown and to really make the most out of that opportunity? So I'll start with you, Ingo.
I think first thing would be a degree of research and communication with just go around, look at projects which have used it, talk to. I mean, yeah, you need the expertise and the knowledge. You cannot, especially in the current regulatory requirement climate, you cannot, as is often done, especially by architects, just say, "Oh, I think I use GRC. It looks really cool on that building," and you will find a supplier which will give you all the knowledge very quickly. It will give you, make sure that's certified and how it's detailed. With timber, you have to go through a longer journey. You have to really understand the material, understand how it's worked, how it performs, how it ages, how the different species are reacting. Like some are more form stable, some are less. You have to become a bit more of an old-fashioned, I think, designer who really knows what they're dealing with, rather than just picking a product from a catalog. So, yeah, hopefully long-term maybe that changes. Maybe companies can provide systems, especially with the off-site construction where it becomes easier, where you can just pick it. But in the moment, I think it's super important to just research, just talk to people and understand what you're dealing with.
Kelly.
I completely agree with you. I think go walk around a building that's being built out of timber tomorrow, because it smells great. You want to touch it. You get the bug, and then you want to learn more, and you find out about other species and other ways to connect it. And yeah, as Alan was saying earlier, you become very passionate about it very quickly. So that would be my tip.
And Sam?
Just one of the bits that Kelly was saying before about the peer review. I mean, we wanted our hand to be held through the design of the building, so we ended up, as you joke about the fees, we ended up paying quite a few peer reviews, and that was all focused around the life safety, because that was, there's the perception that they're not as safe as, from that perspective, as other types of construction. So we really wanted to make sure that we'd had multiple opinions about the specifics of that design. The insurance bit we didn't do at the front end. It wasn't sort of talked about as widely as it is now about early engagement with insurers, and I think we probably could have mitigated the premium that we're going to be paying to some degree by some of the input that we could have got. And I've seen recently, I think some of the work that's been done by Aviva, I've sort of seen being talked about, and yeah, certainly much more information out there to sort of prompt you to engage with the right brokers and the right insurers at the right time and look at how you can reduce some of that premium. So yeah, it's
great.
Interesting hearing everyone's insights that I've sort of heard in the preparation for this panel and then today are things that I think will be useful for other developers building in mass timber.
And if it's the last few seconds for James and Caroline yourself, just words of inspiration for others, what would you say?
Oh, wow. I think timber is the future of the construction industry, and while we have quite a few hurdles placed in front of us, we have to stick at it. We have to solve these issues in front of us, because in 5-10, if we're really serious about meeting targets in the future, I think timber has to become a mainstream material that we build from.
Great. And Caroline?
Absolutely agree with what James says. We can't ignore this. We have to start looking to build in timber, and we need to work collaboratively to find solutions at all stages of the life of the project.
Great. Well, thank you all, and thanks all for listening.
Okay. Wow. Some great insights there. I'm really glad that the insurance people are coming to the table as well. I think from my own experience, I'll mirror James's comments, that it's a two-way street. You do learn quite a bit from insurers and what the risks are from their perceptions of it. We do have our next speaker is Daniel Bosia from Design.
Yep, I think it's not a break till then.
I know. It's not quite a break yet, guys, just so you know. Our next speaker is Daniel Bosia, Design Director from Thornton Tomasetti, and he's going to talk about lightweight timber roof envelopes. So, Daniel. Hi. Hi.
Hello. Turn the mic on. Yeah, hello. Can I request all of you to please be seated? It's not the break anymore, so that the next presenter can get started. Can I request all of you to please be seated? Guys, can I request you to please be seated? We're just starting. The session's not yet over. We've got 2 more talks. Right, Daniel, over to you.
Thank you very much. My name is Daniel Bosia. I'm a director of the Thornton Tomasetti office in London. I'm a structural engineer and an architect also by background. Today I want to talk a little bit about work I've been involved in with timber, and in particular in timber envelopes. This is one of the projects, I think one of the largest projects in this country using what I would define mass timber. You know, although it's a stick system, some of these members are sort of the size of a tree. So this is the debating chamber of the Scottish Parliament. And what I just want to point out in this project, which was started in the late 90s and sort of was completed in the mid-noughties, is that there's always a combination of timber with other materials. So obviously, you know, the prevalence is timber, but you can see that the material is used for its qualities and for its properties. So the timber is used in the compression zone. The steel is used in the tension zone. There are other ways of constructing timber apart from what we've seen, you know, stick systems and CLT. Stress skin construction has been borrowed from the boat industry, for example. This is one of the projects for the temporary project for the London 2012 Olympics, and then spliced together on site. And as you can see, you know, all of this courtyard would have been sort of, you know, cold and full of snow during the winter. Now, you know, it will become a completely different space for a completely different use as well. One of the typologies that structural engineers we've always been fascinated with are grid shells. And grid shells are compression structures, very lightweight. You know, of course, you know, the classic example is the Mannheim grid shell by Frei Otto, which is basically using timber in a fairly agricultural way, if you like, but in an extremely lightweight and efficient way. What we wanted to see is whether combining it with other materials like steel, we could really make the most out of the qualities of the material. So when you look at an eye section, you know, the top and bottom are working a lot harder. And therefore, what we decided to do is to sandwich very thin steel plates with a web of timber, and creating a very similar effect to what Frei Otto did in his Mannheim project, but at the same time, you know, in a more lightweight and efficient and hopefully sustainable way. So where we are creating hybrids which are even more efficient than pure timber structures. The advantage of this is as well that the joints, which are usually the most complex and expensive parts of a timber structure, are very simple. Joints are basically just not structural. They pass each other. Members pass each other. So we've carried out, obviously, when you design a grid shell, you have to make sure that the form is perfectly form-found and as efficient as possible. There is a tension, obviously, between always an efficiency of form in terms of structure. You want to create the perfect catenary. And also from a cladding point of view, because obviously curved cladding is a lot more expensive than flat. So we found, through a form-finding process, a good sort of medium between those and optimized this structure, creating what maybe is a kind of reinterpretation of a sort of Victorian system, combining materials like steel and timber into a sort of contemporary interpretation. And of course, this is I'm not going to go too much into the performance of this roof structure, but again, it is a breathing structure with a perimeter operable vent that allows both smoke exhaust and hot air exhaust. We looked at very closely at the method in which it's constructed, both in the factory, where it's all pre-assembled on the shop floor, by layering the steel and the timber over a series of props, how this is tied together by a perimeter member. Again, steel is more efficient in this particular case. And then how ladders could potentially be prefabricated of, as a kit of parts and can be assembled in a very efficient way. All the connections are bolted, obviously, as a kit of parts, you want to avoid any welding. So again, the timber allows us to spread the connection along the length of a member through a number of different screwed connections, as opposed to a very heavy, and expensive connection, which is what, traditional timber stick systems were, like in the early Scottish Parliament example that I was showing. But we've also tried to scale up this principle and started looking at larger structures, because obviously timber, especially when combined with other materials, is very efficient. It's also very lightweight. So in this project, we were looking at whether we could create a whole arena cover out of timber catenaries. It's actually not just simple catenaries. It's a sort of saddle shape, which means that you have tension and compression members restraining the catenaries against the wind uplift. And what we sort of managed to engineer is a structure that can be built as a series of strips, which are sort of craned in and sort of laid almost like a basket. There is the use of steel as well in some of the connections where the forces are larger, but this is distributed along a length of a timber member. So we basically create a composite material of steel and timber in certain areas. In some other areas, the timber does the work. And timber hybrids have been used in many different ways. We've seen also in commercial buildings. This is the Bloomberg headquarters we mentioned earlier. It does actually have elements within it, not of the primary structure, but it has this sort of atrium space which is completely enclosed within a stress skin construction, what we call the vortex element. And more recently, I'm sure Andy will talk about this more later, is the Google headquarters, which is, again, a very sort of an example of a hybrid where you have a steel primary structure and timber floors hanging from that. In Milwaukee, we're working on one of the tallest, if not the tallest building in the US at the moment. It is also a hybrid because it has a concrete base, and then it goes up I believe 25 stories, and it's one of the examples of mass timber in the US that we're currently working Here in the UK, we've been looking at the Santander headquarters, which I think is the biggest timber hybrid workspace on paper. It's a complete kit of parts, very, very simple. Again, we talked about spans and grids. It is possible with hybrids to get the best of both worlds. So create a very flexible space, which on the long term gives you maybe the flexibility of a building, the adaptability of a building with different uses, but at the same time with a large component in timber. And we've done a lot of these assessments, to get to these conclusions. What we find is sometimes, when combined with other materials, like steel, timber is the preferred option. We have to look at everything, at the manufacturing, we have to look at the transportation, we have to look at the construction on site. And when you combine all of these, the answer is not always the most obvious. Again, we are always benchmarking against different and projecting, in the future to see where we are in terms of embodied carbon, because that's one of the things that drives the sustainability of structures these days. And of course, we always look at sort of scaling up. This is a project which I was involved in. It's Gardermoen Airport, which is the Oslo Airport, basically, which is a large span timber glue-lamp structure, over 40 meters in some areas, with stress skin panels as a cladding material. And more recently, we've been working on this competition for Brno Station, which is a complete timber structure on the scale of infrastructure. So it's from a concrete concourse. We're building these we're proposing these timber tree structures, which then support the CLT deck, which effectively acts to bridge across and the city, reconnecting the city, which is divided by the railway. So it really becomes a connection, it becomes a piece of public realm, it becomes a piece of landscape. Again, we can see that a lot of the heavy infrastructure below is a concrete system, but prefabricated, but above that we're making sort of very large use of timber. Making use of its lightness, its strength, its durability, and also fire resistance, because one of the main concerns in the use of timber in infrastructures like this is that is fire. The whole sort of platform area is also covered. In this case here is covered again by a kit of parts that that creates this sort of space frame responding. That is sort of shaped. Its cladding is sort of shaped to respond to solar exposure and so on. And even more recently, this is the Stockholm Station project, which we've recently won together with Fosters and Partners. It's a very large reinvention of a part of a city around the station. In fact, on top of the tracks, it's I think one of the largest will be one of the largest overrail developments in Europe. The station is right here at the front. The whole development behind is a mixed use of offices and residential. And one of the main, again, we are looking at a hybrid system. So the lower portion of the structure is a transfer structure in steel, which allows us to sort of tiptoe in between the tracks. And then above that is a complete timber kit of parts. So we can see here building up from the tracks to the deck. The deck is developed as an orthotropic deck, again, using other materials like steel and concrete. And then we have the steel arches, which then support a timber frame with CLT floors. The facade is also quite interesting because what this system allows us to do is to basically create a modular grid within which we can then have different options, of different materials. Some of these facades are timber, some are using bricks, some are using other materials. So as a kit of parts, the timber allows us to do that. It's completely off-site, prefabricated, as indeed the facade is. Thank you very much.
Thanks, Daniel. Some really interesting projects there. It's always good to see what's happening abroad as well as in the UK. Okay, we've got one more talk before the breakout session. That's from Martin Dexter, Head of Design, Research and Development at Schindler, Fenster, Thistleton. I'm going to read out the title of this. It's Sustainable Timber Composite Unitized Facade Considering an Optimized Goal Warming Potential for Use in Residential and Office Buildings. Okay, yeah, great. Hands over to you. It's okay.
Next back. Yep. So thanks for your introduction. We company Schindler are pleased to be able to act as a speaker here with the topic of unitized timber facade. We would like to show what is already possible with timber facade and timber composite facade. So Schindler was founded in 1931 as a small joinery, and we built facade and windows over nearly 90 years. So just a small time scale, 1931 established. In 1985, our first timber composite stick system was installed. In 2000, our first fully unitized timber composite stick system was erected in a building, and in 2009, our first patent for a unitized composite stick system and a fully unitized timber composite facade. In 2016, our first project with 1,500 square meters of fully unitized timber composite facade was installed. And just nearly to now, in 2020, our new developed unitized timber composite facade was tested regarding the IGT of 13830 and the CWCT sequence B. We also have developed an environmental product declaration and also tested the glass carriers and the corner gleeds. But before I talk about our unitized timber facade, I'd like to show a few projects which have been realized with prefabricated timber stick system. This project, Schulcampus Unterföhring, we have already delivered prefabricated, fully glazed, as you see on the right picture, fully glazed timber stick facade. The value was about 0.85. The square meter of the whole building was nearly 7,500, and the element weight maximal was 650 kilogram. We used laminated spruce and a triple glazed unique were installed. This slide shows Grundschule Kausfeld with a pine stick facade and vertical timber profiles with the requirement for fall protection. The picture on the left shows how the large-sized prefabricated stick facade were picked up by a manipulator, turned out of the transport stillage and installed. The type of wood was laminated pine, a value of 0.9, a total weight of 800 kilogram. And for this type of wood, of pine, it was not easy because it's a very soft wood with a low density, and you have to transfer the big load of the glass through the corner connection on the concrete. So it was a very interesting and nice project. These two pictures shows, for me, very impressively what is already possible in facade construction. Regarding this project La Lux, we have realized a fully unitized timber stick facade with 3 to 8 meters, fully prefabricated, triple glazed, opening vents, and also spandrel panels outside aluminum, inside in oak, with an value of 0.78. And the total weight per unit was around about 1.4 to 1.9 tons. In this project, our first fully unitized timber facade, we have installed elements with 1.3 meter width and a height of 8.5 meter, made of laminated spruce in 2016 with the area of 1,005 square meters, and up today, the facade works perfectly without any defects. But now, we come to my actual topic. Our timber composite unitized facade HMF 2020. Despite the very successful project with prefabricated timber composite stick facades, we require still a scaffold. We have seen it before on some pictures. We have seen a stick system with installation of a glass, and that means was it results that a lot of sensitive jobs has to be done on site. Bonding gaskets, installing of pressure plates, and so on. So this was the reason for us to develop a facade which can be assembled to nearly 100% in our production and can be installed in all weathers, also at minus temperatures, because you don't have to bond gaskets with silicon. When developing our facade, we imposed the following specification on ourselves. The mullion depth must be identical as for an aluminum facade, reducing the use of aluminum to a minimum. Damaged wood must not endanger the stability of the facade. U values below 0.8 must be achieved. Infills with up to 500 kilograms must be allowed to be installed, and important for us, the water tightness must be higher than 1,200 Pascal. Here we can see a horizontal section between the stack joint. We have different gaskets for accommodate tolerances and deflections, and furthermore, our system can deal with a glass thickness from 38 to 61 mil. The internal width is 94 mil, and external we have a width of 90 mil visible. Here we see a vertical section through our sash bar with an internal width of 65 and external of 60 mil. Horizontal section through our split mullion. The width of the butt joint can be 10. You can see it can be 10 or can be 20 mil. With a width of 10 mil, we have an internal width of the whole split mullion of 85 mil. So, for us, one of the important things, when we deliver facades or install facades, the facade have to be tested, CE market. So, when we plan our test mock-up, according to the N 3830 as well as CWCT sequence B, we wanted to test as many situations as possible in order to achieve sufficient safety. On the right top element, we installed a glass pane with 500 kilograms. On the left, the green marked, we installed a wooden window, and we installed also several spandrel panels, glass, aluminum, and also wood. So the pre-test was in November 2020. In the pre-test, we achieved a water tightness higher than 1,350 Pascal without any water ingress. Then the main test was carried out in end of January by the IFT Rosenheim in our test facility, and we also achieved a water tightness higher than 1,350 Pascal. We also passed the air permeability, the resistance of wind load, and also dynamic test regarding DIN 13850. Then we haven't had any facade element between January and October in our test center, so the facade remained installed in our test center. In October 2020, nearly 1 year after the pre-test, we tested the facade again, because it was important for us to get a feeling what happens when the wood and the facade is installed. We have different temperatures in our fabrication hall, we have different air humidity. If there is a change of the values we can achieve. But also, 1 year later, we achieved the same water tightness higher than 1,350 Pascal. Also, we reached the air permeability as on pre, as also on main test. And even on the main test, the wind resistant safety test was made with 3.0 kilonewton per square meter. That means there was a lot of deflection after the main test, and we also passed the facade test again. Here we can see a picture of the installed unitized facade in our test center. As I have shown before, the big glass on the top, different metal panels with glass and aluminum, and on the right, on the bottom, internal wooden panel and external aluminum cover. Some pictures from internal. We can see the stack joint with horizontal and vertical gaskets. Picture of the dynamic water penetration test according to CWCT. Water penetration test and picture of the soft body test. So here we can see what we have achieved with our HMEF 2020 facade. Air leakage higher than 750 Pascal, water penetration 1,350 Pascal, also repeat of water penetration, the same value, and so on. So now our facade is fully tested and can be installed on big projects with large facade volumina, because the test has shown during 1 year the facade works also with different climatic conditions and passed the tests 3 times again. So not only the testing according to CWCT is important, it's also the testing regarding the corner cleats and the glass load transfer. So in the test we have done on KIT Karlsruhe by Professor Bloss, the corner connection load was by maximum of 1.2 tons. So if we check the deflection with the glass load, we get the result that when we use a glass weight of 500 kilogram, we have a deflection of 2 mil on the horizontal profile, so which our facade can accommodate. So that's the reason why we allow 500 kilogram maximum glass weight per panel. One of our key points in the development of our facade was the statically effective connection between the aluminum profile and the inner timber profile. Because without the statically connection of these both profiles, we can't reduce the aluminum to a minimum. We are not able to have the same cross sections as a standard aluminum unitized facade. The result is shown on the slide. The orange horizontal line is a post length with 5 mm. If we make a theoretical calculation of our IX with the both profiles, we need a depth of our profiles from 290 mm. If you use a standard aluminum unitized facade, you need a depth of 175 mm to 230 mm, depends on the thickness of the profiles. If we now take into consideration our testing, then we can reduce the thickness of 205 mm. I think it shows very impressively that we can choose an aluminum unitized facade and can also switch to a unitized timber facade with the same width of the profiles. Isothermic profile, we have higher or more than 14 degrees internal, so no risk of condensation is also perfect what we achieved. And now we come to our environmental product declaration. The discussion about the reduction of carbon dioxide emissions is in full swing and becomes an important component in our facade and buildings. During the development of our EPD, these primary tasks were considered. Detailed consideration of the production process of the facade, inclusive data collection in our company. Consideration of the effects of the various surface coatings on the EPD. Consideration of the impact of the different types of wood on the EPD, and consideration of the impact of the various insert elements of the EPD. Our EPD includes product stage to use stage to end of life stage. We also check the benefits and loads from beyond the system boundaries. That means cradle to grave. The basis for our EPD was the test mock-up for our CWCT test, because our idea was to use a facade model which can be used in similar configuration at several projects. So here we can see the effect of the surface, and I think it's very, very interesting, this result. If we have a powder-coated 1 kilogram aluminum profile, we have 1.4 kilogram carbon dioxide equivalent. If we have 1 kilogram anodized aluminum profile, we have 5.6 kilogram carbon dioxide equivalent. That means for our facade, when we use a powder-coated surface, we can reduce our GBP of nearly 12 kilogram carbon dioxide equivalent. So it's for me very important, but for us that our EPD covers nearly all facade types, profiles and surfaces, we used anodized aluminum for the erection of our EPD. So here you can see the result for the product stage A1 to A2. Our facade have a GBP for product stage of 140 kilogram carbon dioxide equivalent with anodized profiles. If we choose the wood from oak to pine, have not really a big influence. Also, the glass, it's normal to use a triple glazed unit. Only a laminated glass have also a negative effect on our EPD. As I said before, if we now take into consideration all the improved characteristic values of the materials, then we nearly reach 100 kilogram CO2 equivalent of our facade. So, and I think this table shows where we are now. The red column is an aluminum stick system with an aluminum window. Here we have round about 253 kilogram CO2 equivalent. If we have an unitized aluminum facade, we have around about 230 kilogram carbon dioxide equivalent. If we use a timber composite facade, we have 140 or 102 carbon dioxide equivalent. It shows, for me, very impressively and very clear which facade in future will be erected. So, we heard, I think, 1 hour, 1 minute before, fire resistance, wood, everybody is afraid about it. It's, for me, an interesting test. It's a very old test, 1999. In this test, a 3-story high stick system was tested. The wood or the timber was laminated spruce, and a double glazed unit was used without any fire requirements, and on the second floor a wooden window was installed. Here we see a cross-section through the panel area. Only on the panel area, the plate was a Duri panel with an A2 grade, and behind the insulation was rock wool with a melting point higher than 1000 degrees. And also the connection to the concrete was filled with rock wool and a wooden stripe. The facade was installed on a continuous steel angle where the profiles are fastened. On the left picture, we see the burning chamber. The test has begun. And on the right picture, we see the facade after 33 minutes. What we can see, the glazed area is totally open, and the wooden profiles are burning. But we also can see there is no fire and no smoke on the level above. Because what's happened? Why was there no fire and no smoke on the level above? Just before I come to this, I go through the results. After 4 minutes, the first glass pane broke. After 6 minutes, the first parts of the broken glass panes at level 0 fall out. After 9 minutes, burning of the wooden profiles at level 0. After 40 minutes, breaking the outer glass of an DGU at level 1. And after 40 minutes, now we come to the result why 50% of the glazed area at level 0 are open. What happens? The temperature in the burning chamber falls below the ETK. After 30 minutes, breaking of the outer glass of double glazed unit at level 2, burning of the wooden profiles, but no falling of facade parts and no smoke, as well as no fire spreading to the upper floor. This is the temperature curve measured in the burning chamber. So we can see after 10-15 minutes where the glazed area was open, the temperature goes down. So thanks for your attention.
Thank you, Martin. That's really informative. We're going to have a little break now, so for about 20 minutes, so we can come back at 11:35 and we continue to talk there.
I'm sure you're all looking for a drink.
Hello. Yeah. So Schindler has a booth. So if you have any questions for Martin, Schindler has a booth outside along with other partners. We request you to please visit the booths. All of them are waiting to see you all. We'll come back here in 20 minutes, as Alan said, 11:35.
Accsys. His talk is about maximizing mass timber carbon benefits. So I'll come on the stage.
Okay, well, good morning. Nice to see you all. Just wanted to say it's quite exciting being in a room of non-timber people, or for a lot of non-timber people. As you mentioned earlier, it's been a small community, and I started my timber journey when I was 18, studying forestry, and then forest products and timber engineering, and gradually working in R&D. And it was always the prospect to try and get people who weren't naturally inclined towards timber, adapting timber into what they did, whether that was basic things like packaging or more advanced things like building envelopes. So just wanted to, that probably doesn't mean too much, but it's quite nice to be up here looking at an audience from this background. The first slide here, it just shows an image of a project that was completed about 3 years ago in the US. And it's the Oregon State University Forestry faculty building, actually. And it was, at the time when it was being designed in 2016, it was one of the, I think, perhaps the largest CLT mass timber building being developed. And they also wanted to extend the timber benefits of the skin of the building, so very much in line with what the discussion has been here today. And through it, I got to know the contractor fairly well, and he was a timber guy as well. He'd never worked on a timber project, though. And he loved the project and being involved with it from that conceptual stage, and not having a big network of people to rely on for input as they went through the design of the building. But he found one of the worst things of the project was that opposite here was the old faculty building, which they were knocking down and not repurposing. And the worst thing about that was as they were building it, they had 25 wood scientists looking at them, coming with a list of questions and questioning their methods in detail every morning. So they got through that in the end. He kept his sanity, and they developed a very nice project. And next door to this one, they have a very large testing lab, a wood engineering test lab, and that was also clad with Accoya, but they took a different approach there. For that building, they used mass plywood, which was a variation which was being developed in the US, and similar to CLT, but enormous sheets of plywood which were fabricated and more like a tilt-top type construction. So that's a short intro to that image. I think what I wanted to do was to introduce Accoya with just a few slides and not death by PowerPoint, and explain the origins of the material and why we feel it's well suited to being used in high-performance buildings with strict requirements as the building goes through its life. So I'll just move on, and I think we don't need to labor on this. What we're looking at is maximizing timber from the structure and then going out to the facade and also the windows and doors and interior fit-out I won't touch on. But the windows and doors is also another really interesting area, and there's a lot more design flexibility, a bit like with mass timber now. Evolving, one of the speakers mentioned earlier, timber building from sticks delivered to site and 35% of the waste being removed at the end. Timber windows have also gone through an evolution, and the picture on the left, not many would pick that out from a distance as being a timber window and door system. But through the dimensional stability now that we can get in timber products and the uniformity in the wood that they're made from, the window manufacturers, through their evolution as well in manufacturing and design capability, can develop a much broader range of product that suits a broader range of buildings, not just standard casement or stormproof white windows, but a much broader range. So I think the industry behind mass timber really helps you extend out the range of timber, and of course the amount of CO2 that can be captured in these type of buildings. So in my mind, and these might be different to yours, and we feel that these are very important, service life, the maintenance, and the design options. I didn't put fire on here, obviously. It is a very strict requirement, but we feel timber is combustible. It can be treated with fire retardant products, and after which it's still combustible, just a little bit less. So there are requirements that fire certainly comes into. One of the projects that we'll look at has been fire treated, but there's certainly limitations there that we have to operate in. So within that operating space, that was where I felt these were the three main requirements. And an example here of a timber building, this is in the Netherlands, where the walls and the roof at a school were clad with timber, and that's after 7 years old, and you can see it's maturing. It suits that setting quite nicely, and is performing very well, and has led, I think, to further developments at that school. So a timber solution that we'll just look into quickly here is a coir that's made from trees which grow in New Zealand and is put through a process in Europe through an acetylation process. And it's a product which has been tested very robustly around the world for 30 or 40 years now. So starting in forestry, New Zealand or the Southern Hemisphere, it's good and bad from a carbon perspective. The very positive part, or the negative, I'll start there, is that it's a long way away and boats are involved in transporting the material. The very positive aspect of it is that trees of 40 centimeters, so that type of diameter, grow in about 28 years. And they grow at a rate that allows them to build the same density in that stem, the 40 centimeters. So the per hectare growth of timber in the Southern Hemisphere, New Zealand, Australia, Chile, the amount of bulk it builds up, which draws down carbon, is a much higher level than what I was accustomed to when I studied forestry in the UK. It's approximately twice the rate of growth, approximately twice the build of density on a hectare of land. And if you compare to relatively fast European-grown forests, if you go to the slower-grown European areas, that's more like a rotation of 100 years. So the life of an Accoya Façade of 50 or 60 years is being replenished by 2 crops of this very fast-growing pine, and that, if you add the points up, certainly overcomes the transport quite quickly. The other aspect of growing trees very quickly is that you can actively manage them. So these forests in New Zealand are generally planted on marginal farmland, and the speed of rotation of 28 years allows that if you put work into the forest, there's a reasonable payback on that investment in time. So a common practice is cutting the branches off, pruning. And that's simple with one tree, but it's done on thousands of hectares of land. And it produces a product which, a log in the end, which is 40 centimeters in diameter, and you see the knots are restrained to this core. So it provides a lot of timber that can be cut off the log in a clear form and isn't subject to the problems of knots in terms of creating weak points and creating distortions in the timber. So in a very short space of time, you can grow a crop that has a lot of clear wood, which is uniform, which is what we need for some of these projects and advanced products that we look at. And it grows at a high rate and a high speed. And the downside of that fast-growing pine, though, is that it's quite dimensionally unstable. If you put it in water, it will swell. If you expose it to humidity, it will swell. Not dramatically more than a timber like larch, but enough that it causes problems in an outdoor application. It's also very prone to decay. It will rot relatively quickly. So we, in the manufacture of a product called Accoya, we take that product through a process which I'll look at a little bit further on, where we, at a molecular level inside that tree, convert the timber to be very moisture resistant. We go down to a cellulose level and convert that cellulose to being a very moisture resistant product. And then it goes through a series of tests that we set up some, going back 15 years now, but previous to us, the product, as it was developed through universities, have set up test fields and test exposures of the product, which go back 25 to 30 years. And we're able to harvest data from those as well. So the first step, looking into the sawmill, where the timber comes from, so the log goes in here. It's quite an automated well, it's a manual process, but with a lot of support to that manual operator in maximizing the clear yield of timber from that log. So the whole log gets used, whether it's the bark to the sawdust, but maximizing the clear lumber is the most important part to give the best value from that tree that was growing. The second part is the process, the Accoya process. And maybe before talking about chemistry, to give a little background of where the process came from, to give it a context, the process was not invented by us. It was first patented in 1928 in Germany, as all good timber products generally are. And then it was developed quite a bit further in the 1940s in the USDA at the Forest Products Lab. And there were initial designs for wooden planes to be made from acetylated wood, just at the turn of the Second World War. That didn't happen, and thankfully. The next stage of this process was in the manufacture of cigarette filters, which is still the single biggest application of wood acetylation in the world. The cigarette filters, like a tissue, are made from cellulose pulp. To prevent them from being water absorbent, they go through an acetylation process. And that's the cigarette filter that's in the garden for years is a good example of this process. It's a tissue which has been through the acetylation process. We worked to adapt that technology in the 2000s, early 2000s, to apply it to timber on a large scale. And we found some challenges in that, but eventually we found a way to do it on a uniform, scalable level. And we've been building up production since 2007. The process is non-toxic. The molecule which we add into that cellulose group is naturally occurring in wood. So the molecule we add, there's normally 2% of them in timber at the beginning. We increase that level to about 20%. There are no other components added into the timber. So when we look at performance in a moment, it's all coming from just augmenting or increasing the level of naturally occurring hydroxyl molecules that are in the timber from the outset. I always point this in the wrong direction. Yeah. Okay. So just a quick summary here, and we do have there's a little web link there if the presentations come out later, but on our Accoya.com performance testing, you find an awful lot of the detail behind these tests. The most important part of the testing is to make sure it is long-term testing. And we're fortunate that we set up some of these, but before us, a lot of testing had been set up by institutes and universities. So the example there in the top left, that's a standard European test, EN252, which was set up by the Building Research Establishment in Watford, BRE. That was set up in around, I think it was 1999 or 2001. It was last reported at the 20-year interval. And this test is set up where it's a mortise and tenon joint. The mortise and tenon joint is coated, and then the joint's opened up, the paint line broken. It's put back together with a loose fit, no adhesive or sealer, and then it's put on a rack with an incline of 10 degrees towards that joint, and it's left there, and the people at BRE or the institute where it's being run, they'd inspect that joint each year, looking for signs of decay. And these were laboratory-made pieces of acetylated wood with slightly lower specifications, lower levels of hydroxyl than that we use today. And after 20 years at the last inspection, they were still in great condition. There was no sign of decay in those. We can relate that to a window. A lot of wood testing is actually based on putting pieces of wood in the ground. And an example of a stake field or graveyard trial here. This data is just on the left there from New Zealand, and it's that graveyard data where we look at Accoya plus other types of timber. And the comparisons go beyond just untreated pine, which would deteriorate very quickly. So the comparisons in there are copper chrome arsenic, which was a very common wood treatment in Europe until it was outlawed. It's still used in New Zealand. It's a very good treatment. The other natural timbers in there are teak and western red cedar. And you can see the chart, what the chart's showing is that as time goes on, out to 10 years, the performance of the wood is rated on a system of 0 to 10, and 10 is perfect. And as time goes on, The Accoya wood is showing very little degradation. That's just the light coloring that's developed on the wood. No sign of decay yet. A durable timber like teak has deteriorated quite rapidly. And that type of application, a graveyard, is hard to relate to a window or a facade. But it is, in our wood world, one of the only ways that we have of comparing woods. And a timber like teak or western red cedar do have the benefit of a very long service life. So when BRE and Trada, who were mentioned earlier, run their assessments of how long an Accoya window or facade would be expected to last, they do look at this type of long-term field testing of the 10 to 20-year category, and they compare that to how other timbers with a service history, such as teak, have performed in those tests. And they're able to give not how long it will last, but a minimum of how long it will last. And that's in the 60-year service life category for a facade or a window. The other point, I won't go into lots of slides, but the other aspect of Accoya is it's very dimensionally stable. And that doesn't take 10 years in a graveyard to evaluate. A very common way of evaluating that is to put a piece in measure a piece of Accoya and then put it in a bucket of water and then take it out and remeasure it. And the dimensional stability is very strong. It's very similar to that type of scale where there's very little change, whereas even durable woods like western red cedar and teak have fairly significant change in those conditions. Coating lives are also extended, particularly by this dimensional stability. So I mentioned design options are really important. The coatings, Accoya can be used raw or it can be used with coatings. The coating life of it is extended by between 2 and 3 times because of the fact it's so dimensionally stable, and also helped by the fact that the wood doesn't contain the defects such as knots. And through the process, which involves high temperature pickling in essence, it removes the resin from the wood, so that isn't an artifact that can come out and disturb the coating layer. So we do, in the bottom right, an awful lot of testing. That's at our factory and our R&D center in the Netherlands. We do a lot of similar testing with some of the coating companies who are here today, like Accsys, Nobel, and Technos, and PPG. We also now have the benefit of some large projects where Accoya has been used and provide a real-life evaluation of the product. And it was mentioned there about repurposing buildings, and this was a housing association building in London, which is owned by the Poplar Housing Association. And I think it was built in the 60s, and it's a listed building, actually, because of the brutal nature of it. And the options for replacing the windows, which over time had become a mixture of wood and PVC windows, but were generally all performing quite poorly, was to go for an aluminium option or to go for a wood option. And wood was preferred for the listing and the design limitations, but the maintenance was an issue on a building like this, and the costs, of course, were an issue. But they did eventually go with Accoya, and I think this photo was taken this year, and that's after 9 years of service. And the windows were a little bit dirty, but they were certainly not in need of maintenance yet. And it's a good example of that retrofit, which was mentioned earlier, and how timber can fit with that. Just very briefly, the range of finishes. We have a couple of samples outside on the table, but if you're working with a facade manufacturer, there are a huge range of finishes available now, and that's been a dramatic development in the last 10 years. I'm sure you've all seen as well. Just a few examples here. This is a company in the US which uses a lot of Accoya for facades, Delta Millworks, and everything from burning of the surfaces now to burning, then brushing and coating, all sorts of combinations and variations of sawn-type surfaces. But there's an awful lot at websites like Delta and others which are available. And also, products like this are being made in the UK now and available for projects. The CO2 aspect of it, the Accoya process is intense. It does involve energy. And of course, it involves that transport I mentioned from New Zealand. There's a lot of information in this subject on our website, but where it sits relatively to non-wood materials and wood materials that come from a less sustainable type of forestry, it sits in a fairly good position still. And this is cradle to gate, so the gate being when it leaves our factory. So if you then go on to cradle to grave and taking account of reduced replacements, enhanced maintenance intervals, this becomes quite a good story. So we're not losing all of that benefit by the process we put the wood through. I'll just move on quickly now to a couple of projects, but I think maybe one note on each because some of them are being covered later. But there's a level of CO2 which gets locked in compared to the alternative for each of these projects. Another nice part of being used for Accoya is that there's also an MDF version of Accoya. So for this product, actually this project, we took the offcuts and they were used to make furniture around the campus. The Google project, which I think will be a feature later, but just one thing to mention on that was that the offcuts from that project from the factory in Germany were all taken to Ireland and used to make Medite Tricoya MDF, so another type of product which is used for facades also. This is a nice project in Finland where the two central buildings there are part of a development called Wood City, and the frames of those buildings involved a lot of LVL and glulam timber. The point to note on there is that those buildings, the timber was treated to a Class B to get past the fire requirements for the engineer. And just the final project here, which is not a facade, but the window elements of the accommodation pods at the project here by Wilkinson Air at the Dyson campus. And these windows and sections were not made in Germany, they were made in Scotland by a company called Treecraft and have been performing well, and they extended the use of timber from the CLT pods out to that window and door element, which looks quite well in place. And I think that's the last slide there. So thank you very much.
Thank you, John. I think timber and durability is always a great topic. And I know insurers are certainly interested in that, which kind of leads nicely into our next speaker. It's Dominic Lyon from Gallagher's Brokers. And Dominic's going to be talking about engineering mass timber buildings. All right, thanks, Dominic.
Good afternoon, everyone. How novel it is to be back on a stage and also to have an audience of this size for something about insurance. I'm going to pretend that's because you came just for me, so let's run with it. I've got 20 minutes to talk about something that I could probably bore your socks off for about 2 hours on, so forgive me if we whistle through. If you've got questions, my details will be on the last slide. Do take a picture, give me a call, drop me an email. Happy to discuss further. It's become overly familiar. So that's me. What we're going to try and cover in the next 20 minutes, who am I, so why am I here? I think market context is really important. I know we've had some sort of brief discussions in the panel earlier about insurance, but I think I'm going to try and take you a step sort of higher even and a step back to talk about the context, what the current challenges are, of which there are many, and then maybe let's try and touch on some solutions, some opportunities. I'm an optimist by nature, so I'll try and end on a positive note, and then I'll try and wrap it all up. Here we go. So who am I? Thank you very much. Who am I? So Dominic Lyon, as Alan kindly said, I'm a chartered insurance broker working for Gallagher. Before I got into the real estate world, which is sort of my day job, so to speak, I was in the construction world. My colleague Russ is here and is also happy to answer questions which I don't want to. So I'll line him up for you as well. I'm on the board of the Structural Timber Association. Don't ask me how that happened. I think I lost a game of musical chairs, but I advise them on what to do when it comes to insurance, probably quite poorly. I'm on the Timber Accelerator Hub and the Mass Timber Know-How Group and just about every other body where someone wants someone from insurance to come and take some stick. I seem to put my hand up for, so I'm on a number of those. And I've had 6 and a bit years of mass timber experience, I would say. So referencing back to a few of the talks earlier, my first involvement was on a scheme called Dalston Lane, which we saw a picture of, working on behalf of the contractor at the time, looking at the insurance of that. That was a very different marketplace and a very different challenge, but nonetheless opened my eyes to the opportunities with mass timber and equally some of the challenges. And that graphic at the bottom, I'm afraid, is about as exciting as my slides get in terms of who we are as a wider team. I don't think we're famed for our PowerPoint skills, so you have to bear with me and listen instead. But we're a big team based in London, 120 odd, including construction and real estate, focusing purely on those sectors from an insurance standpoint and advising clients of all shapes and sizes. So that is where we are. I stole this from a previous PowerPoint that I did because I'm lazy, but essentially I could have picked out any number of stories from the web. I think the point behind these is far more important. Basically, at a very simplistic level, insurers are fundamentally worried about fire and water. So I've picked out a fire example and I've picked out a water example. This applies both across construction and real estate or property. You know, yes, there are nuances between the two, but in essence, what are their biggest two concerns? Fire from a large loss point of view, and the ones that make the headlines, and as Caroline pointed out, they're long in the tooth, so they remember things like Nottingham, even though it was 8 years ago, and we can debate that at length. But actually, the sort of death by 1,000 cuts in the world of certainly construction in the last 10 years has been escape of water, bursting pipes. And I know that my loss adjusters and our guys involved in dealing with those types of things will thank me for saying that's actually the thing that causes insurers far more grief. They spend an awful lot more time on it, and ultimately is what's caused them to lose money over the last 10 years, is bursting pipes, poor plumbing, and again, I shan't delve too deep into that because I'll say some terrible things. But it's worth noting that those two are equally of importance to insurers. I know that the fire agenda is absolutely at the forefront, but as part of my work at the STA, we're very much looking in tandem at the durability piece from a water and wider standpoint in terms of how do these buildings perform over time, because we kind of know that that's coming. Dare I say it, once we solve the fire issue, that will be the next one that hits us. So that's kind of the context. And then what do we have going on in the background when it comes to insurance as a wider piece? Well, we have a hardening market. That just simply means prices are going up, unfortunately. Pretty much any insurance you're trying to buy at the moment, save for perhaps your pet insurance, prices are going up. Why is that? Well, in simple terms, it's because insurers are making losses. Some insurers are exiting the market altogether, and that means the remaining ones, in order to make money, put their prices up. It's a cyclical market. It will come back, but it's not at the moment, unfortunately. And I verified this with Russ before saying it out loud. To put it in context, if you were building a building 4 years ago out of steel and concrete, your constructional risk insurance premium would be somewhere in the region of 0.1%. If you did it today, you'd be somewhere around 0.35, 0.4%. So it's gone up 250, 300% in 4 years. That's in regular building materials or traditional building materials. So you can imagine why insurers then, when faced with something new, novel, different, suddenly get extra nervous, because in simple terms, they're not making money on the stuff that they thought they understood. So when you bring them something that they definitely don't understand, well, yes, you can kind of see the response. We've obviously got the tragedy at Grenfell and the kind of the playing out of that in the background. Insurers are still understanding, I think it's fair to say, what the full extent of their exposure and losses are as a result of Grenfell. I think, unfortunately, or fortunately, whichever way you look at it, Grenfell opened the eyes of the insurance market to the fact that they didn't necessarily know what they were insuring in a lot of ways. And they didn't really understand what the building industry had been doing for the last 15 years when it came to cladding systems and modern methods of construction. So they, I think, are still getting to the bottom of quite what is on their books in some cases, unfortunately, which ultimately I think will be a good thing, but makes them doubly nervous in the meantime. I mentioned escape of water losses. Underlying escape of water losses still is the thing killing them from a financials point of view. And I know you won't appreciate me saying this, but insurers, unfortunately, are commercial beings. They do want to make some money, and they haven't been generally over the last number of years. So that is why prices are going up. And then COVID-19. And this plays into the wider piece of the insurance market just being a global market. Unfortunately, the nature of what is insured out of London and beyond now is it's a truly global market, and therefore losses anywhere in the world of any sort do somehow have a nasty way of finding their way back to London. And COVID-19, obviously, and claims as a result of COVID-19 are no exception. So, I don't think insurers are going to be hit to the extent that they thought they might be when it comes to COVID. We can debate whether that's good or not. Maybe they should be. But they're running into the billions in simple terms, and they're still figuring out what that looks like, and that hits their bottom line. That hits their underwriting philosophy, strategy for going forward, and their pricing, unfortunately. So I think context is important. The market is hardening, and it's nothing to do with you. It's nothing to do with engineered wood as such, but trying to bring something into a marketplace where there is already nervousness, fear, underwriters thinking, if I write this and it goes up in flames, I'll lose my job, I think is a really important thing to appreciate when it comes to presenting these guys with new opportunities. There's absolutely a desire to help in the right places, and there's absolutely an understanding of the climate crisis, but there's also a fear of, I want to be employed tomorrow, being very blunt about it. So I think that's important. So what are the challenges? Again, this was mentioned earlier on by Caroline. The Risks Authority and the FPA, the Fire Protection Authority, I think I've got that right, is essentially a body funded by insurers to do research for insurers into things that they don't understand, like, and or are scared of. They have been relatively quiet on the topic of mass timber until fairly recently, and then they released a white paper on middle of last week, it was. Again, I could probably debate with you for 2 hours about the content of that report, and I'm not going to pretend that I love all of it, but I think what it does do is it sets a benchmark and a kind of a framework from which we can move forward, which we perhaps didn't have before. So the paper is, at a high level, 24 of the biggest insurers in London saying, here's what we know at the moment, here's kind of what we understand and generally don't, and here are our concerns. And these are why we have the concerns. And here's some ideas, but please help us, industry, in understanding how we move forward and how we solve those problems. So I would implore you to grab a copy of that from the Risks Authority website. I'm pretty sure it's freely available. If it's not, again, email me and I'll send it through. What does it talk about? It talks about building regulations. Again, this was touched on earlier. Dare I say it, insurers historically, I don't think have been that bothered about building regulations, and that perhaps makes them sound very ignorant, but I think they just always took it as read that your buildings would comply with building regulations and therefore be safe. To put it very harshly and bluntly, that, and as we know now, our building regulations, and Kelly talks about it, are intentionally vague to encourage innovation, but they're also, what that leaves is a big gap when it comes to engineered wood for interpretation, and also really only covers life safety, and everything else is up to you. And from an insurer's point of view, that doesn't necessarily help them if that means that their £100 million shiny new mass timber building is just left to burn once everyone's out of it, because that still leaves them with a whopping great claim. So there is a lot of talk in there, or some talk in there, about building regulations and how the insurance industry would like to see them reformed in the same way as I think we all would, and indeed the changes we've already had and the sort of reaction to those. There's some talk about US building codes. Again, I know that was touched on earlier. Whilst I think there's points in the paper about the US building codes that aren't strictly right or accurate, I think it's, again, useful context for you guys to know that the insurance market ultimately in London underwrites an awful lot of US business. And what that means in reality is their experience of timber tends to be experience of stick buildings on a mass scale in the US, and it tends to be that they have at least one massive fire a year. And so to the ignorant insurer, and they'll probably berate me for saying this if they ever hear this, but their only experience of timber really is an experience of US timber, lightweight frame that goes up in flames. Now, what they do with that is they apply all sorts of stringent conditions, and they charge an absolute bucket load for it, and the US market's okay with that. We can't do that in the UK. The economics don't work, and we're not building like that. But again, I think that's really important to understand that that's where a UK insurer's mindset tends to be when you talk to them about timber. They think, ooh, okay, I know that our US guys write a lot of that, and it burns a lot. That's the starting point. And their experience and evidence. Designing for material damage prevention, I think that's where this paper is really helpful. It just starts to talk about certain things that insurers would love to have a debate around and or see when it comes to designing not purely for life safety or for aesthetics, but actually, frankly, to help save their building. And again, into that debate comes the whole fire response strategy and how our fire brigades are engaged in projects. But at the moment, there is an argument from insurers to say, but all I know is that once everyone's out my building, the fire brigade are just going to leave it. And whilst you might have an opinion on that from an insurance standpoint, that means I'm going to have 100% loss. Whereas if I had a concrete building, I might have a 40% loss, and it will burn out, or it will be compartmentalized. So that, again, this is all trying to help you get in their mindset. And what are the challenge? Last challenge, and it's going to be one of the solutions as well, unfortunately, is communication, knowledge sharing. So the guys at War Thistleton are brilliant, and I met Andrew War for the first time about 3 years ago, and he reminded me last week, he's still the only person in 25 years of being an architect that he's met from the insurance world. Now, maybe that's a good thing for him, maybe he doesn't want to meet anymore, but I think it illustrates a key point, which is that whilst everything's been easy, in inverted commas, and insurance has been easy and cheap and readily available, there has been a total breakdown in the communication between you guys, the industry, and insurers. Now, brokers, dare I say it, are partly to blame for that. We like to keep our clients at arm's length from our insurers because we're possessive, and we don't want you to get too friendly and go and run off into a corner. But I'm very much not of that way inclined, by the way. I think putting you in front of clients is absolutely a solution, insurers. But communication and knowledge sharing, historically, I think, has been a massive problem. The baseline knowledge of the insurance market still, when it comes to engineered timber, as a great example, is limited. There are pockets, dare I say it, but limited. So solutions and opportunities, and this isn't a typo in case you've spotted it already. There are, no, I'm sorry, I'm jumping slides here. Solutions and opportunities. So important to draw another distinction here. There are two distinct markets in the insurance world, construction and real estate, or property. Now, all that really means is during the build process, hands over to the property insurers. But the important thing for you guys to understand is that they have very different understandings of mass timber, they have very different attitudes towards it, and they are distinct and separate, actually. So as much as you might go to Aviva and think, oh, I've gone to Aviva for my construction, great, that means they'll get it totally on the property side. Unfortunately, it's not as easy as that. They are distinct, separate teams within a big corporate wrapper. And if you explain something beautifully to one, doesn't necessarily mean you've explained it in any way, shape, or form to the other, or even, dare I say it, that they can get access to what you've given one, such is the madness of the world that we live in. But so where are we in the construction insurance world? Well, I'd say we're in an okay place. I'd say that's because we've put a lot of time and energy in the last 3 years into the construction insurance market and trying to educate them and bring them up to speed, because frankly, that was the first problem. The property thing was kind of like, well, if we can get people building, then we can solve the property problem. Hopefully, we're just about getting people building now. So you can definitely buy insurance in the UK, and forgive me, I know this is a sort of a much wider reaching seminar than this, but I'm sort of talking specifically UK for a sec. If you were trying to insure a project in the UK tomorrow and you had elements of mass timber, I'd probably caveat that and say, please, it would be a hybrid scheme rather than a full engineered timber building in its entirety, but if you had some sort of hybrid model, you're going to be able to get insurance for your scheme up to the tune of about 150, 200 million, i.e. total construction value. And that's pretty much readily available out there. It's not as cheap or at the same price as steel and concrete, but it's there, it's available, and it can be sourced. And if your clients or the developers out there are committed, they can get insurance, would be my blunt statement. Sorry, Russ, no pressure. And yeah, so ratings roughly double, I would say. It's sort of teetering downwards all the time, but it really does depend on the scheme, dare I say it. There are so many variables there. And he's actually escaped already, but there's a chap here from Chase Underwriting. So there's a proactive underwriter out there called Phil, who works for a company called Chase, who has kind of led the charge in trying to come up with a solution in the construction space rather than just sitting on his hands and listening and hoping someone else will do it first. So there are people in that space being proactive, trying to understand, and Aviva being a great another example. Caroline's brilliant, trying to get their heads around it, trying to bring the quality up and drive the price down, make it equitable for you, encourage use of mass timber. Where are we in the real estate space? Unfortunately, it's not so good, but I'd say that's partly simply due to the fact that we focused all our energy on construction for the last couple of years, and now we're kind of playing a bit of catch-up with the property market. So it's definitely obtainable, and one of my caveats would always be, I think any insurance is obtainable at a price. It's just is it an equitable one that you want to pay? But it's definitely more difficult, it's more challenging. Insurers know less, and that's why we're really kind of pushing hard at the moment through a number of forums to educate them. But there are various solutions being looked at. There are various captives being looked at some of the big developers. There are various other solutions being looked at by the Lloyd's market. and Lloyd's of London, as of December, got in touch with me and said, we want to get on board with this. So there is a wave of change happening. It's just not as quick as we'd love it to be. And solutions and opportunities part 2, this is where I was jumping to, saying it basically reads the same, and that is intentional, I promise. The top tips for both sides, dare I say it, are identical, and they've kind of been touched upon already. Engage early. Really, genuinely, there's no stage too early. I've got 3 projects on my desk at the moment, and the first one, the spade won't go in the ground until February next year. And we're coming up with a strategy, we're coming up with a plan, and they are, one's 28 odd million, one's 40 million, and one's about 160. But we're already engaging with the client, we're already engaging with the insurers, we're there at the start of design almost, basically saying, right, what do you need to think about, who do you need to talk to, and how are we going to get this done? Engage with experts, hopefully that goes without saying, it's a little bit of a selfless plug, but in the same way that there are experts in your fields, of which you all are, no doubt, there are experts in my field, and there are pockets of expertise, and not all brokers are made equal, so please engage with someone who understands what you're talking about. And the third one, recognize that the burden of proof rests with you. I know that might sound a bit harsh, but that's just the reality of where we are at the moment. We are in a mindset where the insurer's first response will be no thanks, as a broad statement. So it's then on you to say, okay, how can I change your mind? How can I show you that my scheme's better, my scheme's safe, my scheme's different, my scheme is everything that you do want to underwrite, and I don't care about what else is going on in the market. This is the best thing since sliced bread, and you want to be on this because this will be the future example of the best mass timber scheme in the UK or beyond. That's the kind of mindset you have to get into. And then looking at the fundamentals of how can I show you, Mr. Insurer, that your building, once it starts burning, will not burn through in its entirety. How can I show you that through compartmentalization, through protection, through proactive response, that actually I'm going to save the majority of your building. Oh, and by the way, it's really easy to reinstate by cutting out layers, lamellas, and putting them back in and all the rest of it. They need all of that education almost on a scheme-by-scheme basis at the moment because we don't have that consistency across the market. 43 seconds left. Whew, almost there. So conclusions, 38 seconds of conclusions. There's huge progress that has been made. I said I'm an optimist. I'll try and end on a positive note, even though I'm sure all of you are thinking insurance is the bane of your life if you've got a timber scheme in the pipeline. There has been progress, I promise, but there is definitely more to do, and I'm committed to doing that, I promise. Currently, it really is a project-by-project challenge, and explaining how you've de-risked it to insurers, why it's something they want to get on board with. And coming back to the context at the start, really, things will undoubtedly become easier as the market does plateau, hopefully soften in time, new entrants to the market, and insurance as a whole gets a bit easier, fingers crossed, because it's been a pretty rough few years. And as more performance and test data becomes available, I know the STA was plugged earlier, and there's hopefully really positive stuff coming out from us in the next couple of months around that, and really positive results of some testing. And finally, with your engagement, as insurers' understanding improves. So, 20 seconds over, not bad. I will leave you there. Thank you so much for listening. There are my details. Come grab me afterwards.
Thank you, Dominic. That was quite useful. It's always good to get insights from the insurance industry to consultants and trying to break down those barriers between building designers and insurance providers. All right, next up for our next speaker is Jeppe Hundevad, and Jeppe's going to talk about hybrid timber systems, the EcoN. All right, thank you.
Thank you. I think actually I'm quite fortunate because I just listened to 20 years of insurance, so talking about facades is a lot easier for me now. People are a bit more interested. So I'm talking to you here on behalf of Lindner. Lindner is one of the largest building system suppliers in Germany. We turn over around 1 billion euros worth of building systems over Europe and internationally. Lindner is a family-run business. They've been over 50 years in the industry. So Mr. Lindner himself is still around. He actually drives a cycle around the office grounds. And we've been through a lot of changes recently.
particularly due to this issue with the environment, carbon footprint issues, etc. We really have a problem to solve. Lindner was one of the first founding members of the Green Building organization in Germany. It's the DGNB. And we were one of the forerunners of producing the EPD information, Environmental Product Declaration data, for pretty much all of our products. When you look at like facades, particularly element facade, unitized systems and metals, it's actually shocking producing these EPD documents, because you realize how much embodied carbon is in the aluminium and the glass and the metals that we use right now. And until now, no one has really been interested in these things. So we as a company feel we need to address this issue, immensely, because it will definitely change our business, not just our suppliers' business, our business, and we have to provide these solutions, not just to keep the turnover, because we have financial challenges, but we have a duty to pass this technology on, what we've learned so far, and create new systems that will take on this challenge. And it's not easy, because people have been working so long in this business, they need to be slowly taken through the process. We know the green building, this term green buildings, is not just about carbon footprint. Carbon footprint is important, it's critically important, but we have to recycle these buildings. We have to be able to take these buildings apart, recycle them, and put them back together in maybe a new design 20 years down the line, particularly in our business. So it's not just carbon footprint, and this is why maybe you'll see the systems that we've developed, they're not only focused on carbon footprint, they're focused about recyclability. So it's a bit of a balance to make there. That's the situation. Oops. This is where we are, facades. This is all aluminium, completely aluminium system. This is our interiors division. It's all timber. The complete interior of the Copenhagen Radio Hall was completely made by Lindner. We have a huge capacity to machine, process timber. So we know about timber, but our facades department doesn't know about timber, because we've been looking at aluminium for the past 25, 30 years. So the challenge was given to us, Lindner, come and find a system where you can use your knowledge of facades, particularly unitized facades. We mostly deal with unitized wall. We don't do stick wall or windows, towers. Design me a system where it still functions. I need to give my warranties. I need to make it fireproof through the slabs, all these things. I need to at least halve your carbon footprint. Go ahead and make a design for this right now. So that's what we did. What we chose was a mixture between timber and aluminium. Aluminium is bad for the footprint, but it has certain things that are absolutely fantastic. You can design screw splines, you can design threads, you can have it thin. All these things, some of these things about aluminium we need to keep, because there is no other material that does it better than this, the aluminium, and it doesn't rot at all. So Lindner has a system called ECO, which is the left-hand system. This is the 2021 on the left, up to now. This is the most simplest unitized system we have actually made so far. There's no structural glazing here at all, so that's gone. You don't want to start ripping out glazing because it's just too difficult. I don't know whether anyone knows about unitized systems, but the ecosystem has the same mullion and transom profile is all the same, it's all identical. In other systems, you've got a chop and change to profile around, but this is one system only. And if you look at the way it's made, every part can be ripped apart and taken apart. You can pull it apart, take it down to the recycling places, and put it back together again in a new system. That's eco. So we're quite well advanced, in fact, with the idea. The eco-N is basically to look at the structural aspect of it and the performance of it, to remove all possible metal that we don't need for the structural aspect of the wall. We need to keep the timber inside, obviously. Looking at Accoya, maybe we don't, but maybe we'll think about that later. And the key here is that the timber and the metal are working as a composite part. This fishtail joint and the little slat there, they actually help the timber and the metal to work as a composite piece. The timber stops the metal from buckling, so you can achieve almost the full stress loads on the aluminium profile. The core is still eco, so if there's a wet room, for example, or like a bathroom or something, we can keep the eco on the left and swap with the eco-N on the right. So we can swap and change the systems if need be. So this is the slimmest system we have. This is based upon structural aspects, basically. This is more like a residential type of an affair. We can integrate all types of timber windows, aluminium windows in the ecosystem. Again, that's something that is part of the elemental design of the eco wall. The Eco 100, basically, this is purely a structural requirement. We have a slightly wider profile. We could increase the depth of the metal, the depth of the timber, to account for any kind of additional wind load requirements. The unit sizes we're looking at right now are mostly for residential buildings, so we're looking at about maybe 3.5, 3.8 meter height elements. This technology that's been known for a long time means that we're able to utilize an existing tested system, so it's completely drained from inside. So I don't know how many cladding specialists there are here, but a big problem, a big issue with higher rise buildings is infiltration of water behind the weather line. So the system is completely drained internally, and there are no timber parts at all in that chamber. And that was one of the things that we basically insisted to keep, because the simple fact is, you've got some areas that you can't see, those areas cannot be wet. So pretty basic. So this system is fully guaranteed under the same ecosystem as we have with Eco or Eco-N. So here, this is the slab edge. Big problems with slab edge and timber, because you can't see any of the timber, and there are fire and smoke issues there. The Eco-N system, we basically decided to completely cut the timber area out in this void. There is no timber in this area at all. This means that there's only metal areas. We don't need the mullion, the timber mullion there, to provide a structural restraint, because this area has a lowest point of moment connection. So the metal core is taking all of the shear forces into the slab. So that's been solved structurally. The other advantage is we have no, so let's say, invisible timber areas in that slab area there. also a key issue for facade design. So how do we check this composite action? So we have our own testing facility. It's basically next door to us. This is GIB. They're a fully certified testing authority. We tested a mullion. This is the N100 system. You see, this is the test rig right here. Here you see the metal and the aluminum profile. It's just to test the interface between the metal and the timber, whether it's theoretically acting as it should be. Because when you're doing hybrid design, you make certain assumptions about sharing of forces, and sometimes they can be wrong. For example, you're not properly transferring shear forces clearly. So this test was done, and it basically performed better than the original engineering calculations showed us. So we were on a very good way structurally to solve the wind load issues. There we go. There's a few technical questions here. So this is a whole lot of numbers that some people may be interested in. One issue here is this hybrid action between the timber and the aluminum. So there is currently no longitudinal shear transfer at all in the system. It's purely lateral shear in and out. We can theoretically clamp the timber top and bottom to allow some degree of shear bonding, so we could increase the strength of the system, of the hybrid system that way. If you see here the consideration of shear bond and without shear bond, we can roughly increase the strength of the mullion by about 10–15% under certain conditions. So that will be the next step in testing that process, but still avoiding having to physically screw the timber into the metal. Many different timber qualities. So we just basically used a simple softwood spruce material for these tests. So thermal performance. So the message here is basically we cannot have any interstitial condensation on the timber first surfaces at all. This was part of the whole clue of the focus. And with this thermal modeling, we can show that in detail that basically does not happen. So any concerns about condensation getting in between the gap between the metal and the timber, this is just not going to happen. The U-value calculation is obviously part of the whole story with saving energy. We can achieve, with some enhancement on the profiles inside the cavity, we can get the U curtain wall value down to 0.72, which is an extremely good value for a curtain wall system with glass in it, of course. If you take away the glass, of course, the factor gets a lot better, but we are currently thinking about glazing. Glazing is another challenge because that has to change as well. But 0.72 is a pretty damn good value, and we're quite pleased with that at this stage. This is more of an architectural picture, let's say. So we can change the visual aspects internally of the mullion. We can add seams, we can add beads, different types of aluminium or timber features. So this is something that maybe, if we want to be a bit more creative, this can be discussed. The two bottom pictures of the actual transom. So those are the two options of the transom detail below. So again, you can swap the finish on the right-hand side, and a full timber structural member on the right-hand side, left-hand side, sorry. This is also an idea for one of our designers to incorporate some kind of lighting in the voids, because we have this gap available to us. We can maybe use that gap to give us some kind of functionality to the system. And these are some options we have from our lighting department at Lintner. They've helped us out with different options of lighting for LED. That's basically what the concept is of how the system will look. So talking about this haptic feeling of being in a wooden timber room is, I mean, I'll tell you, it feels completely different than having cold metal profiles in your building. And it does, I would say that myself, I would rather have this in my apartment than an aluminum system in my apartment, to be quite honest. We can add any type of windows to the system. So here you see a typical window. So one unit could be either one window or two windows, depending on the building module, etc. But we would install these units as a complete pre-assembled system. It wouldn't be stick. Everything's made in the factory. It comes ready to install, and there'll be protection, which will be removable and recycled during the whole construction process. So we didn't choose the furniture. This was done by one of our designers. This is it's a nighttime view, so you have nice visions to outside. You have some nice lighting systems there. Maybe a good feature to add to the feeling of the room. So one big advantage is we can take any kind of timber that you need. So we can change it to oak. We can change to, we probably wouldn't need a Koya here because it's all internal, but we can change the wooden species to however you would like. We know the structural values of timber. These can be taken into account with the calculation. And, we also have different strength characteristics of timber we can include as well. Surface preparation is exactly the same, so we can offer anything basically you need that's already available on the market. This would be... So as far as the carbon footprint and the recyclability, so what you see there on the left is basically all the parts that are needed for that system. So there's actually not that many when I look at this. All those parts, none of those parts are actually glued together. So there is no composites anymore on the system. So you could literally take that frame out, unscrew it, rip all the pieces apart and put them all into different containers and get them remade. Okay, so this is the big number crunching exercise. So up until now, our facades have been around the 250 kilogram mark, CO2 mark. You see here the distribution of the metals and the parts and pieces. And this bar chart basically shows only the stages A1 to A3 of the cycle. So it doesn't go all the way to maintenance, use of energy in the building, and then recycle, just the A1 to A3. The orange is the aluminum, obviously, we know, and the blue is the glass. So when we flip over to the Eco-N, Obviously, the timber is a fraction of the aluminum. So even if we can save a little bit of aluminum, it makes a huge difference to the balance for us. So with the standard supply chain process of metal, we get about a 20% reduction totally in the footprint of that facade, which is pretty good. It could be better. Obviously, the reaction to the climate crisis for the aluminum industry is they are now looking at their whole supply chain, how they make aluminium. This will also completely change for us in the future. There are products out there from Hydro and other companies. We've taken one, for example, Reduxer, which is a Hydro product. And we can then build in that calculation of the aluminium usage into our calculation. And you can see here, for the same amount of metal, we can halve that footprint, which is quite significant. What that message is basically is that don't kill the aluminium yet. It's still going to be there, and it still needs to be used for certain parts of the building. We should try to use our knowledge that we have already and make a better system and not just chop out parts that maybe are bad. I think we can make the system a lot thinner. I think the metal can be reduced a lot more. But this will be how these systems will look for us in the future. There'll be much more of a combination of timber, metal, pulling the system apart, recycling. And I think we're quite happy with the situation right now. And we'd be happy to discuss the system with you right over there in the coffee room. Marcus is here with me. And I'm going to stop a little bit early because I know that you're late, so I'll leave it at that. I'm +3. Okay, I'm right then. Thank you very much.
Oh, thank you. I do concur, actually. I think a timber environment does feel better than in your cold metal place, so I do agree with that. Next up, we have a slight change in the lineup. Instead of Maria, we have Ross Palmer, who's also a senior partner at Foster & Partners. He'll be sharing the stage with Martin Ocampo, a design director from AKT2. They're going to, the theme of their talk is a light touch approach to future tourism. All right, thank you.
I'll wait until you finish, yeah. Hello, thank you for your time today. A very interesting, Jeppe, comment that I picked up strongly was the word feeling in his presentation, the feeling that you get from the use of timber in structures. And I've been working at Foster's for 27 years. I worked on some fantastic projects, but I have to say this one's particularly interesting. So I'm looking forward to sharing some hopefully incredible images with you today. It's about just one resort spread over 2 islands on Ummahat al-Sheikh in the Red Sea. Where is that? It's roughly halfway up the Red Sea. It's very easy to find on Google Earth. This is the Al-Waj Lagoon. The Al-Waj Lagoon is very pristine. There's no buildings there whatsoever currently. And we're working on the Red Sea project. The Red Sea project is a series of luxury hotel resorts, and it's focused on Saudi Arabia's Vision 2030, which is about diversifying their economy. And the tourism industry is a massive industry globally. As much as 1 in 10 people in the world are working related to the tourism industry. I'm only talking about one project today. It's on this island here. We are actually doing an airport. It's a new international airport. And this particular diagram is just to give you a sense of scale. The Al-Waj Lagoon is comprised of over 90 islands, individual islands of various scales. And they form this is just roughly half of it in this image that you're seeing here. They form the 4th largest reef structure in the world. So it's incredible. The fauna and flora, particularly the marine life, is absolutely amazing. And that word feel, I think, is really critical. We knew from the outset on this project we wanted to create something absolutely unique. The client's vision was to try to create something that had never been seen before. And we knew from the beginning we wanted to do something that was super integrated, very crafted, and hyper efficient. And Martin will be going through in the second half of the talk in some detail about those aspects of the structure and the systems. I was fortunate enough to actually get to the island. It's 25 kilometers off the shore, and pre-COVID, we went there to have a look. And I think the takeaway feeling from being on the islands, being in the Al-Waj Lagoon, is the feeling of isolation, and that has challenges from a construction perspective, but it was really about how do we create an architecture that captures the essence of the place, protects it with minimal impact, and also deliver hyper-luxury. And that comes back again to this concept of what does it feel like to be there? What do you want to feel like in a luxury resort? And we think the future of tourism is minimal impact and space. Space and openness, and a connection to the place, yeah? Just a quick master plan view. It's actually over 2 islands. If I mention Blue Hole when I'm talking, I might do it, just drop it in. It's this huge water body here. It's very deep, and it has these incredible colors. And so our resort is spread over 2 islands, 82 villas in total, and they're connected by a guest hub at the center here and runs all the way down to some additional overwater villas. Most of the villas are on land, but some of them are over the water, and we wanted to do that to connect it up visually and in a beautiful way. So right from the master plan perspective, we wanted it to be connected. I'm going to go quite quickly on these images, so don't look at your phones. If you want to see them, you might miss some. Give an idea of scale. This is 320 meters diameter circle. And what we're going to talk about are the villas specifically. And they come in various clusters, and it's a repetitive shell module that's used to build up the villa structures. There's a couple of unique ones, which I'll show very briefly as well, which are bigger. And the guest hub structures is on this triangle over here, which incorporates food and beverage, lounge spaces, relaxation spaces, and cafes, and so on. Drama was a key aspect of the project, to touch the ground lightly, but to do it in an absolutely beautiful way, to respond to the nature of the site. And it is truly incredible location. I've been there, I know what it looks like, I know what it feels like. We wanted to integrate some aspects of Saudi Arabian traditional architecture, and although I'm not going to go into detail on this, you'll see in some of the imagery the use of ropes. The top left-hand image is from a historical project in the south of Saudi Arabia where they use these rope structures on housing. But I think the other things to take away from these imagery is the play of light, yeah? The shade and daylight and protection. This is a plan view of one of the typical villa structures. In terms of dimensions, it's 2 shells that you're seeing there connected by a central living space. The shells are free-spanning glulam beams, roughly 18 meters in length and about 6 meters in overall width. The overwater villas are also clad in some timber structures. These are timber slats on the outside here. You can see the rope cladding above, which has been very challenging, but we've made incredible progress with that. And you can see a hint of the arches inside. Part of the reason for the shell structure was this feeling, because you feel very isolated on the island, we wanted to create something where you felt protected, when you're actually in the resort, in your villa. And so this concept of protection, these slightly cave-like structures, which only have actually a window on one side, was a key concept. And I mentioned at the beginning the idea of crafted. We think this is very important, and part of the reason why we went for the wood structures, because we just thought that this was a way to create something truly unique. Timber is used for the vast majority of the buildings in the project, including a walkway structure that you can see here, which is part of the circle that links those overwater villas. And the concept here was, how do we create protection? And these are timber ribs in here with a cable net structure and planting to give people a sense of protection from wind, sun, and we oscillated the kind of undulation of this wave sort of form. So you had views into the circle and out of the circle, and also provide privacy to the villas. The land-based villas are actually identical in structure, and that was part of the reason we wanted to create efficiency. How do we actually get these buildings to the site? A view there of the pool structure. And I mentioned a little bit earlier, we have some relatively big free-spanning glulam arch structures, which are all the timber structures are being made by Blumer Lehmann in Switzerland. I'll show you a couple of mock-up shots at the end of the presentation. So these 3-bed villas follow the same conceptual approach, but are just grander in scale, and there's only 3 from memory. I think the expression of structure is really important, and I think, this is a Façade conference. My take on what is interesting about this project is the fusion of engineering, architecture, and facade. It's all one, yeah? There's glass facades, but the concept of the whole thing is that roof doesn't form walls. It's all one structure, one element, totally integrated. We have other facilities on the island, a spa facility. You can see the internal view here. And we have other destinations on the island, whether it's beach bar, kids clubs, and so on. But hopefully what you can see in the imagery is this light touch concept, that the buildings are unique, hopefully something you've never seen before. And our take on it was to try and make it minimalist. So you maintain this purity of the very narrow islands, and the view isn't a blue hole you can see in the top right-hand corner there in the imagery. Specialty restaurant structures are also involved. And I just want to touch on a couple of other building types. So this is the guest hub. This is one of the arrival spaces. It's a series of 2 types of shell structures, purely shading functions. This is a lattice diagrid timber frame with gigantic glulam arch structures. I've got a couple of images coming up in a second. And we have sealed ones where the kind of the cafes and lounge spaces are that can be air-conditioned. But conceptually, the whole idea of the resort is to minimize circulation spaces that are internalized. So you don't have to air condition, you don't have those energy issues. The entire resort, and all resorts in this Red Sea project, are powered off 100% renewable energy, solar and wind. Coming back to this concept of crafting, what does it look like? What does it feel like? How does it feel like hyper-luxury? And one is the appearance, and the other side of it is the shade and the effect that it has on the environment. And particularly at Foster & Partners, we've always liked this combination of aesthetic, engineering, and performance. Performance in this case being somewhere where you can sit in the shade out of the, albeit, what can be extreme heat in the Saudi Arabian climate. Coming to the end here, so I'm going to hand over in a second to Martin. But just to show you what we've been up to very recently, this photograph was taken, I think, in December. It's a full mock-up of the structural frame done in a warehouse, because this is in Switzerland. And we were testing actually some detailing to do with the window frames, but particularly how these buildings will be assembled on site and how it works from a tolerance point of view. So all these The assembly of the structure was filmed, videoed, recorded, and they were using it as a training process with Blue Malaman's team for the site installation teams, because they have to be put up very quickly. This is just to show you what we've been doing on the rope cladding. So this is 1/2 of one shell, so 1/4 of a one-bed villa. This is the pool deck, where that guy is standing there is roughly where the pool is. And this is the rope cladding that we've been installing on these timber structures. And just to prove it's in Switzerland, and very recent, an image. Okay, I'd like to hand over to Martin.
So thank you, Ross. That was really good. I know you all want to go and have lunch, so I'm going to be quick. Hopefully by the time I get used to this microphone and you get used to my Colombian accent, we should be over. So quite a variety of buildings, as you saw from Ross' presentation, with one thing in common, they're all made out of timber. And we made the decision of building everything in timber right at the beginning of the project. And what is interesting, I think, about that decision is that we didn't make that decision out of embodied carbon and minimizing embodied carbon in the buildings, which is kind of the obvious thing. That was part of the equation, but it was not the main driver to do so. So what I want to talk today is what complexities and challenging of this particular project led us to that decision of doing absolutely everything in timber. And the first thing I want to mention is how remote the place is. So I also went there, not with Ross, in a different visit. It took me 3 days to get there. The islands are, you actually quite kind of see it from this scale, is this spot here that you see, that clear color. But there are, in between these two massive deserts, the Sahara and Saudi, the nearest city with an airport is a place called Yanbu, somewhere there, which is a couple of hours' drive from the coast of the islands. And then the nearest port, more importantly, is in Jeddah, which is way further south, down the Saudi coast. But the islands are not only remote and isolated, they're also surrounded by this incredibly sensitive and precious environment, which is this coral reefs. The whole formation of this massive lagoon is nothing but the outcome of centuries of those coral reefs right along the perimeter and those sand deposits on top of the coral reef. So quite key. The sensitivity of the environment around us. Our islands are these ones here. You get, as you probably know, the Red Sea has some of the most amazing corals in the world. And you get that vertical wall of coral here in this transition between the deep waters and where is the shallow water. So you get the main corals there, and then along that line there. So not only you're surrounded by this sensitivity, but the nature of the formation of the islands also means we have a very shallow waters all around it. So the edge, even though it's here, we have almost 0.5 kilometer of really, really shallow waters all around us. So bringing materials there is extremely, extremely challenging. And then when you get to those places, even though they are surrounded by desert and they look like a desert, they're far from being a desert. The islands themselves, they're a very precious habitat. They provide nesting spaces for sea turtles, but they're also part of a very important migration route from South Africa to the north of Africa. So if you were a bird and you're trying to go from South Africa to the north, instead of crossing the Sahara, you do it through the Red Sea and stop in this paradise to nest and to eat. And that provides, I think, the biggest challenge for building here. And is whatever you do, you really want to minimize the site activity. You know, the last thing you want is hundreds of workers living there for many, many months. You really want to go build very, very quickly and then go away. So timber really ticks all those boxes. Now you can prefabricate it, all of it. It's very lightweight to transport, to bring it there. You don't need a lot of people, and you can install it in a very quick way. But in addition to all of that, timber is also very resistant to the marine conditions, as opposed to steel or in a way, concrete. Timber is very good with salt. It doesn't get attacked by salt. As you probably know, salt silos are all made out of timber, precisely because of that. And that brings another key thing, which is you not only want to be fast and reduce the risk of pollution during construction, but you also don't want maintenance to be an issue in the future. The last thing you want is needing to come back and paint and pollute the environment. And then that was the reason for going down the timber. And once that decision was taken, I think that the concepts and the designs all evolved around that decision. So when you look at the solutions themselves, there's two keys there. One is simplicity, and the other one is efficiency. As Rose mentioned, it's fully integrated. There is no distinction between the structure and facade. It's just one envelope that provides both. Glue-lab arches, very efficient, and then in between these timber cassettes with the insulation inside, providing the shelter. And this is the one-bedroom villa, which is the smallest but the most repetitive one. Let's see if this works. And then when you go to the largest element, even though the geometry is different and the form is completely different, the concept is exactly the same. Again, glue-lab arches. This thing doesn't work. Again, glue-lab arches spanning in between, and then those infills with those timber cassettes with insulation. So very simple, few parts that allows for that very speedy installation and prefabrication. And again, when we go to these large models that provide this hub, again, glue-lab arches with this beautiful timber grid shell. And that's possible because this is not an enclosed space. It's a flexible space. It's mainly a canopy providing shadow to the space inside. And that's why the buildings next to it, which are actually enclosed and are a proper conditioned space, instead of that flexible grid shell, this is a rigid timber diagrid, again, supported on glue-lab arches. And then that's only the structure and the shell. But when you look at the whole range of components, apologies for the blur image, again, it's very simple. It's a few parts that come together, and that's it. And we not only, this is not only in fabrication, it's actually on site. And those pictures are from the island itself when we start having the first villas. And that's it from me. Thank you.
What a really interesting project. Makes me want to go on holiday. Now. Okay, that's the end of the session, second session. So we've got a 40-minute break have some lunch and to mingle around. So if we come back here at about 10 to 2, that'd be great. Thank you.
I'll have to go push them, so let me go out.
Okay, welcome back. Hopefully you're all rested and fed and raring to go for the second half of the day. Our next speaker is Claudia. I can't pronounce her surname, but I've got permission not to pronounce it, so that's okay. And Claudia's going to talk on facade engineering with a theme on healthcare. So thank you, Claudia. Come on up.
Oops. Thank you very much. Kalispera, I think I should say. I'm very happy to have this introduction to a project that is very close to my heart. And I hope you will find it beautiful and virtuous, as the word would want to say. Just because I'm a very messy person, I thought I would put some order in my thoughts. This is what I'm going to do for the next 30 minutes. Bear with me. I will swear I'm going to be very fast. For the first bit, particularly, I'm going to talk about the health initiative, which is at the basis and the founder of the project. I was supposed to be here with representatives from Renzo Piano Architects. They couldn't come. So you will have an engineer pretending to be an architect for some time. I will do my best personification. I will try to go into some of the timber challenges specific to the project and show you some of the answers. I'm not going to be terribly exhaustive, but I think it's all that is allowed in the time being. So without further ado, first I'm going to tell you who we are so that you understand who's talking to you and if you can trust us and me. I work for Fonte Tomasetti. My name is Claudia Farabegoli, in case you were wondering. We are an engineering consultancy working all over the world. The headquarters in New York. The London office is in Farringdon. I know most of you in the room, so I'm very happy to see all of these familiar faces. These are our purpose and values. I've highlighted the one that I think is more appropriate for this project, which is potentially contentious. There's quite a lot of risks associated with it, but we wanted to see it as an opportunity to do something of value. I also put on the page our faces, and I wanted to highlight my colleague Valentini, who's hopefully in the room because she's delivering the project with me. So whatever you are, Valentini, thank you. You are a star. So going back many years, I've been lucky enough to work with Renzo Piano on a number of projects. Most of the projects are clad in glass and steel and metal, and you will recognize some of them. Before that, he was the New York Times building in New York. Until this project, which is just finished, where you can see, it's a residential project, the first glimpse of timber arriving into the facade. And that was not my first foray into the material, but probably the one that was biggest in terms of scale and complexity. We originally wanted to do all of the facade in timber unitized. At the time, it was 2015. That wasn't possible because of fire regulations and spandrel compartmentation. So you see timber in the frame of the internal doors and then in the sliding doors. It was the first timber bit that you could see in some of the facades I've done before. But that was going to be followed by timber all over for the following project. So I have now to show you something which has got timber in structure, in slabs, in walls, in cladding, and in windows. So multiplying the challenge by a factor of 5 or 50. The founder of the project is a foundation, which is a philanthropic foundation by Stavros Niarchos, one of the richest shipbuilder of Greece. And he's been investing for the past 25 years in a lot of different things, mostly connected to cultural events, funding for this is probably the building that you will recognize more easily. It's the home of the Greek library and theater, I think the National Opera, that was delivered by Renzo Piano. They've been founding and sponsoring many more buildings and many more initiatives over the past 25 years, including health initiatives. What they wanted to do this time was something pretty radical, so increasing the scale of the initiative and going straight for 3 hospitals, so 3 completely new built constructions in areas of Greece that really needed it. So these are around 420 million euros to be delivered until, I think, 2025. The hospitals are in 3 very different locations. Komotini is fairly on the inland. It's quite coastal, but it's not on the seaside. Thessaloniki is pretty much on the seaside, and Sparti, again, is quite close to the seaside, but surrounded by green hills. All of these 3 locations have got completely different wind load distributions and seismic loads. So for all intent and purposes, it is 1 project, but it's actually 3 projects. Because I'm a lazy cow, I thought I would just show you the video that the foundation prepared, which is much better than what I could do myself. And it's specific. This is specific for 1 hospital, which is the one of Komotini. Oh, there's music. You can see that all of the white bits that you see there on the video, this is all timber. The lower levels are all just a stick system, glazed facades. But timber is used extensively on the inside, on the upper parts. There's a very piano design with the skirts, the wings, the screens at the top, and as interior. The thinking behind it is clearly sustainability, but also well-being, because there's a number of studies that have been developed that show that being connected to nature in healthcare settings helps us speeding up recovery of patients and contributes to the well-being of both the patients and the people working in the space. So, a few images. The 3 buildings are, I've got common language elements. That's what I play. I play the architect. There's the flying canopy at the top, short sides and long sides. The long sides have got timber. The short sides have got render. This is Thessaloniki. It's just a pediatric hospital. It's not a general hospital. And it's also made on 2 blocks. It has 2 levels of wards, whilst the other hospital had 1. Sparti has got more levels. Many of them are kind of in the lower part. There's a lot of timber in the structure. I'm not going to go into that. The structural engineer for the project is Milan Engineering. I can just give you the bullet point of why they did it. One is sustainability, and the second one is a seismic performance. So in comparison to a normal hospital, in a seismic location like these Greek towns would be, the displacement of the structural elements are a lot less than what you would expect if you were going for the traditional form of construction in Greece, which is concrete. Okay. So the hospital has got multiple levels. The idea is that the patients will always want to have visual connection with the nature around it, either the canopy top or the landscape around it. Even the operating theaters have got windows. The operating theaters have got multiple layers of windows. They include louvers and shading blinds and blackout blinds, and in some of the operating theaters they will have laser-proof blinds. The majority of the activities in the building are done on the level 1, which is where you got the stick system facade, and the timber is mostly used in interiors in these locations with the auditorium and the circulation spaces. Then you go up, and that's where the inpatient wards becomes interesting, because the bedrooms of the patients are all clad externally and partially internally in timber. They've got timber windows with interstitial blinds, and they've got these deep shading elements that are kind of 3/4 from the top that cast a shadow inside the room. You can start seeing from these pictures how the facade has got this vertical rhythm of noses and cladding, and some of the CGIs that have been developed by Piano. As I said, sustainability is at the heart of it. The hospitals are going to be 100% powered by green energy, and the PV canopy are estimated to provide 75% of the electricity for the running of the building themselves, whilst 100% of the heating is going to be provided by geothermal energy. They are all aspiring to be platinum, LEED Platinum, healthcare type of accreditation, and the choice of timber as a material has played quite a large part into the way of achieving this accreditation. You can see in this elevation all of those elements. You can see the slats, which are partially projecting down as a skirt over the glazing below and sideways and at the top. Talking about timber, this is where it becomes a little bit more juicy. From my perspective, it's always a balancing element between what you want to achieve in terms of sustainability credential, beauty, warmth, contribution to feeling good, and what you need to do in order to have compliance with fire regulations, procure the material, where do you procure it, where it's coming from, where it's going to, durability and visual consistency. For visual consistency, I mean both consistency on day one and over time, how the timber behaves in the expected life span of the building. So 3 challenges. The first one is that really compliant with the code? Can we do a hospital that is completely clad in timber? Durability and maintenance, and then a bit of a provocative question just to see if we stay awake. So, is it compliant with the local code? Yes. The Greek code allows, is fairly stringent on some aspects. So they want to have 1.40 meters of fire-rated separations between windows and openings. But if you've got a low enough ratio of openings versus a solid wall, they actually don't expect much in terms of Euro classification of the cladding material. So in principle, these building could be clad with a Class C cladding, and it will be perfectly compliant. Now, I spoke with everybody and I said, we're not going to do C, we're going to do the best possible classification that you can do with timber. And if we're going to get cavities that are going to be, they're not required, cavity barriers are not required to Greek code, but we're going to implement them nonetheless, because we know what they do and seems stupid not to use them. The bit that is probably most important, I can start talking a little bit less frantically, is the durability and the maintenance requirement. So one of my major moral questions facing this project was that timber requires generally maintenance. And when people spend all of that amount of money for a hospital, the foundation is going to allocate a pot of money for the hospital's maintenance as well, but you really want that maintenance to go on medical equipment and things that make a difference to the function of the hospital, not to people repainting the cladding every 5 years, right? Particularly not in front of emergency entrances or escape routes. So we dedicated quite a lot of time at thinking what that means and how we can optimize it and making sure that the use of timber is sensible and compliant with both the expectations of the building lifespan and daily operation. I'm not going to go into any of the details. I can warmly recommend anyone who's interested to go and look at either the TRADA or the WPA documentation, which is online, which has got a truckload of really, really important information. I can give you what are my most important takeaway points. So when you look about durability, you have to think about the timber essence that you're going for. There's a complete difference between one timber and the other. some of them can be naturally durable, others are less naturally durable, but can be treated to be as durable as the others. The durability is described by many different criteria that include resistance to fungi and rot, resistance to yeast attack, resistance to mechanical abrasion, wetting, geometrical stability, and all of that. In most conditions, you will need to use some sort of preservative for timber that is used on the outside. This can be a preservative like surface applied, impregnated over the outermost few millimeters of the timber, or it could be a chemical or thermal modification. Different options are possible. Each one of them has got implications in procurement and management. The super important thing with timber is always thinking about the humidity. Timber will never be stable in terms of normal timber. In terms of humidity, it will fluctuate. You have to design it so that the fluctuations in humidity within the timber are compatible with what you're doing to it, how you're fixing it, how you're coating it, how you are using membranes around it. You have to implement sensible design features, and you might want to coat it if you want to create some either design color or durability against fading. There's a lot of philosophical discussions that we can have about painting timber, and if you could just let it go gray naturally or not, and how to design so that it does it more uniformly or not. I think it may be good for the breakout session. What we've, so kind of a conclusion, the sensible design feature that you should always think about is drainage path, allow for drainage, chamfer pieces of timber so that they shed water out. Don't ever create a surface where water can accumulate, because water and timber in long period of time don't go together. Think about the gaps that you allow. Think about the ventilation. Ventilation should not be impeded by cavity barriers items that you put at the back, unless you think about it and you design it appropriately. Allow for moisture movement within the wall build-up, so put the membranes sensibly, and design above the splash zone. So always keep the timber, unless you want to design a wind post or a post like a fence, and you want to maintain it as you maintain your fence in your garden, put the timber above ground. And there's different numbers that I've been hearing about what's the sensible distance for splash zone. In my mind, 250 millimeters seems to be about the minimum that one could consider, because water splashes. And if you do all of that, if you choose a good timber, if you apply the right treatment, you should be able to achieve a class 1, which means 60 years of expected design life. It's not 60 years without maintenance, it is 60 years with maintenance, and you're going to see visual changes over these 60 years. So that it comes with the material. What we've done in the building in detail, finally, I can show you some details. That's more or less what the facade is made of. There's a series of rain screen cladding slats, decorative noses, which are sometimes uninterrupted, sometimes interrupted by fixings of that cantilevering canopy, and then skirts. See the details. The windows are in timber as well. They've got interstitial blinds into the IGU. That's because in healthcare setting, you cannot have blinds that require cleaning for hygiene reason. The internal windows need to match the timber of the interiors. The outside is acetylated pine, and the rain skin is acetylated pine. The inner wall, we've been debating a lot about that. Our preferred solution as engineers was to go for an SFS type of construction with steel studs, because that's widely available in Greece, and it seemed to be very much into the cost plan. But the conclusion was to be a little bit more ambitious and go for prefabricated modular constructions with timber studs. In order to comply with the fire regulations, in the 2 hospitals, they've got ward rooms one over each other, so not the Comotini Hospital, which the wards are only one level. You need to have an internal dry lining construction to help you with the achievement of the 140 centimeter high fire rated zone. And you need to have a construction that is certified for 60 minutes EI. Oh, sorry. Going back, you can see that the skirt is designed for water shedding, and a similar design would happen at the top. What I'm showing you is a visual mock-up that was commissioned by Piano last summer. It would be really interesting to go and see it now to see if the color has changed already. It was commissioned by Piano and done by a local fabricator. It's executed with acetylated pine, Accoya, or pickled pine, as we call it. It has got a slat around 23 millimeter in depth, and they are oversized. They are 180 in height. The cavity is 50 millimeter wide, and it has impregnated with a fire retardant, which is polymer-based, to meet a Class B S1D0. That's according to a certified and approved test report. So it is nailed with stainless steel nails on impregnated buttons. The certification gives you the limit of application, so the buttons can be not more than 600 millimeters apart. The gaps have to be not more than 6 millimeters. There's different criteria depending on the type of timber and the type of layout of the slats. The finish has been tested to be compliant also with the European test for durability of the fire impregnation. And because it is a fire impregnation, it doesn't need to have end grain touched up if you need to do any cutting on site, because nobody would want to trust a fire treatment if you have workers going out with a saw at the material when they are fixing a corner doesn't quite fit the dimensions. The main problem we are facing is that the architects really wanted to be gray. They don't like the timber color. And it's a problem because a surface stain, and they specifically want it as a surface, as a stain, gray, has to be tested specifically for the substrate. There is an issue of compatibility between any surface treatment that you do and the fire impregnation, which is a combination of the timber that you're using, the fire impregnation, and the surface roughness. So the slats that you see there to the right are example of exactly the same Accoya slat with different surface finishes. So they've been sewn with different roughness, treated with the same fire impregnation, and then painted with the same gray surface stain. And after 5 minutes, they look okay. You turn around, after an hour, that's the way they look. So either the stain disappears in the timber drinks it, I don't know, but it can achieve completely different visual appearance. That's why doing early mock-ups, prototypes, speaking with the industry, getting the advice of the people that do this day in, day out is vital, because nobody would want to see at the end something that comes out like that mottled finish. Last very few slides. We are not anymore building with material that we found around the corner. None of the things that we put in buildings, and particularly timber in this case, comes from the wood around it, like we used to do it in prehistoric times. So the timber that we're going to use in buildings arrives to site, and it has traveled thousands and thousands of miles. It's passed hands between the fabricator, who's been harvesting the timber, who's been doing the fire treatment, who's been doing the painting, who's been doing the assembly into prefabricated pieces. The one thing that you really need to make sure you have is a clear chain of custody, because if you miss a piece of paper, you don't know what you're putting on the building. Your fire certificate would probably not be valid, As a specifier, I would probably expect everybody to have a million eyes over the quality controls and making sure that all the labels, not just the sustainability bit probably is the easy one, is understanding how many steps this piece of timber does, where it's going, how many different brains have been thinking about it and been treating it. That's a super, super fundamental. Also fundamental is procurement and transportation. Oops. So site logistics is super important. You can't think about building a timber-clad building without thinking about what you're going to do with all these pieces of timber when they are resting before installation. You need to have the space, you need to have the knowledge to store them correctly, to protect them, to allow moisture to evaporate if they get wet, to make sure that the final quality, visual quality of the timber, but also performance quality of the timber is appropriate. Otherwise, there's not, I mean, half of the pieces will be rejected and not valid. It's a sad truth that this timber goes through a lot of processing, and during the production, all of the offcuts, all of the pieces that are not making it to the final slats are generally used in energy recovery system for biomass. So the producers of timber are very green, I mean, they're not wasteful. There are people that wouldn't warm up their factories with additional fuel when they've got all of that in-house. But I would like to leave this presentation with a question to the industry to see what they can do in the future, because we are doing our best to design timber buildings that will last 60 years. It's a lot of energy, it's a lot of carbon that we are putting. The last thing I would want to see is that in 60 years' time, people will burn it. That would break my, I mean, in 60 years' time, I'm not going to be here, but it would break my dead heart to know that we go through all of that, and then the best way that they can do with all this reclaimed timber, assuming that there is reclaimed timber to take off a building, is to burn it. So there must be a smarter way to dispose and recycle of it. I'm leaving this with a joke. Maybe in a few decades, people will still use pencils to draw, like Renzo Piano likes to draw on surfaces that he found around in his yard. If we can possibly have a conversation about what happens to that, because I feel really bad at thinking that, I mean, we're going to build this building and we're going to set it to fire after 60 years. We can recover energy, but it would be a pity. That's it. I finished 2 minutes in advance.
Well, thank you, Claudia. You finished 2 minutes before time, so brownie points for you. Next up, we have Franco Piva, founder and technical director of Ergonomous Timber Engineering, and you're going to talk about how engineering mass timber can be used for facades. Right?
Right, exactly.
Thank you.
Well, good afternoon, everyone. Thank you for coming to this event. Honestly, I'm quite nervous to speak English. I come from Italy, but Italian is my mother language, and a lot of people. I'm very happy. And today, I'm going to show you a bit how we used CLT to design, to engineer a few facades around the world. It's quite innovative to use a CLT just for the facade. But we proved that it is possible, and to do this, we combined together many different technologies, and we'll show you later how we did it. So first of all, I show you where we are located. We are in the northeast part of Italy. We are in the Alps. The office, the engineering firm is based where the point is, the orange point is. It is in an area surrounded by lakes, forests, and a lot of mountains. So it is quite normal for us to go for timber, to use timber for the structures. I started personally in 2003 engineering CLT buildings. This happened, at that time I was just graduated and I was working in a company in South Tyrol, which was a bit, well, you don't see the laser, doesn't matter, it is a bit north, more north than the point you see there. And at that time we were really pioneers because nobody was talking about CLT and especially nobody was talking about high-rise CLT buildings. A 2-story or a 3-story CLT building was something like, wow, great. We'd never seen it before. So at that time, there were just 2 CLT manufacturers all over the world. Both of them, one was based in Austria and the other one in Germany. And the total CLT production, the worldwide production, was about 25,000 cubic meters per year. Just to give you an idea, last year they produced something like 1.2 million of cubic meters of CLT. So in 20 years, a lot of things changed. Here in this map, you can see where we worked, where we engineered projects, always using timber. We do not design concrete or steel, but we are just kind of aficionados of timber, let's say. We worked, the very last project we worked on is in Australia. It is the first one, and we used heavily tools like rhinoceros and grasshopper to use double curved and twisted glue timber beams. Next week I'm going to the factory for the quality control and hopefully everything will be fine before they load the containers and they transport the material to Australia. Thanks to all those projects, we as a team had the opportunity to see how important is the digitization of the projects. Otherwise, it would be impossible to manage different projects in different countries using different codes. Because we are located, let's say, in a strange position on the market. We are between the producers on one side and designers, general contractors, developers, and builders on the other side. So this means that sometimes we work with and for builders, but other times we work directly for the manufacturers. And in that case, we need to know exactly how they work. We need to know exactly the limits of the production, how the elements will be created, how the CLT panels will be manufactured, how they will be machined, transported, loaded on the container, and assembled on site. So we need to know exactly the whole supply chain. We need to know exactly since the beginning, from the beginning to the end, what will happen on the project. This is absolutely not easy because we also prepare the files for the CNC machines, which is one of the most complicated parts of our job because every company has different machines or they customize their CNC machine or they want us to try, let's say, to force a bit to find workarounds to make the machine make what we need, what we want. So on this side, on the side of the producers, we have to arrive up to LOD 400 plus. We added plus because of the CNC files. On the other side, we can stop at LOD 200 or LOD, level of development, 300. As I said, I think that in the past 20 years, especially in the past 10 years, we saw a big evolution, but I prefer to call it a revolution in the market, because finally all the architects, designers in general, and also the companies are using new technologies. So we are getting very, very familiar with concepts, with words like BIM, building information modeling. We are getting familiar with computational, generative, and parametric design, robotic prefabrication, and especially there is one word which I like very much, which is DFMA. This acronym stands for Design for Manufacture and Assembly. And by coincidence, in the past days when I was looking, when I was using Google to find the logo of this conference, I came across a slide, a picture of I think it was 1 or 2 years ago, this event. And during a panel discussion, there was a sentence which was, is the DFMA the new value engineering tool? Question mark. So I decided to reuse this sentence to say, yes, it is the new value engineering tool. I say that because when we work with or for builders, general contractors, and developers, they always try to cut the cost of the material. They always ask us, how can I use less material? How can I find another supplier who can be cheaper than the previous ones? But I believe that at a certain moment, we cannot make the material cheaper than now. Well, put aside what happened last year on the market of timber, it was a bit crazy. Hopefully, this year will be different. But I think that we need to embrace new technologies, to have in front of us, to have on the monitor, the 3D model of what we will see on site. So we decided, me and my team, a couple of years ago, to try to find something new to analyze our project and to find better solutions. And this is why we came up with the augmented reality. And this is a movie we created about 1 year ago, a bit less. So we had, this is a project we engineered in Toronto, in Canada. And this is a huge connection, it's scale 1:1. And we wanted to know exactly how it will look like on site. When you see on your screen in AutoCAD, you see this connection. Okay, you measure it is 1.20 meters, 1.10 meters, but you do not really realize how big it is. So we used, this is an app we developed on the Android platform, and we're moving to, hopefully by the end of the year, to the platform HoloLens of Microsoft. But this helped us a lot to see how we can change, how we can improve the connection. Because we were thinking how they can bring together the two beams, how they can add the steel part to the column. And so after this movie, after this analysis, we changed a bit the connection. I cannot say that we saved 5–10% of the cost, we cut the cost, but at least we made the life of the assemblers easier on site. To do all those things, there is another word I really like, which is holistic. When you engineer a timber project, when you engineer a timber building, you must have a holistic approach, which means you need to take into account many different aspects. So if you're a structural engineer, it's good, but not enough. You need to know a bit about structural analysis, you need to know a bit about building physics, about manufacturing process, about how to transport the elements. And we are also working on a super strange project in Venice, which will happen in April, and we need to take into account how to transport the elements. To work in Venice, Venice is a beautiful city, but to work there is a nightmare, because everything must be, when you need to transport something, you get a bit crazy. So to explain you what we mean for holistic, I made this short movie with my little drones. You need to raise your point of view. You need not just to stay on the ground level as a structural engineer or just an acoustic engineer. You need to raise your point of view and to have a wide global overview of the structure you are engineering. So if you stay at 1 meter, you barely see that it is a building, but when you move up to 20–30 meters, like in this case, you have a wide view of the project. So DFMA plus holistic approach make possible this, to say it's not anymore what you see is what you get, but it's more what you draw is what you get. This means you draw something on your computer, and thanks to the digitization of the project, you are 100% sure that you will have on site what you saw on your computer. It is exactly very similar to using a 3D printer. So a lot of people now are talking about digital twin when they talk about cities, but we can use the same words, digital twin, also when we speak about timber buildings. Here is the BIM model, the IFC model opened in Revit and using an IFC viewer. You click on an element and you see who it is, the dimension, the thickness, how many layers of the CLT we have. This is a glulam beam, and you see all the information related to the element. GL24, the number is 854, the length, the width, etc. It doesn't matter how complex the detail is. It doesn't matter if you're talking about a very complex facade. The important thing is that we draw something, and then we are sure that we will see that detail on site exactly as it was on my computer in the office. There's another detail. So I'm sure that all of you are familiar with this image. It's taken by, from the movie Matrix. I think we are, in this moment, we are very close to this concept when we speak about buildings, about timber. Because we see this as timber engineers, we see this instead of solids, instead of beams, columns, etc. We have a digital model of our building. Thanks to this, we can quite easily prepare the CNC files, loading plans, assembly drawings to give to the assemblers on site. So, said that, we combined together all those technologies and we made a lot of experiments. We like also to play a bit in the office, to experiment, we spend about 400, 500 hours per year for a R&D project, free time, sometimes R&D project. And the first project we engineered outside Italy is this one. It is located in Singapore. It is the EJC, Eunoia Junior College. The government of Singapore wanted to go for green buildings, and they decided to have a concrete building, but to make a test using CLT for the facade. So it is a hybrid building. This is the digital model. This is the IFC model we shared with the other engineers. There were 2 engineering firms involved in the project, and one was located in Singapore and one in Vancouver. So different time zones, which drove us a bit crazy. Here you see we designed the elements thinking how they could be pre-assembled on the ground and then lifted and installed on the facade. They decided, because of the fire, to cover 100% of the surface using non-combustible materials. Unfortunately, I can't remember the name of the material they used. Then they added the membranes and then pre-installed some tapes so that the assembly on site was quite fast. Here you see the panels doing the assembly. You do not see that they are made of CLT, but trust me, they used the CLT and they partially pre-assembled the panels for the facade. This is another picture of the site when doing the assembly. So this is also another one. And here you see how we work together with the other designers to create, let's say, the details in order to guarantee the waterproofing of the facade. Because, of course, for the facade, it is very important to work on the static, but also on the detailing. So again, holistic approach to get to the best result. And this is another project, another great project. I really like very much this one. This is located in Italy, and we work together with a Façade producer. It is a headquarter of a company. As you can see, the facade is really complex, and there are thousands of openings with different shapes. The architects worked, and we worked together using Rhino and Grasshopper to create this pattern, this algorithm. And there are some seeds inside the algorithms so that all the openings are different. And you see here, there are some steel columns and CLT panels. They decided to go for CLT because it was the only way to be sure that the facade was looking exactly as it was on the computer. This is the digital model. We can call it digital twin. The IFC model, and then we use HSB CAD for the design of the CLT panels and to create the files for the CNC machines. It is a hybrid structure, again, because there are 3 materials combined together: timber, steel, and concrete. So there are 3 different engineering teams sharing the IFC models. We used that time Dropbox as a cloud system to share the files. We received the file and we added, let's say, the skin, the CLT panels. It was quite interesting to see. In this case, we worked quite a lot on the workflow to create the right workflow to combine together different softwares, because we were using some products, other teams was using another software, and there was a BIM manager collecting all the files together and sharing the right model for the clash detection. So here you see how we connected CLT to the steel. This is a big, huge cantilever. It's about 25 or 30 meters, because it is the theater, the main room, the main theater of the headquarters. And here you see again the production drawings. It shows how detailed must be a drawing for to prepare the files for the CNC machine, to prepare the files for the production, for the manufacturers. The list, element by element, because we created a PDF file per each element and the file for the machine, the BTL format for the machine. Again, some pictures of the panels. And here you can see how some pictures are doing the assembly. They covered, to protect the CLT, they covered with a white membrane the outside part of the panels. And here you see the theater, the huge cantilever I was talking about. And the view from inside, you see the CLT. Unfortunately, the client decided to cover all the CLT, so when you go in, you do not see anything about timber. They covered with gypsum boards and quite unhappy, but unfortunately they decided to go for this. Okay, the last 2 slides. This is an experiment we made in the office. This is my garage at home. I wanted to find a quite crazy client using this, because we wanted to prove that it was possible without any special skills to design this and to install it in a very short time. So I used me as a, I don't know the name in Italian, but I wanted as a tester. Let's say we have a specific word if you go to a hospital to be tested. But in any case, I decided to use myself, and we designed this. It took a few days to design everything, to prepare the files, and to create the augmented reality app. But then in 3 people, me, my brother, and one of my colleagues, we assembled everything in just 2 days because everything was perfect. We almost didn't use any tool. Everything was there with the small holes to know where the screws needs to be installed. And my personal opinion, but I think it looks beautiful, this. I really like it. So since I'm the client, I must be happy. And the experiment is to know, we spoke a lot about durability. We installed it 7 months ago. At the moment, it is still brown, but here in some parts, it is getting gray here at the bottom. I'm very curious to see what will happen in the next few months. Oh, I forgot, there is also this movie showing you how we assembled it and a short time lapse. I was waiting for the CNC machine. We prepared the files for the manufacturer. It's a small-scale project, but we learned a lot of things, how to manage also the large-scale projects, because you can really replicate all the aspects. And here you see how fast was the assembly. The orange one is me. Okay, that's it. Thank you.
Thank you, Franco. I can honestly say I'm quite jealous of your shed. So I might have to steal some ideas from you there. I think your digital twin, DFMA, and coming on into a digital world is something that we can all relate to, and hopefully it's going to progress as we go through time. Okay, next up we have a couple of speakers from Arab. Andrew Lawrence, who is the Director and Global Timber Lead, and Julie Schulz, who's the Timber Fire Director there as well. So, going up to the stage, guys.
Great, thanks, Alan. As a structural engineer, I'm actually really excited about the potential to use a lot more wood in our buildings, simply because we can actually lock away so much carbon dioxide. So I've got this vision that in 50 years' time, a third of our building stock could be made of wood. But I think, like all of you, I've seen the nervousness following Grenfell about combustible cladding. And so, Judith, you've done a lot of fire testing. I think I'd like to try and understand why is there so much nervousness about timber or combustible material in an external wall, particularly for sort of residential type buildings?
Well, let's have a look at that. So, the physics of the problem. We have a residential building here. We have lots of people living in it. It's asleep. Plenty of risky activities, cooking and so forth, that the building has provisions for to deal with. So with these types of fires, we have compartmentation in place to contain the fire within the compartment itself. And that enables other persons outside of the compartment fundamentally to stay in place if that's safe and if they choose to do that. If we now have a combustible external wall, then clearly that is a route for fire to spread. And if we look into that in a little bit more detail, often these external walls have cavities. So if we go through to the next one to introduce that, then that is also a route for fire spread. So if we click through, we know what we put in these. We have cavity barriers in lots of places around openings, at slab levels. If we have combustibles, we put them at closer spacings. So that is a safety feature that we do introduce into the external walls. The tricky thing with those is that they need to be installed the right way around. You can never inspect them again once they're in the wall. They're subject to all sorts of creatures, potentially nesting in them, so they're not the most reliable safety feature we have available. So if you click through. So these are the cavity barriers. We'll put them in the wall. Right, so we've dealt with fire spread in cavities. The next feature that is important is fire spread over surfaces. So to do that, we generally treat the outside. Again, that is subject to weathering, and fire retardant treatments clearly are available for combustible materials, which Claudia was alluding to earlier, but they are not particularly compatible with paints. They also don't last particularly well when they're exposed to weathering, so they need to be refreshed on a very regular basis. So again, not the most reliable feature on the lifetime use of a building. Then we have often structural elements that sit in external walls that also need to be thought about. So if you go through, here's a simplified steel element that exposed to fire needs protection if it's load-bearing to do its job in case of a fire. So it needs to be protected from the inside. And if it's in an external wall, it might also get exposure from the outside. So that also then goes into the external wall. So you can see it's getting quite complicated. And we're nearly there. So lastly then, the other important safety feature that external walls deliver on is limiting fire spread to other buildings. So if we have a building opposite, then I have an obligation to check that the risk to persons in and that asset itself is controlled. This is a bit close for comfort, so we'll move those a little bit further apart, because part of the safety approach to that aspect is to buy enough time so that the fire brigade can actually then wet down the adjacent building to limit that fire spread risk. The last thing we need to be cognizant of is that fires don't just start inside of buildings. We do have often balconies on the outside, and there are all sorts of activities that you and I love doing on those. So balcony barbecues, people might smoke, and it is very common that fires start on the outside of buildings because someone smokes and something falls down to the balcony below and then starts a fire there. So fire starts also need to be considered on the exterior. So we go through. So very common causes of fires occur on the outside. So these are all the challenges that an external wall design needs to consider in terms of fire safety for a residential building example here. We go through. So question for you then. What sort of forms would you like timber to use in external walls?
I guess what we all really want to do as structural engineers and architects is actually build in CRT. So it's my image of a CRT building is like a giant piece of flat pack furniture, which means it's a really easy, a really quick way to build. So entire walls and floors made of CRT. You probably won't see it because it's going to be hidden behind external finishes and internal finishes. Now, but I think even if you've got, this happens to be a glulam frame, but I think even if you've got a steel or a concrete frame, I really like the idea of cladding panels, which are actually lightweight timber cassettes with finishes on them, as you see here. And I guess finally, rather than having, should we say, normal aluminium louvers, the energy that you need to refine aluminium is incredible. If we could replace those with timber, then we've got a much lower carbon solution.
Good. Okay. So we've actually studied all of these different timber systems that you'd like to use, and we've come up with different fire dynamics mechanisms that we need to consider, and there's 7 in total, and we'll click through them to highlight where they are. The first one is via the perimeter stop at a floor junction, then bypassing compartment floors through the timber itself, via a window jam into the timber construction, in cavities, over the external surface itself, back into the building, and via leapfrogging, where you have such significant flaming on the outside that it might just enter back into the floor above. So there's a lot of different mechanisms that need to be considered when using timber in external walls. And that will please you, Andrew, if you go to the next slide. That actually is also replicated in a significant study that was recently completed by RISE, Swedish Research Institute, looking at statistical analysis of fires in timber structures, where 35% of the major fire cases involve the external wall as a mechanism for fire spread. So it is really important to get this right. And the other aspect that we need to consider is that we actually have had a lot of near misses with timber on external walls in various forms. So, for example, in 2018 in West Hampstead, that went fairly well. So there was balconies made from timber that spread over the full height of the building because someone had a cigarette on the third floor and the fire spread up and down. 5 homes were damaged, but it didn't go much further because there were sprinklers on the inside, which activated on 5 floors, and it was bounded by brick left and right. The Barking fire that you will all know is a significant fire where 10 homes were damaged. People were displaced for a very long time. It was an absolute mess to try and get people rehoused. And equally, the Cube fire is probably very well known, that used a high-pressure laminate, so a wood-based product that spread very rapidly and really only didn't cause a death because the fire brigade rescued 2 persons through ladders. So we do know that timber can really be a very significant hazard. So tell me about what you know about material properties then in timber.
Okay, I'm going to limit myself to fire properties of timber for the purposes of this discussion. So to be honest, and particularly if you'd asked me 2 years ago, I'd have been very optimistic about the fire performance of timber, because to me it chars really slowly, and that char is a good insulating layer, so it's sort of self-intumescing. And so the timber member, if it's thick enough, can actually survive quite a long time. This is a picture of a charged member, and I think, of course, we know from the latest sort of European codes that actually that heat damage layer does penetrate a little bit deeper into the wood, and particularly at sort of junctions between panels, as we can see here. Now, I do realise that we're going to get more, probably longer and hotter fires if we've got a timber structure that's burning. But again, one of the things I hadn't realised was about smouldering. So I guess I knew that if you had a fire in a fireplace, that the timbers could sort of smoulder and occasionally recatch fire. But it was only when this happened. This is right next to Finchley Road Tube Station, which is where I use every day to go to work. And this was a fire inside this Victorian building. But what really surprised me was it took the fire brigade 2 days to put the fire out, because the fire was smouldering and spreading inside the wall and the floor cavities, and because it was inside the cavities, they couldn't get at it. So from this, I start to understand what you're talking about in terms of fire in cavities.
Yeah, good. We go to the next one.
So,
is there a safe way of using timber in external walls? You'll be pleased to know, yes, there is. But it really is important to consider these hazards that we talked about. So in low-rise buildings, where, for example, it's constructed as a single compartment, there's very rapid evacuation times, good fire brigade access, absolutely reasonable and good application of timber. Clearly, you need to think about proximity to other buildings, but that is a good place to adopt that material. If we go to higher risk buildings, and here's an example of a high-rise residential building in Holland, over 20 stories tall, maybe not, right? So in this building, there was a very careful consideration given as to where we make use of timber to have the most impact in terms of carbon, and the decision was taken to not put it in the external wall, but use it in the structure and have a way to expose a controlled proportion of it, so you can still get a sense that it is a timber building, but deployed in a way that we're still comfortable that people are appropriately protected if a fire was to start in that building. So these higher risk buildings, high rise, people with vulnerable occupants in it really do need a holistic approach if timber is to be adopted. And the important point to consider here is that, unfortunately, at the moment, in the UK, we do not have a design framework that really considers the hazards of timber properly, and our tests that we have are not set up to capture all the different fire dynamics phenomena that I talked about. So to get the evidence base for using this properly is typically actually very expensive and takes a lot of time. So 8414, for example, can't be used for load-bearing elements or timber substrates. It doesn't quite measure the right things. So it is currently really needing a first principles approach to get that evidence base. It also is important to remember that building regs deal with really only life safety. So asset protection and resilience in the long run are not covered by building regulations, but of very keen interest to insurers who are ultimately asked to underwrite the asset. And what we are finding a lot on projects we're working on, there are very few off-the-shelf products available that you can use with timber. So there is always the risk that delays happen because of products needing to be actually proven for their application. So in Arab, we have invested a huge amount of time and effort and money to create that evidence base. So you see here a snapshot of a very large compartment, 380 square meters, that we have set on fire to understand fire dynamics. That's also important to understand the severity that external walls might be exposed to in fire, to study smoldering. We've developed a test method that we think captures all the relevant criteria that we could use, that catches them all in one, maybe two tests, and not a very large number of them. So we're ready to engage with those that are really keen to take the safety aspect as seriously as the sustainability aspect. And just to wrap up as a final consideration, go to the last one, I think it is really important to consider the design choices one makes. And I've been reading a lot about safety systems recently, and it really struck me that the hierarchy of controls pyramid that are very familiar to those that are delving into health and safety at work issues is one that, as designers, we maybe shy away from a bit too much. So it starts with the highest, most effective aspect, which is eliminate the hazard in the first place, and then goes down in terms of effectiveness to substitution, engineering controls, administrative controls, and protecting PPE type equipment. And if we apply that kind of reversely into a timber external wall setting, then our PPE is kind of the fire brigade, hoping that they'll deal with the hazard. Administrative controls are those where you ask people to change what they normally would want to do. So no barbecues, no smoking. I don't think that's really the way we should design buildings. Isolating the hazards, so treatments, maintenance provisions, they can work, but they really need to be factored into the lifetime use of the building and costed properly, otherwise they won't last the duration of the building. We can replace and remove people, so large-scale evacuations. For some buildings, that's absolutely fine. For others, that is immensely disruptive. So there are certain applications where really timber maybe isn't the right material in an external wall.
I've got one more question for you, actually. I mean, the cladding ban.
Yeah.
Is that a good solution?
Well, so I'm personally not a fan of bans, I have to say. I do like design flexibility, but you can, I guess, appreciate that given the reluctance maybe of making the top most effective decisions in the past of using materials in the right application, that taking away the toolbox was the only way that was seen to be achieving the impact that was desired. So I think it comes to the designers to prove that they are trustworthy in making good decisions that consider safety as well as sustainability.
So let me see if I understand correctly. So I think what you're saying is that we need to be really careful about timber and external walls for all the reasons that you've talked about. I think, in fact, what you told me is that actually some countries, there are codes and guidance which is specifically designed for combustible materials, but what we need to be aware of in the UK is that our guidance and our test standards were not written with combustible materials in mind. And so at the moment, until those are changed, we need quite a project-specific approach to fire safety. Is that right?
No, you got that right. So, and the project-specific application is, for me, it's really exciting because it really allows a very holistic view on how we make safety part of the overall story of the building, but it does take time and it does often cost a little bit more. So it is important to consider that, and if that is not possible in the project, then we do have other options available. And ultimately, safety is part of the responsibility of a designer. And for me, to be a truly sustainable development, the design solution that wants to use timber in external walls does need to minimize, of course, resource waste and carbon emissions, but it does need to stand the test of time, and it does need to create a resilient built environment that can adapt to the safety requirements of clients in a rapidly changing world. Thank you.
Thank you guys. That was really fascinating. I think with timber design and fire is always a really interesting subject, and it's really good to see that there are sort of pathways to make it acceptable in there. And it certainly makes me reevaluate the dangers of smoking. So I think that should be in the warning packets going forward. Okay, next up we have a director, Max Durat. And you're going to talk about from aluminium to wood unified facades. And you're director from Gutzmann Bosia Systems. All right, thank you.
Okay, good afternoon, everybody. It's been a long day, and we have been hearing a lot about timber and timber aluminium facades. Actually, we are the third company to present a system in this sense. And sorry, that was the surprise, but I just wanted to start. We have this Jeff Koons dog, which I personally like, and probably many people have seen it before, which now is being sold in wood. And like this Jeff Koons dog, you can also think about more profane things like a toilet seat, which could be also done in wood. And it seems that anything that we are using, like a toothbrush, or yesterday when I had a coffee here in London, the spoon was a wooden spoon, because that was a very fashionable place I went, and you have to serve things now in wooden environment. So wood is everywhere, and it seems that anything we are doing should be wood right now. So the question is obviously, can we build them in wood as well? Yes, we can. I mean, we have always done it, and the historic and traditional way of building buildings, at least in many regions of the world, was building in timber. So it's nothing new. It's something that is traditionally being used in construction, and was for a long time the main construction material that was used. But what about high-rise buildings? I mean, here we are going into a different field and something that we are probably not so much used to. This is not from us. I mean, I've just picked a few pictures, and I think it's obvious to this crowd here. To other people it might not be that obvious, that we see a lot of architectural designs and proposals for buildings. This is a project in Japan with a tower of 350 meters height, fully built in wood, which is not yet built, but under design. This is a competition entry in Germany. This is going to be built. It's a quite recent project from the mad architecture also a wooden structure, high-rise building, residential. And I could show probably 1 hour more pictures of buildings and design proposals that have been issued in the last few months and years. So Goodman, as an aluminium company, for us, this is nothing new. Actually, our main market is wood aluminium systems. So we have the aluminium cladding on the outside shell for wood aluminium windows, wood aluminium doors, sliders, curtain wall systems, wooden mullions and transoms, and aluminium outside. So this is our traditional business. It's nothing new. It's something that we are used to do, and we have our customers in this area, and this is one of our major markets. So this is also a wood aluminium window. So from the outside, it's obviously aluminium cladded so that the wood is protected from the environment, from rain. It's good for durability. And from the inside, you have the image that you have seen just before. Goodman, as an aluminium company, and in other parts of the world, for example, in the Middle East, where we are very active on large-scale projects, and also in Germany, we are used to build in all aluminium systems. So we have the full range of products from doors, windows, curtain walls, and also unitized facades. And this is just one example I picked, obviously, because it's here in London from Foster's and Partners. One project that was realized using Goodman profiles, a typical unitized facade scheme that you could see on many buildings. Another project in Berlin where we are using our all aluminium or full aluminium systems. So we are quite comfortable in both worlds. We are serving the residential market mainly with our wood aluminium systems, and we are also serving the office buildings with our all aluminium systems. But who is actually building unitized facades? Because what we are presenting here is a unitized facade system. So unitized facades are typically all or full aluminium systems, and the customers and the fabricators who are building those systems, they are equipped with machinery to drill and cut aluminium profiles. They have the whole setup for building aluminium frames and for building these units. So this is how a typical unit production would look like. This is one of our customers in Germany, but any customer who is building these all aluminium units work more or less in this way. So it's fully prefabricated, off-site, and then brought to site and installed on the building facade. The wood production, obviously, the customers we have in that area, they are completely different animals because they are using different machines, they are buying the wood, these squared profiles, they are then milling those to the final shape, and they are building the wooden frame, and they just put the aluminium frames on top of it, they clip it, and they don't have the machinery to use aluminium profiles or to produce them. This is how a typical wood window factory would look like if you go inside. So it's a different world. Then this is a picture I had the chance to take yesterday, just walking around London, and I was lucky enough to see how they were installing here one of those typical facade units. I think it's a permasteel building. So what is important in this picture for me, a unitized facade is after the main structure of the building, the second thing that is going to be installed on site. That means anything inside the building is not yet done. So there is a very long period from the time the unit is installed until the building is actually getting finished, where these units are exposed to all the risks that you have on a building site, meaning humidity, temperature changes, dirt, and people running around, different craftsmen who are finishing things, and they may not pay really a lot of attention to the facade units that are already installed. So this is somehow the introduction, and the main idea of our system is the body-to-chassis marriage. And as a German company, I mean, you need to have somehow this relate back to the car industry. In the car industry, this is something very typical. You call it the marriage, either of the chassis and the car body, or in this case, it's the engine. I thought it's a nice picture of this marriage, the rings here at the end on the two hands. So this is basically the idea that we are coming up with. We are designing a unitized facade system where we are producing two elements which are then married on site at a later stage. So you will see and understand that a little bit later. So basically, we are trying to combine the best of two worlds. We have been doing this in our window wood aluminium systems for a long time. I mean, we have all the advantages. We heard a lot about the carbon footprint of wood compared to the carbon footprint of aluminium, which is obvious. But we also have heard a lot about the different properties that we have from wood and also from aluminium. And we think that the combination of both and the intelligent combination and use of the aluminium where it makes sense and wood where we can use it, that makes really the difference. So the production, it's perhaps not that romantic on the wooden side as many people might imagine, and even myself, because before I started to dig into this world. So on the right-hand side, we have our extrusion plant. This is one of our extrusion presses. And on the left-hand side, we see the fabrication of the timber units that are later then used for the window production and also other products. So we are based in Bavaria, just between Nuremberg and Munich, where we are extruding all our aluminium profiles. And we are sourcing the wood for the wood aluminium unitized facade also in the same area, very close to the Czech border, which is called the Bayerischer Wald, which is a protected area. So it is a forest that is sustainably managed, and we source the wood for our system from this area. I think that's also an important aspect and was mentioned many times today, that using wood is also helping to reforest or to manage forests in a good way. So now finally show some pictures of our system. If you are interested, I'm not going to show a lot of details here. It's, as you saw on the other systems, it's the basic construction principle is our unitized system, the aluminium unitized system. We can use all our testings and all our the performance testings that we have done on rain tightness, air tightness, etc., from our aluminium system. And we are substituting partly the walls of the aluminium profile by a wooden shell. What is important here that we are not only cladding the aluminium profile with the wood as an aesthetic element, but it is part of the static performance and overall performance of the system. So that means that the wood here is part of the whole system. And that also means that we are going to supply everything to our customers. So the aluminium profiles, the gaskets, all the accessories, and including the wood cut to size and delivered to our customers, either to their workshop or to the building site. Just a few images. You can see that in real outside. I think I can skip this relatively rapidly. So this is how it looks like from the outside. It's a classic aluminium unitized facade aspect. From the inside, you have then this wooden aspect. So you can see here that the woods are straight cut so that we are able to combine the aluminium profile with the wooden profile once it is installed on site. So the main topic that we have been looking at is actually the static performance of the overall system. So that's a nice German word. I just wanted to write it here. There is a longer one which comes later. So we call Tragfähigkeitsnachweis. It's one word, I swear. You would say ULS, ultimate limit state. So what does this mean? That means that we are able to produce an aluminium frame which is self-sustaining, is strong enough to produce it off-site in the production of our aluminium customers who have all the machines and all the know-how to do that. They can transport this fully glazed unit and they can install it on-site without the wood. And just after that, so this is how this aluminium chassis would look like. I mean, here it's obviously without the glass. You can see also one of our customers who is sitting here in the front row. He was the first one to build our facade. Actually, we are just about to install the facade on the first building in Germany. And here we are looking at the testing that we did, and you can see here a lot of thinking going on. But the basic idea was to deliver this aluminum chassis, install it on site, and then once we add the wood to the aluminum chassis, we get this, Gebrauchstauglichkeitsnachweis, which is also one word. I mean, in German you can play around with this. You would say SLS, or serviceability limit state, which means the self-sustaining aluminum frame is strong enough to be produced, transported, and installed, but it's not strong enough to open the building to public. So this we only achieve once we add the wood to the aluminum. Here are some pictures and close-ups. You can also see that outside if you're interested in those details. So we have a way of clipping the wooden profiles, or the wooden load-bearing shells, as I would like to say, on top of our aluminum chassis, and then, only then, we have the final performance, static performance and aesthetic performance of the unit. Just one slide on building physics. I mean, the main concern we had is about humidity, condensation, humidity in the wood. That's the reason why we did this two-step process, or we designed this two-step process. And obviously, we did some calculation here to make sure that we never have, I think this is the most critical point here, where the wood comes very close to the glass and to the aluminum profile, that we never have any condensation at that point. And that's actually the case. So the upper one is more related to the normative conditions that we have to fulfill. But we also did a little bit more extreme calculations and simulations with minus 20 degrees outside, 18 degrees inside. And still with these conditions and a significantly less performant glass, we still don't see any condensation at that point. So that was very important for us. Again, the best of two worlds. I mean, these are not yet finished projects. We are working on a project, and I was yesterday sitting in a design meeting, and I was really surprised because it was so similar to this rendering that we did. And it would have been nice to see this as a wood aluminum facade. I think exactly the same skyline that we have imagined. So that's it. Thank you. If you're interested, we are outside.
Thank you, Max. That's really fascinating. I'm going to attempt to fill the air for 2 minutes while these guys sort out the seating arrangements. I thought I'd reflect a little bit on what we've all been hearing today. I said earlier that the common theme would seem to be passion from a lot of people in the industry. And I agree. I think that is what we're seeing so far. But I also think what we've got in here is a lot of creativity and ingenuity, and it kind of gives you hope that we are great problem solvers, and we have a problem with carbon and sustainability that we need to solve. And I think we can really sort of meet that head on. And it makes me think about the potential that if we didn't create our own problems, how would we be in solving other things? So hopefully that's enough, and then you guys can get cracking on that. You want to say a few words about people who unfortunately couldn't be here?
Yes. So, can I have the, turn the screen on? How you doing? Right. So we have this panel discussion now. Unfortunately, John Downs can't make it in person. The little one got him today, but he was very instrumental in getting this panel through and ensuring that this project is being spoken of. We have Peter, who would be taking his place instead as the moderator. So I'd like to thank John Downs from Lend-Lease personally for making this happen. So thank you, John, if you're watching this live stream. I'll introduce the panelists. Peter? Or will you do that?
Everybody?
You'll introduce the panelists?
No, we're not going to introduce the panelists.
No, the names.
Oh, right, yes, certainly.
Right.
Hi, good afternoon, everybody. Hope it's not too bad. It's quite a warm room, isn't it? So we have here, I'm Peter Runacres, Argent. Development Director, largely looking at the commercial at King's Cross. We have Andy Martin, Director from Google. We have Andy Young from Big. We have Julia Erdem from BDP, and we have Frank from Gardner Permastleser. So,
who's controlling that?
Oh, right.
This is a double thing.
Okay, thank you. Andy, I'll give that to you. So you'll have to forgive me, I'm not John Downs. Thankfully for him, I look nothing like him anyway. Sadly, he's ill, and we wish you the best, John, and get back soon to full fitness. So, very quickly on, it's a real pleasure to introduce this project that some of us have been working on for best part of a decade now, and some people even longer. It's a heck of a scheme, as you're probably all aware, and if you've been up to King's Cross, hopefully you've seen the true size and scale of this building as it's coming forward into real fruition now. It's a stunning building, and I think it's going to be an absolute cracking addition to London. It really is. Simple stats, really. It's over a third of a kilometre long. We often describe it as the Shard lying down. It's 16 metres wide at the southern end and about 7 stories high, 65 metres wide at the northern end and nearly 12 stories tall, if not slightly more. It's a heck of a scheme, so what I'll do is we're going to go through in a fairly short order, hopefully, because when we did this a couple of years ago, the most interesting part was about the questions from the audience, and I'd like to keep it that way today, if at all possible. So without further ado, I'm going to crack on to my colleague and client, Andy Martin.
Thank you, Peter, and good afternoon. I just want to concentrate a little bit on the client brief at the inception of the project, and then we'll follow on to some of the more technical nature of how the facade has developed. But the sustainability was at the core of the brief. Obviously, it was the brief was 60,000 square metres net internal area and various other fixed parameters, but sustainability has always been top of our agenda. And maybe that's moved on a little bit. I'm sure you're aware of some of the commitments Google has made as a company, and especially at COP26. Now, on a consumption side, we've got to achieve zero carbon by 2030, which is no mean feat. And so we're looking at how we do that. But going back a few years when we started to design this, it was the embodied carbon which was top of our agenda. And what do we do about that? How can we have a much reduced impact on the environment? And we strongly believe that sustainable workplace is good for people and good for the environment. So we wanted to do something. It's an enormous building, consuming lots of carbon-intensive materials. So how do we reduce that? And we started with the introduction of CLT floors. And so we thought that was going to be the main focus. It evolved into the facade, and Andy will come on to how that decision was made. But it's helped us really change the game. We did a whole life carbon assessment very early on in the design scheme, and we've managed to reduce our carbon by about 23% at the last measure in stage 5, largely thanks to the use of timber, initially, as I said, in the floors, but more recently in the facade itself. And so that brief, we had to achieve a building that was ultimately flexible internally, because designing it such a long time ago, we didn't quite know how we're going to use it. We know how many people we probably want in it, but workplace is evolving. And luckily, we've planned and are executing what we think is an excellent building. And at that, I should have pointed out that the 100-year life cycle of the building, that's another unusual thing, but I guess an owner-occupier can afford to do that. It was a game changer for us, but again, it's to reduce our overall impact. So we know we want to control this building and use this asset for a very long time. Anyway, over to Andy.
Thank you, Andy. So, first of all, what is the building? My goodness, it's basically 3 absolutely gigantic rooms, each room varying between 2 stories high and 3 stories high. They're stacked on top of each other. On top of that is a big area with amenities, gardens, and facilities. And then underneath at street level, something which is perhaps subject to a bit more change over the life of the building, relatively free area where we can have retail and other facilities. But the building is quite remarkably 3 huge rooms. As Pete said, each room is as long as the Shard, and each one is about 10 meters high. The way that we arranged that in the design of the building was to create a relatively, if you like, firm structure, superstructure for the building, consisting of columns right to the top of the building, a gigantic transfer structure, and then 3 huge workplace floors. That, in this day and age, that might not be considered to be the right thing to do, because the focus on carbon and embodied energy and so on has become, is something that's become very, very much in focus. This was in 2016, 2015 sort of time, and we simply had a very enlightened client who brought things to the agenda for us as designers. But most importantly, what we chose to do here was to focus on a building that would not ever become obsolete in our view. Inside these 3 gigantic rooms, a series of mezzanines are added, and the mezzanines contain lots of facilities for the building and things that aren't necessarily workspace. And critically, those mezzanines change their shape and they cut back so that daylight can penetrate deep into the floor plates. So what that means is that in the early days, we envisaged an interior which was 10 meters high, with loads and loads of workspace, very, very well lit, lots of amazing natural lighting, and then a series of servicing mezzanines up above. You'll notice in this picture that there was no timber in the facade, and in actual fact, we had it in mind as designers that we would try to make a fully glazed facade that was very, very smart in its operation. It had active shading inside of it, and it would be a genuine smart facade. And we wanted to do that with just glass in the first instance, create an incredible lantern-like facade. We did many, many studies on how this all-glass facade would actually work, with blinds from the top and blinds from the bottom that kind of passed beside each other to get lots of different conditions and deal with sunlight in lots of different ways and solar gain. We took that quite a long way, and we put that in front of Andy Martin, among others, and we said, look, we have our design team preferred option here is to go for this gorgeous lantern-like all-glass facade, and we did investigate another option. We called this one the smart option. We called this one the smart dumb option because it was kind of a bit dumber. A lot of the work, heavy lifting, was done by simply orientating a sawtooth facade. But we all kind of fell for the idea of the lantern as an idea. And Pete had said to us on this job, you will damn well make sure that this is a job that Google want and not the job that you want. So we will go through a very strong process here, and we'll design the building exactly what they want. And then, then we took it to the planners. Right. So we went to the planners, we got involved with their Jarvis, who's a very, very kind of like clever guy. And it's a very, very rare event, actually, that going to the planners doesn't improve your building. I know that a lot of architects complain about that whole process. But in the most dramatic sort of oversimplification of a year of my life, in the end, we ended up with a timber facade with a lot of variegated panels, and we adopted a system whereby we used timber as a structural material. We used timber as a material for the envelope that had a performance to it thermally, and we put together something which is going to be, and indeed is, Frank, one of the most glorious and spectacular things that you will ever see in terms of workplace buildings, shall we say. Here is a picture of how that panned out. You can see the sawtooth shape is variegated, and it will deliver some solar shading just simply through a passive design. Other areas of the building will be, each one of those panels is doing a particular bit of performance at a particular time of the year and day. What that means for the interior is very, very similar to our original intent, but now with super warm timber mullions rendering the light a bit warmer in the building. We went out to a professional rendering company to draw what the building would look like on a fine summer's day in London. And then also...
It never rains in London, does it?
Well, some of the guys that came over from our American office also did their own render of what the thing would look like, and it was pouring with rain in that render. So what I'll do now is I'll just, I'll kind of like hand over to Julia, because when we made this switch to the the timber system, it was kind of my observation, I suppose, that we could use log cabin technology here. Right? So you would just use a big chunk of timber to do a ton of work. It could be the envelope of the building, it could be the insulation, it could be the waterproof membrane, and it could do a structural job. And without further ado, I'll let Julia tell the rest of the story.
Okay, I'll probably stay seated, not to block the view of the screen too much. So we've been on board as executive architects, so that's BDP, since about 2016. We've worked together with Big and Hasselbeck in the early stages of the project. So we were part of all this evolution of the facade when it went from a fully glazed system to what the concept is here now on the screen. So that more passive approach to shading and introducing more solid elements, that was really quite a long process through several studies, and those lovely blinds you saw there earlier on any slides, they're actually still there, but they're just there for glare control and privacy, rather than performing in a solar way, because that's actually all achieved through the mullions and the glass. So just to go back a bit to the early stages, we had this lovely site here with Argent and Google. It's located right next to the King's Cross railway tracks. You've got office buildings right next to it as well, just the boulevard in between. So there was always the issue of noise, pollution, the issue of overlooking, the issue of reflective glare even from the other buildings. So to introduce these more solid elements made sense in that respect. So also in terms of this diagram, you can see how close the train tracks actually are. So the installation, which Frank is going to talk about a bit later, is also quite a challenge. So the whole system that was developed needed a very specialist approach. So I just wanted to mention that we worked closely with a lot of other consultants. We had Arab Façades involved. We had Austin Fire involved in the assessment of the fire and especially the use of timber in the project. So when these timber mullions were introduced, it was partly also in discussion with the planners. They wanted a bit more variation in the facade. So what you see here in white, it's actually quite an old image, still concept stage. And what you see in white here in between the green elements, that's actually facade gardens. The green elements, that is the timber glass facade. You can see here the orientation of the mullions actually varies between north orientation and south orientation, and then we've got transition areas as well. So it's quite an animated facade now, where it went from the glass box, which was a really different approach, let's put it that way, to this very animated timber glass facade. And just to also demonstrate the, oops, is it working? Again, very early stages, just to show, we've got these panels. That's a 9-meter structural bay that you see here, and that is split in various ways. And the 6, I think, that was early on. So it's mainly the 5, 3, and 4 we've got in the gradients. But you can see the percentage of solid elements that we've introduced through this new concept, really. And I think it's probably 90 different types of individual mullion shapes. So there are similar mullions, but it's not a repetitive system. It's not that you've got a stick system, you use your certain size. It's all varied and very bespoke.
Yeah, so we have about 940
mullions, individual mullions, and
yeah,
probably 90 types. And, depending on the location of the building and depending of the function where they are.
Not only that, they also vary from 2-story to 3 stories in height.
Exactly.
And that's one of the big considerations as well, which alluded to the depth of some of the timbers that we ended up with on the facade.
Yeah, just to get a feel of the scale, a single timber mullion, as you said, it could be up to 3 stories high, so 10 meters, and the footprint, it's roughly 700 mil by 360 mil for the typical ones. So there we're not talking little elements, we're talking proper tree trunks, and they're all glulam timber.
Yeah, well, actually, the weight we had to handle was about more than 2 tons per timber beam, and we can show a machine later on how we handle them on site. Yeah? So let's look at this later on. Yeah,
yeah, right. So that original concept of having that log cabin type approach, we looked at very carefully. We looked at different timber species. We looked at the performance, at conservation risk, and everything. So in principle, that could have been made to work. The consideration then was, what will it look from the outside? Will we always be happy with it? We've got this really long-term approach to the structure, and you mentioned here the 100 years for structural elements. Obviously, the triple glazed units, which we've got in the facade, will never last that long, but obviously to use the timber as a structural element here to retain the facade, it should be as durable as possible. So in considerations, we ultimately came up with that solution here that you see on the right-hand side, which is basically a sacrificial layer which protects the structural timber mullion further from the elements. The performance, I think you are going to talk about a bit later on, Frank. But just to mention, the external part is actually a coir that was chosen especially because of the properties we heard about earlier, the 6 years design life. And we are actually using it on this project in its raw form, so it's not coated at all. And we've been able to achieve that through a lot of studies. So Olsen Fire, they confirmed, and it was verified by the BRE, that we wouldn't need any Class O treatment on this. And so the concept also from Big and Heatherwick was to have the timber as natural as possible, and then obviously to reduce any further maintenance later down the line. It was really, we wanted to embrace fully that natural appearance of the timber at the time.
Which I think you're going on to.
Yes, yeah. We've got some slides here. So this is showing just examples of uncoated timber. What you see here at the bottom was actually what we had on the planning boards. So we had the coir samples early on, and then as they would weather, obviously due to certain elements being sheltered more, you will have differential weathering over the different mullion locations as well. But everyone bought into this concept that timber is a natural material, and we managed to achieve to do all those studies to make that happen.
Maybe it's worth to mention that we bought the Acoya, the actual wood we bought in Spain because of sustainability reasons.
The earlier versions that we were looking at was importing Acoya all the way from New Zealand, which is not really sustainable. So we sought out more local suppliers of the Acoya material, type material, as Frank's alluding to, which we found in Spain. Do you want to crack on to the next slide, please, Julia? And we can talk about some of the other rotating fins.
Yes. Do you want to go ahead?
I was just going to go. There are some other key timber features. I want to get on to the technical side of this very quickly and then actually into the discussion, because there's a lot to go through in this building. So one of the other key features of the building was at the south, which fronts onto Battlebridge Place. If you know King's Cross, it's probably the most preeminent facade, certainly around King's Cross and Euston. And it has these massive rotating timber fins. And we went and tested it as a team. And you can literally push them with your fingers and they will rotate, and they're 2 stories high. They act as a solar shading on the south facade. Thank you, Julia. Here's the mock-up. They act as solar shading on the south facade, but also they can act as a screen and an interactive element for Google and for various other parties as the building kind of changes its use through life and through days and weeks in operation in and around the estate. So this is the scale of the mock-up that you kind of see, and this is one of the 2-story elements. Do you want to crack on?
No, I just wanted to say, so yes, that's the 2-story element. As I said before, that is the smaller ones. We've got, on the east and west facade, we've got the 3-story as well. This is actually not a coir in the mock-up, so that was just to simulate the other elements, so it's not always the real materials. You can see there on the side, just in case you're wondering, there was some testing in terms of coatings, which was more for the internal elements as well. But these are just going to be really, really interesting. So if you come to Battlebridge Place, and you will just want to be there and watch them move, because it's going to be very interesting in terms of how it really changes over the time of day, and it's actually linked to the weather station as well on the roof.
It is, yeah. If you want to crack on to the, you're going backwards. There we go. Over to Frank. One of the interesting things, if you go down to King's Cross now and you actually walk around the site at the moment, you can see virtually all of this going up. It's a fantastic time to go down there, because you'll be able to see all of the things that Frank and his teams are putting together, actually installing them on site. You can see virtually every phase of the cladding install, which is fascinating. I strongly recommend you have a look at it right now. Crack on, Frank.
Okay, so I mean, for us, the challenge started when we were on board, yeah. And just to explain, I mean, on the left side is the section of the building, and just to repeat that the slabs are hanging, and we have these 9-meter long trusses, and basically the facade is a big window wall system, yeah, with 10-meter long mullions in between. And I mean, we took the details and draw the first design proposals. On the right-hand bottom side, this is the spandrel, basically, yeah, to give you an impression. The concrete element on the side is about 1.5 meter high, yeah, to see the dimension. And the spandrel structure itself, it takes the weight of the mullions and the curtain wall, and does not transfer loads into the slab edge. So we only transfer horizontal loads into the slab edge. And yeah, there on the bottom side is the typical mullion detail, is one of the types we have. And I mean, it shows what we have seen before today. There is an aluminum profile. We use, let's say, a typical dry glazed system, which doesn't require any silicon sealing or so from the outside. And yeah, so this is the design concept. Yeah. Then, yeah, we went into looking into the timber, which was special for us at that stage, and we did some research. And yeah, one of the interesting or one of the important studies we did, we heard that also today a couple of times before. Since we had to figure out where actually the moisture distribution in the mullion is and where the dew point is, so we made a thermal assessment of that mullion, and the fact that the mullion is part of the thermal envelope, and you have an external and an internal side, made it even more complicated than just in a normal timber facade. And this was especially important because we have steel inserts which go into the for the connections, and they are not accessible anymore. So with the background of the lifetime, we have to make sure that there is no moisture or condensation which cannot be drained out anymore. So, and another interesting thing which is logic, but we found out that because of the moisture content, there would be a quite significant distortion due to humidity, and that was another complex thing what we had to consider in the glazing detail. We have round about 940 of these massive timber beams. There was about 2,000 cubic meter of laminated wood required, and it was relatively early. It was clear that we had to team up with a specialized company who can supply this quantity and also can fabricate these elements, and also can support us in with the technical competence to look into the timber specific issues. So the company was Hess, and this is an image of their facility, and what you can see, I mean, it's a combination. They use the timber, and they have a big CNC machine. But also on the next slide here, you can see that there's a lot of manual work required as well. Yeah. So on the left side, you see an already machined element, and on the right side, this is a mullion which is almost ready for shipment to site, and you can see the brackets for the sacrificial layer, and there is a protection foil behind to protect the actual structural beam. And on the right side, you see an aluminium profile, which receives the profile which is attached to the glazing. So we have a lot of prefabrication, and we always try to use our, let's say, technology from the unitized facade. Just to show what level of detail goes into the design. This is not timber specific, but the glass support is designed in a way that we stack the glass on top of each other. We have triple glass, 3 meter wide, 5 meter high, and each glass panel is around about 1.5 tons in weight. And it was stacked on each other in order to deal with the deflections we have caused by the hanging structure. And here on the right side, you see basically the setting block detail between the two glass panels in order to make sure that there is no stress exceeded. And on the left side, this little machine is what we call the rocker beam or rocker element.
I think actually, if you go on to the next slide, Frank, this kind of shows it all. Because the one thing that we haven't mentioned really, and you've just mentioned it, is that this is all a hung structure. So if you remember the image earlier that was shown in Frank's earlier slideshow, that you saw the giant trusses at the top, all David at the back is cheering for them. So all of this facade is hung off of those giant trusses, apart from a small area at the front of the building, at the southern end, which is gravity structure. So the point I was going to make, and Julia alluded to it here, even though there's a small number of us on the panel, probably, as a development manager for Argent and for Google, I've never had to work on a project where we've had so many individual elements of the industry come together in one facade. And some of the ingenuity that went into it, from everything from the hung structure to the little rocker mechanism. And the reason I wanted to push on to this was because you're starting to look at how the big timber elements are actually fitted onto the site. And you're going to show that, I think, later how you develop that technology. It took all of the interactions of various elements of the industry, more so than ever before, because this was such a stunning and interesting facade. Everybody wanted to be involved in it, but everybody added to it as a whole. So it was a real team effort. And just the sheer complexity and the detailing that goes on to develop that rocker mechanism because of the shifting and the movement that we are likely to have, and getting those glass panels in on these hung structures in against the timber elements was really, really quite complex.
So, yep, this
Alice,
is actually
who is Alice?
Exactly. So this is Alice. This is a machine we developed. There was the need to or there was a requirement on the east side, especially on the east side of the building, where the building is next to a network rail, and we are not allowed to oversail the railway, and it's not possible to shut network rail down. So basically, it leaves us only a 3 meter wide strip, which we have to use for installation. So. Already in tender phase, we came up for developing a manipulator, which can be used with a tower crane and lift the beams in. Yeah? So it would pick up the timber in horizontal position, turn it, and then we are able to shuffle it in between the spandrels.
So to give you an idea, Alice is the rotating nib there, which is hung from the crane, so one of the main luffer cranes up above. And then, as Frank said, you have to lift it up from horizontal, turn it, twist it, tilt it, get it in, under, rotate it to one of the rotation positions for the facade, put it down, and then lock it into place. Easy, eh?
Yeah, this is just, let's say, a stage of the installation. You can see the spandrels from the underside, and you can see that they change the shape, and they get narrower and wider, and we have overhangs and underhangs, and there is some repetition, but also not, let's say.
Keep going.
Yeah, and last but not least, I mean, this is the precast which goes onto it afterwards. I mean, again, precast is 9 meter long, and it's 1.5 meter high, and different shapes, and I think we have around about 500 elements in different lengths. Yeah. So this is again the precast. That's the finished segment, already with the sacrificial layer on. Again, you can see the shape of the spandrel, and the glass being installed there on the top, with a counterweight device to get inside. And this is view from the inside, which we took. Is probably showing, how it will look like from the inside when the building is in operation. Let me see. John attached these videos to the presentation. I actually don't know how to start them.
Have we got the videos? Thank you. So as you can see there's one of this is Alice in action, which is quite astonishing.
The left is also a video?
Okay. No, I'm asking. I don't think so. Are both videos, Frank?
Yes.
Yeah.
Okay. So
I'll play the other one.
So one of the amazing things that we were able to see was Frank and his team, to test this out, went outside, chopped down a fir tree, brought it into the factory, and then started testing the early prototype of Alice around. And that was quite something to see this giant full-scale fir tree rotating inside a manufacturing tin house. It was quite something. So it has to counterbalance all of those rotational forces whilst being hung from a jib. One of the things that Andy from Big didn't mention as well, one of the instigations of the planners, if you come down to site, and what you can see here is that the building was tilted. The southern end and the northern end was pushed over slightly so that it kind of hugs Kings Boulevard as an urban device to kind of tilt you and turn you as you go up Kings Boulevard. So it didn't seem like much at the time, the fact that you would step the building out to the upper levels, and then it comes flat, and then it comes tilting out again. But of course, what that does, when it comes to the installation methodology and the design detailing of it, it makes it just phenomenally complex, because you've got to be able to get, so each one of those floor plates steps out, as you can see towards the left, so the jib had to be able to work to get it out underneath and in, because the furthermost ones, the easiest access ones, were actually at the top of the building, not at the bottom of the building, because they were all tucked away underneath, just for fun. Okay.
Should we do the questions?
Okay, I think we're there. So without ado, thank you, panel. That's terrific. Can we have some questions from the audience? So, hand there gone up immediately.
Can just shout. Just shout.
I'll take this, Mike.
It just seems to me that we've been talking about carbon all day,
yeah.
And you've taken out really considerable carbon in the floor plates and in the facade, but the sort of elephant in the room is you've got a story-high transfer truss at the top of the building.
Should I do that? Yeah.
Maybe I should do that one. Yes. We would do it again, because the spaces are actually feeling amazing. When the temporary steelwork's coming out and you get that, because it's column-free on the perimeter anyway, on the ground floor, and then it's just hangers on the office floors. It's extraordinary space, but we've utilised the truss deck as our plant area. So we've crammed where you'd normally have building plant on the roof, we've tried to put as much of the building plant as we can in that truss zone. It's been very difficult to thread it all in, but we want to use the roof, so that's an amenity space. So we are using that. I know it's an unusual floor, but we are using the truss deck for a good purpose.
Undoubtedly. Can I just say that there's one of the big conceptual moves on the building was simply that the ground floor of the building that the public might use is the thing that over the life of the building is likely to change the most. And therefore, we've all felt very strongly designing the building that it should be possible at a certain point in time to just clear all that stuff away and put something more relevant in at some later date. And so that was something that led us down this route. It also meant that think back to the kind of glass lantern kind of type of thinking, that we would also just have tiny little steel hangers in there. So we would, now we've got these big carbon sequestering jumbo mullions, which is fantastic and quite even more unusual and bizarre than what we kind of set out to do. But overall, there is another not facade related and not timber related story on the building, which is about the flexibility of the building over its whole lifespan. And there's also another very small thing, which is that on the non-street side of the building at ground level, there's a whopping great big TfL ramp that goes all the way down to the bottom of it literally goes to the basement of King's Cross Station. And by using this methodology, we just don't put any load on that, Because you can imagine there's probably some engineers in the room, you've got an existing structure, and we've got a new design of building. Everybody gets a bit nervous about loading that existing structure up. So this was a sort of antidote to that whole issue. So.
Is a very good one in relation to the temporary works of any structure. It's something we start to look at more and more now because it's the body plan that really isn't looked at. But as Andy said, there were some very good reasons for doing it at the time, and they still hold good reasons. That one little thing we did, because this is a timber facade conference, we weren't going to talk about the access ramp. So we, as Andy said, it's not a small little thing. This is an access ramp that keeps King's Cross Station alive 24/7, 365. So they have, in legal terms, which is called quiet enjoyment, which is a lovely phrase, which means you can't interfere with them whatsoever at any time, at any point. So you have to be able to keep that significant piece of public infrastructure going. So it was really important that we didn't actually snafu that in any way, shape or form whilst we were constructing the building. So I hope that helps. Any other questions? Down at the front.
You can use them. The timber on the outside, the glowlamp beams from Hess, they look like larch, but you mentioned using a coir.
So the inside is actually larch. That's European larch that we're using there, FSC certified as well. And then the sacrificial layer we were talking about, you saw that mullion detail with the split, so that outer part is a coir.
Are you putting any form of UV treatment on it to give it sort of longevity? Is that not necessary with a coir?
For the Accoya, no, we haven't got any treatment on it at all. These internal large mullions were also meant to be completely uncoated, but Gardner and Hess then recommended just for protection during transport and on-site that a thin layer of protection coating is applied, which will wear over time and will not be reapplied.
Any other questions? Yep.
So how do you clean the glass?
Sorry, I didn't get that.
How do you clean the glass?
There's a building maintenance unit on the roof which travels all the way around, and so that is accessible. And it's maintained through that.
Yeah, there's a giant BMU on a rail track which runs all the way down, and it's part of the replacement strategy of the building. Again, to both Andy's points, this is about the longevity of the building, and one of the reasons for having that sacrificial element on the outside was when it does wear out, and when the triple glaze units do eventually fail, which they will, and or need replacement, then they can be replaced relatively easily. You take that outer capping off, replace the glazing. One of the things that we discussed, and it's so long ago now, but we hope that in future, with the air in London improving, if we did go back and put more units in, that perhaps there would be opening lights in there to actually have a mixed mode building, because quite a few sections of the building could actually work quite well in a mixed mode scenario. So it's that kind of malice of forethought in terms of future-proofing the building.
I couldn't help noticing in one of your earlier pictures that you had this, what looks like a CLT slab, and there were patches of rain on it. You got a team of sweepers, or how do you deal with that during the construction stage?
I'll do that. There's a
These
variety.
ones?
Yeah, there you go. There's a variety. There are Lend-Lease are our construction manager. There is a water gang, and we're hoovering up water, we're sweeping it. We've got a lot of fixed protection as well. So obviously, as the more facade goes on, the easier this gets. But we've been building a long time. Obviously, you can all see that. So it's a long-term strategy. We're trying to keep as much water out as possible. The damage-wise, it's actually been okay. There's some staining, but it's okay. And we've done some test cleaning on the CLT, and it's fine, because that's the finished. The soffit there is the finished product. And it really doesn't need much at all. Just tidying up around the edges, and it's done.
Some of it's been there over 2 years already. So, and I think that was one of the lovely things, was that about the use of the timber, which we debated a lot, and Julia's alluded to about the coverings on it. We wanted it to change in appearance with life, and actually express that. And I think actually Google were very brave in doing that. And I think it's going to be a terrific aspect, because some of the externals, by the time because it's going to take so long to build this building, by the time you put the first elements on at the southern end and you get the ones on the northern end, they'll have gone perhaps through 2 diurnal cycles. So, they're going to have a natural amount of changing colour that happens along that building, and we wanted to celebrate that.
One last question. Do we have?
So I see there's some timber on the roof. Can you talk to us about timber on the roof rather than it's a lot of it. It looks pretty shaped and pretty interesting.
Timber on the roof.
Yes, we'll go back to that section maybe. Let's have a look if we find that slide. Yes, you're right. There's also timber on the roof. Yeah, you can see it on this image here. So those elements right there at the top, they're timber trays. They're actually done by Schneider. And they're also Okoye. They're solid slats. So slightly different to the board we've got on the main facade, where it's actually glulam or 3 layers, actually. And so yeah, that's also another element on the building that will be really, really nice and benefit the atmosphere on the building and in the building.
And the gardens on the roof.
Right. It doesn't constitute the envelope of the building, that stuff, does it? So it's more like a soffit treatment that bends up to contain planters and edge balustrade and so on.
Correct. That's absolutely right, because what you're seeing there at the top, so not only is the top, the vast majority is hung, that section shows it exactly as it is. There is a 2-storey section on top which contains a load of facilities and the roof garden, and that's a gravity structure which then sits on top of those trusses if they weren't doing enough, as it were, anyway, and then the stepped garden. We're out of time, and I'm very conscious that it's the break next. I'm sure you're all desperate to get out for a little while, so I'd just like, if you wouldn't mind thanking the panel in the usual way. Thank you very much, everybody.
Okay, what a great way to end session 3. Thank you, Peter and everybody else. If we take a 20-minute break so we can get back here for 4:30, that'd be great. Thank you. Oh, thank you. a building quite close to me, and I'll pass it almost every day. And our next speaker is Julia Barfield, who's the Managing Director for Marks Barfield Architects. Julia can't be here, so she's going to dial in via Zoom call. Hi, Julia, over to you, if you can hear me.
Okay, thank you very much. Victorian terraced houses. So that's why it was important that it sat very comfortably in its surroundings. And you can see from here that that's the site before, on the top left is the site before we did any, we came onto the site. And you can see that the main bricks that were used in the area are these kind of traditional gaunt bricks with red highlights. So when we entered the competition, we asked ourselves a question: what should a British mosque be like, designed for the 20th century? And we did a lot of research looking at mosques previously throughout the world and throughout time, throughout history. And we kind of came to the realization that mosques tended to take on the character, the culture, the materials of their place. So a mosque in India looks very different from a mosque in Turkey, looks very much different from a mosque in China. And so that's what really led us to think, what should a British mosque be for the 20th century? And we were inspired by elements of British sacred architecture. This, of course, is some of the vaulting that you'll see around Cambridge. But we're also, of course, inspired by Islamic architecture. Here's two mosques, one from Turkey and, of course, Cordoba in Spain. But the Garden of Paradise, this drawing that we found fairly early on in the process of the Garden of Paradise was very much the main inspiration, with its water fountain in the center, symbolizing the source of all life, which was very much one of the Islamic ideals. The design emerged of a calm oasis, like a glade of trees. And these trees became the structural trees and then the vaulting was joined at the top that became the support for the roof. And then this was clad in CLT timber with masonry cladding over the top. Now, geometry is a sacred geometry is very much part of the Islamic tradition. Geometric art is symbolic rather than literal, and so it's therefore consistent with Islamic traditions against representation. And as it happened, we had one of David and my tutors at the AA in the 70s was Professor Keith Critchlow, and he is a venerated professor of sacred geometry. And he came and he was part of the competition winning scheme. He actually determined the geometry for the building, which he suggested should be the breadth of the compassionate pattern, which is based on star octagons. Each one is, it's formed of 2 squares rotated through 45 degrees, passive and active squares representing heaven and earth. And then we took that geometry and we took it into 3 dimensions with using our geometric CAD packages, including Grasshopper. And then we also made a timber model at the early stage to look at how the structure would look. And this was the plan that we came to. And this is very much, because it was an elongated site, it was gave very much the opportunity to take a visitor through a journey, through a gradual progression, if you like, and prepare people from on the left where there's Mill Road, moving from the day-to-day and the mundane into the spiritual. So if you look, it starts with a community garden on the outside, then moving through into an Islamic garden, moving through into a portico, and then an atrium with the teaching area to one side and a cafe to the other. And then the ablution spaces, which are in blue, they're at the kind of knuckle of the plan. And that's where on one side is for men and the other side for women. And then finally into the prayer hall with an atmosphere of quiet contemplation. In 3 dimensions, you can see that the block at the front very much addresses the street. But of course, as it moves back to the prayer hall, that is needs to be orientated towards Mecca, particularly the Qibla wall on this side. And of course, I mentioned sustainability was very important to the building from both the client point of view and from our point of view. And this just shows some of the key sustainability principles incorporated in the building. We took a fabric first approach, super insulated and airtight. And of course, there's a timber construction, which has sequestered biogenic carbon. And then it was very carefully designed so that it was lit naturally, so that there don't have to be lights on during the day in all of the public areas, including the ablution areas, and that it should be naturally ventilated. And this was really quite a technical feat on behalf of our engineers. We took a decision very early on that there should be no fossil fuels on the site. And so it's powered by ASHP heating and heat pumps. We also have PVs, and all of the water is collected and used to flush the toilets, but also to water the garden. We work with specialists, contractors from a very early stage. And when you're trying to do something different, it's very important to work with the people who are going to make it. And my partner, David Marks, found Bloomer Lehman early on, and we went to visit them in Switzerland, where they're completely self-sufficient with timber, powered by timber. And we worked with them, as I said, from the early stage, even before we got planning. And this is one of the models that they developed later on. We both tended to work very much in 3 dimensions. So we had a language that we could speak to each other in. And this is the fabrication model that they made, where every joint, plate, pin, and screw is itemized. And you can see in the next slide how all of the halving joints, everything is itemized. And to my mind, this is one of the most beautiful kind of detailed drawings that I've ever seen, certainly, particularly with the different colors, obviously, delineating the different pieces that need to be made. This is just showing one of the junctions, showing all the halving joints and the pins. And the construction process of the blanks, I think it's you know, a spider's web apparently has all of the different elements of the spider's web actually have different structural properties. So the spider somehow makes them to have different structural properties. And that's true of the structure on the mosque as well. So each part is constructed specifically for what it needs to do structurally, but also whether it's straight, has a single curve or is double curved. So, and the way I like to describe this is that we have sandwiches and we have the Battenberg cake. So the double curved elements are constructed a bit like a Battenberg cake, and they are obviously much more structurally strong than all of the other pieces. So this is the blanks that are then milled with a 5-axis CNC milling machine. And then the whole lot was taken to site in pieces. When we were on site, they were then, we had a jig to assemble the crown, and the crown pieces were then lifted in place and then joined together, as you see on the right. I mean, the accuracy of the that was able to be achieved was just astounding. And our main contractor was very impressed in the end. He said he was one of the best subcontractors they've ever worked with. You can see that this is an entirely timber structure, so the walls are CLT, and this is the topping out, the dome being put in place. Now, coming to the cladding, as I mentioned before, we wanted it to fit into its place, and so it was very important that we took some cues from the local area, but of course it's a mosque, so as well it also has to have the Islamic influences as well. So we took the local buff-coloured Cambridge brick with the red accent tiles as being a starting point. And then we looked at how Kufic, which is a form of Arabic calligraphy, was also integrated into a lot of kind of Middle East buildings as a kind of writing. And this lends itself to a modular construction because it's where the positive and negative spaces must be balanced. So where square Kufic is used to create geometric brick patterns in relief, it's referred to as a rabaf in Persian, that meaning 1,000 weavings. And we used a 50mm Dutch tile, brick tile, which was 50mm offset perp joints and alternating courses. The calligraphy reads in Arabic, say, "He is God, the One." So this is kind of on the left-hand side. You can see there is a kind of a tradition in England of the use of mathematical tiles, particularly in the 18th and 19th century with timber frame buildings. You can see, you think that they're actually made of brick, but actually they're made of these mathematical tiles. And the advantages of using something like this is that it's very lightweight. So saving embodied carbon in the foundations. So this is one of the walls as it emerged with the Kufic patterning on the outside. And we also, Professor Keith Critchlow also did a lot of original patterns for the doors and other parts of the mosque, including the dome. So there he was very old school, and he did all of his drawings with a very sharp pencil. So the patterning for the dome, for instance, was based on a truncated cubed octahedron, which then we took into our CAD modeling as before. And then we worked out how it could be constructed out of, actually it was a single piece that was just mirrored. And then that was went and constructed in more of a traditional way before it was put together in the dome thus. So we employed a kind of combination of very high-tech methods with very kind of low-tech methods. So this is the progression of spaces, showing you how when you enter, this is on the left-hand side, that is the community garden. On the outside, then you go through to the Islamic garden, which was designed by Emma Clark on the similar principles to the mosque, where she takes elements of the English garden as well as elements of the Islamic tradition of gardening and put them together to fuse to make something unique for this building. This is as you enter the building. This is the portico and entering into the atrium. And here you can see the atrium with the Kufic patterning on the wall saying, God, he is the one. And then on the floor, the breath of the compassionate pattern. And then moving from the atrium through into the ablutions. So there you can see the ablution, the women's ablutions on the left, which is an octagonal space, and the men's ablutions on the right. And then into the prayer hall itself. And this is just showing the prayer hall itself. On the right, you can see that's the prayer hall in COVID times, and on the left, pre-COVID times. And this is showing the prayer hall with the mashrabiyah screens and the dome. And this is just showing some of the detailing, also done by Keith Critchlow, some of the patterning on where the filtered air comes in from the outside. This is in the prayer hall, and this is where it comes in from the outside. So all of the patterning was designed bespoke for the project. This is just showing the breath of the compassionate pattern on the atrium space, and also there was stained glass windows. And this is just showing a view of the project from the outside. Now I can see I'm running out of time. I was going to do a little bit about the fact that we're in a climate emergency. I expect people have talked about this in previous talks today. So I'll just move on to the embodied carbon assessment, because of course we designed this building 10 years ago, before even the COP, the Paris Accord of 2015, and before anyone was really thinking about embodied carbon. But since then, we've done our own estimates of the embodied carbon in the building. And this is what, as you can see here, is looking at all the materials, including all of the flights that were made by the contractor from Northern Ireland, Gilbert Ash, who are also brilliant. They did a fantastic job. And this is just looking at the two ways of looking at it. You can look at it without the sequestered carbon or with the sequestered carbon. And if you look at with the sequestered carbon, it's actually a very low embodied carbon in the building. So we're quite pleased with that. And I think I'm going to I'm going to stop there because these are just views of the garden at various times, seasons in the year. And I thank you very much.
Wow. Thank you, Julia. It really is a beautiful building, and I think the attention to detail on that was amazing. So if you are ever in Cambridge, come to Cambridge anyway, it's a beautiful city, but definitely go down and check that out. It's really, really something to behold. Okay, so we're going to move on to our next speaker. We've got Mark Lambourn, the business development management from a Procter Group, and he's going to talk about airtightness in off-site construction. So, welcome, Mark. It will do as you start stage.
Right, good afternoon, everyone. As the introduction said, my name is Mark Lambourn. I'm Business Development Manager here at the A Procter Group. I'm here today with a couple of my colleagues. So myself and Will Jones, who's down there, and Ian Fairnington, our Technical Director. We work alongside our regional managers to really generate specifications and provide technical and site support within high-rise and facade division, but also with particular focus with regard to the modular and off-site sector. So as a business, we're based up in Blairgowrie in Perthshire. It's a family-owned business, fourth generation now, and for over 50 years, we've really been sort of providing solutions and products for the construction market. And this really is the whole building envelope. So if you're building on contaminated land, there's obviously gas membranes and gas venting systems, right through to specialist acoustic floor systems and specialist insulation materials, aerogel products, which are standard grades and also A-rated grades in terms of fire performance. But I think what we're known for and what is key to what we do is really through product development and innovation is developing a range of high-performance membrane systems. So as I say, for 50 years we've been providing solutions of products in the construction market, and what we really understand is that really to have an energy efficient and healthy moisture-free building envelope, there's really a clear need to manage the balance of heat, air and moisture movement. And this will be through the building's life cycle, from design, construction, completion and use. So additionally to that, we have what we call our HAM principles. So as I say, core to the business is the HAM principles. So this is the understanding of the balance of heat, air and moisture movement. So if you get us involved in an early stage, we're able to take an holistic approach to building design. So today's seminar is entitled Airtightness in Off-Site Construction, but actually this very much, the membranes are also suitable for use and applications on site as well. So we work with the off-site side of the business, but also building traditionally with high-rise residential, for example. So what we're looking for with this presentation is really just to provide you with a brief sort of snapshot as to how a fully self-adhered membrane can solve a number of issues. So that may be extended exposure time of CLT or mass timber construction and any associated moisture ingress or water ingress. So our membranes can protect the structures from that. And a factor which is becoming, I think, increasingly more important, certainly for clients, particularly when designing for schools, health facilities, and either medium or high-rise residential projects, is the reaction to fire of materials within that through wall construction. So we're going to touch upon also our range of fire-rated membranes. So in terms of the presentation, we're going to give you an overview of how we go about managing that heat, air and moisture movement. So we take an holistic approach to design with that, with our free sort of hygrothermal analysis service. We're going to refer to recent changes to BS 5250, Management of Moisture in Buildings, Code of Practice. Then we're going to look at the membrane types, physical properties, and the correct placement within the wall build-up. So this will be for vapor control layers, primary air barrier systems, and secondary air barrier systems. We'll review fire performance of membranes as well, but in particular we're going to highlight, I think, some of the shortcomings which are there in the moment with the current test methods, which really doesn't differentiate between how membranes are tested and perform. And finally, we'll look to provide an overview of membrane systems. So when we're putting together our hydrothermal analysis of the building, what we look for first and foremost is what is this building going to be used for? Who are the occupants going to be in this building? So we need to understand, is it a commercial? Is it a mixed-use building? Is it residential, or is it student accommodation? All of these will have different internal conditions for temperature and humidity, and this will influence the load on the building, the moisture load on the building. So off-site construction, I think, offers a number of advantages hydrothermally, because buildings are composed more of dry materials, and the building is watertight at a far earlier stage. So really, we can get us involved at an early stage, and the design can be tailored to manage that moisture associated with the occupants and use of the building, and this will lead to a more efficient fabric, envelope, and building system. We next need to look at weather, consider the external weather conditions. We know that construction moisture will come from the weather, and this must also be taken into account when we're doing the hydrothermal analysis. So we'll consider the weather conditions that the building will be subject to once completed. So what we'll do is actually look at where this building is positioned geographically, and we will import the weather data, historical weather data, from that region, and it will give you a more defined hydrothermal analysis of that construction. So we use this historical weather data associated with a geographical location, and then we'll look to sort of move that forward over the next 5, 10, 15, 20, 30 years and have an understanding how this building will perform and what type of weather it's going to be sort of conditioned to. We also need to then think about the building itself. So buildings are made from concrete, steel, and timber-based products, and all of these respond differently to moisture as well. So each of these contain different amounts of construction moisture, which must be fully allowed to dry out. So buildings with a lot of in situ concrete, we know will take many, many years to dry out fully, and this excess moisture load must really be taken into account really at the design stage. I think by comparison, if we look at largely timber structures, so TLT, for example, then these will have lower initial moisture loads that we need to consider. But then I guess the buildings of that type will have less capacity to retain heat, so they may require then different approach with the design of the heating and cooling system. So having looked at the occupants, the weather in the building, we then need to look at how we balance that heat, air, and moisture movement within that building. In order to do this, we use a very detailed hydrothermal analysis. So it's a WFI software developed by the Fraunhofer Institute. So I think in comparison to your traditional glazing method, which is the sort of U-value calculation and condensation risk analysis that you receive from your insulation manufacturer or insulation distributor, this is a very detailed hydrothermal analysis that uses dynamic simulation to account for heat and moisture flows, as well as the capacity of materials to store moisture. So it considers the effects from that initial moisture load from during the construction process, the external weather conditions, and then can assess over long periods of time rather than over these simple 12 snapshots that you will get from a typical glazing method. And it gives you a far more detailed analysis, as I say, than is provided by typically your insulation manufacturers. So BS 5250 is coming through the centre there. So the management of moisture in buildings, published in last year, 2021. And I think it's encouraging to note that this really now recognises the importance of taking a holistic approach to building design. So really fits in with the message that we've been taking the market now for many years to take this holistic approach towards moisture management. So it looks at integrating thermal insulation. It looks at energy efficiency alongside moisture control. And our hand principles and hydrothermal analysis is therefore important because it can be used to confirm the suitability of a range of solutions to control not only the movement of moisture, but also the movement of air. So we'd certainly recommend or would welcome the opportunity to discuss this with you in more detail following the presentation or at a later date. So since its introduction back in 1975, BS 5250 at that time had 25 pages. And I think it's very quickly approaching up to 200 pages now, I think 180 odd pages in total. So for the first time in all that time, since 1975, it now recognizes cross-laminated timber and other solid timber framing, and suggests that moisture risks should be assessed and treated separately to those of a timber stud frame system. So it now sets out key principles for a well-designed CLT structure, and these must be adhered to. And it recommends that the mass timber external structure, for example, should be on the warm side of the insulation. That insulation should be continuous and without gaps, because you don't want condensation forming on the surface of the mass timber. So in order to achieve that, is detail your insulation correctly. You may also want to consider a membrane to prevent wind washing or thermal bypass. So that can also be considered. A vapor permeable membrane should also be considered on the warm side of the external wall element. So we would traditionally put that on a sheathing board, but in this case it would be on the face of the CLT before you put your insulation layer to be installed. And in terms of air tightness, it gives you two approaches. It recommends the use of either an internal air and vapor control layer, or alternatively, it says you can use an airtight external vapor permeable membrane. And in terms of, I think, transportation in off-site applications, I think there are obvious advantages if you can apply an externally vapor permeable airtight membrane that is fully adhered. So you can apply this in the factory and supply that CLT kit, as it were, to site, already wrapped in a membrane. So I think here in the UK, I think it's generally accepted that the internal temperature of a building is warmer than the external temperature. So this creates a water vapor pressure or drive through that construction. And as we move through the building layers, the temperature at any given point will vary according to the thermal conductivity of the materials used, and this will produce a temperature gradient. And using our detailed hydrothermal analysis, we want to make sure that there is no risk of interstitial condensation forming at any point during that construction. The beauty of the WUFI analysis is that it actually allows you to investigate what would happen if the vapor drive was actually in the opposite direction. So if there's cooling units within the building, it's warmer outside, how would that then affect that vapor drive? And where would the condensation line fall? In addition, we can also introduce in the software little cameras at any point during this construction and little taps, and that represents moisture. So we can actually engineer in failures. What if a membrane was to fail? What if something wasn't detailed correctly through that building envelope? So we can actually demonstrate how this building would perform if there was some kind of failure and how it then will dry out over time. So now we're going to look into more detail into the application and placement of wall membranes. So first of all, vapor control layers, such as our ProCheck A2 membrane here. This is a fire-rated membrane. And these membranes, vapor control layers, really are designed to provide two functions. One is to act for moisture management, so the traditional use of a vapor control layer. And then the other thing is the other sort of purpose it has is to provide an internal air tightness line. This can be quite subject to complex detailing. It can be very difficult to detail these membranes through the construction. We need to ensure that laps are effectively sealed, and we need to be concerned about the action of follow-on trades, or indeed, at the end of the day, the building owner. We never know what the building owner is going to do. So if you take your time installing a membrane, you've sealed all the joints correctly, we never know what the building owner is going to do, where they're going to put their shelves, their TVs, etc., etc. So these membranes can be damaged over time. So I think a more robust and simplified method is actually to place that air tightness line externally rather than internally. And this gives you the option then to specify the membrane, the internal VCL, purely for moisture management. It's only concerned about moisture management rather than being your air tightness line as well. So by placing that membrane externally, that air tightness line gives you a more robust solution and one which is less likely to get damaged. So that's where this membrane comes in, the red membrane here. It's a product called Radt. It's a fully self-adhered membrane, so effectively a 3-layer product. And the clever part is actually the vapor-permeable adhesive on the back there. So this is the membrane that would allow you to install that off-site in the factory, get an initial grab. It takes about 6 hours for that adhesive to cure, but that then could be sent out and simply detailed together on site. Panels can be zipped together using a Radt tape, made of the same material, and you can link panels together, you can do corner junctions, etc., etc. So being vapor permeable, it's possible to adhere Radt to the external face of that CLT or mass timber in the factory. It offers a Class W1 water holdout, so it provides a high level of water resistance for roof, wall, and floor construction. It protects the timber from moisture ingress during the transportation phase while it's being left on site, and there may be delays on site for a number of reasons, so it can protect the CLT, etc., during that construction phase. It's fully BBA certified, and it provides a robust external air tightness line. Very quick, very simple to install. You just need to follow a few very basic principles, such as having the shingle effect, where we want the moisture to run very quickly off. So, BBA certified, easy to install, eliminates the need for complex detailing for internal services. So what we can do, rather than trying to detail all your internal services in the building, we're effectively wrapping the external face of that building with an airtight, vapor-permeable membrane. Radt is also a Class B S1D0 in terms of its fire rating, so it's approved for use above 18 meters. The sister to that, as it were, is Radt UV. So this is darker in color. This is the membrane here. And it's vapor permeable, fire resistant again, has very good, it's a Class B fire rated, combines the best properties really of vapor permeability and air tightness, but it's really designed to go in open jointed cladding systems. So you can put that onto the construction, and you can have cladding openings of up to 50 millimeters. And that will then remain UV resistant for the life of the building. It can be left fully exposed on its own if it was wrapped onto a CLT or off-site construction, or any construction come to that, for up to 12 months in terms of its UV degradation. Next, we've got a product called ProBreathe A2, and as the name suggests, as a system with the appropriate tapes, it's got a double-sided tape for you to bond it back to the substrate and a tape for the laps. Those tapes have been tested with the membrane as part of a full system, and it achieves an A2 fire rating. So it's an airtight woven glass fiber membrane with a PU coating. It's got very good water resistance, air tightness, all in one membrane. So it has a reaction to fire, as I say, A2 S1D0, when installed either free hanging or onto a substrate. And it's ideally, I guess, shown here. You may have the Radt membrane applied to the external face of the CLT to provide the air tightness line, but actually you may want a membrane, particularly in passive house construction, and there's a number of architects now that are concerned about wind washing, etc. So you can put that membrane over the face of the insulation there to prevent thermal bypass or wind washing. We're now going to look at, I think, some of the issues with regard to how membranes are tested. So the way membranes react to fire is not always accurately reflected in the on-paper test data. So this test that was conducted by Edinburgh University is based on a single burn item test. And what we're trying to do is compare the reaction of the two fire-rated membranes. So the membrane on the left is our fire shield, and then we've got a membrane on the right which has the same identical fire classification. Both are Class B S1D0 as declared under the current test methods. As I play the video clip now, I think you'll see that there's a dramatic difference in how these membranes perform. So literally within seconds, you can see that the membrane on the right has recoiled from the flame. It's exposed the substrate behind. In less than 1 minute, then we've got the fire has taken hold and it's really spreading up that substrate. So at 8 minutes, they actually stopped the test because the substrate has now failed, the fire has gone through. The membrane on the left, because of this unique coating that's on there, it actively foams up and prevents the passage of fire across the membrane. Unfortunately, these products are both defined under that current test method as being exactly the same, yet there's a big difference the way these two membranes perform. So we are sort of really discussing this with the likes of BBA and amongst others, and it highlights really the importance, I think, of contacting us as a business to try and understand which the most appropriate membrane is, the position for it, and the application. So, as I say, we're just trying to get to the bottom of how we can, that should actually be a B plus or an A minus, but it's not. They're both exactly the same. And finally, we'll just leave you with a snapshot of all those membranes that we've discussed. So the Radt-Tite is vapor open, airtight, and fully self-adhesive, as is the Radt-Tite UV. We've got on the right-hand side there the fire ratings of each of these membranes. The fire shield that you've just seen, again, vapor open, airtight, but requires to be mechanically fixed. We've got the ProBreathe A2 vapor permeable membrane, ProBreathe A2 breather membrane, vapor open and airtight, but again, mechanically fixed or taped. And then the two VCLs we have, A2 fire rated and Class B fire rated. And these are airtight and vapor tight as well, and mechanically fixed. So, thank you for your time. We're with the kids, so we're on all forms of social media and that type of thing, but that's the website. If you log onto the website, we have a members area, and you can download all the relevant data sheets, specification details, et cetera, and fire test certification. So thank you for your time. Hope you found it useful. And I believe the bar's open very soon. Thank you very much.
Well done. That's really good.
Cheers.
Thank you, Mark. That's really interesting test information that you had there as well. Okay, we've moved on to our last speaker, but not the least of today, and it's Hugh McGilveray. Bang on, yeah? Great, excellent. Hugh is Associate Director from Accsys O'Callaghan, and he's going to talk about UK timber envelopes, a global perspective. The floor is yours.
Thanks very much, Alan. Thank you, and thank you for those that have clung on. Yeah, I'm Hugh. I'm an Associate Director with the London Façade team at Accsys O'Callaghan. And I really appreciate being given the opportunity to conclude today. It's been a really informative and inspiring day. So I'll just run you quickly through what I want to talk about today. I'll give you a brief overview of Accsys O'Callaghan and to why facades and timber are so close to our heart. I was going to try and summarise some of the things we've had today and just surmise the UK timber challenges we've been discussing. Then I wanted to go abroad and have a look at a few of the insights. A lot of people have touched on them, that other countries are doing different things. And then I'll try and come full circle, pull some of those ideas back and see what potentially we could be doing differently. So EOC, we're a SME engineering consultancy, and we're broadly split 50-50 facades and structures. And our HQ is here in London. We're 18 years old, and our facade department was started in 2012. And so we're celebrating our 10th year this year as a facade team. Anecdotally, the kind of growth of engineered timber in the UK is roughly tracked with our own growth, and that's played to our strengths. And that's because originally, as a firm, we were known very much for our traditional structural engineering, but also our structural glass engineering. But as engineering timber was coming to the fore, we kind of realized that there are some rough parallels between the design of these two materials. Despite one being anisotropic and one being isotropic and being very different materially, they're actually quite similar in design. And that's because they're both very brittle and non-ductile. They both demand very careful load path analysis, very careful connection detailing. You can laminate both of them and have to think very carefully about material supply and about production limitations. they're both often exposed as structures, and therefore we need to have a keen eye for detail and understand how to make them look nice. And above all, they're both been pretty code-free. There hasn't been a huge amount of information to design with over the years, and therefore a first principle approach is often appropriate. And therefore we've become specialists in both of these materials, which were once very much traditional, but now very much emerging again. So I'll just try and summarize what we've all learned today. We've learned there's a lot of obstacles. The first and foremost being insurance, or one of them being insurance, and a very hard insurance market. And that's been compounded by the Grenfell inquiry and a lot of uncertainty around combustible materials, including, of course, timber in our facades. And a general lack of testing and a general lack of a pooled knowledge pool for building the evidence for the case in the case for timber. And the stack of papers here is meant to represent that despite it being probably the most traditional structural material, unfortunately steel and concrete have kind of kept the university research labs and the BSI pretty busy for the last 100 years, and we don't have a sophisticated set of codes really for timber, let alone engineered timber. And there's also an unfortunate irony that despite a lot of us here knowing the sustainability credentials of the material, it's often quite difficult to cut through the noise and the confusion around sequestration and deforestation and supply chain issues and actually prove the sustainability and everyone agree on it of this material. And finally, you only have to look at a map of Europe to see just how sparse forestry is in our country. We only have 13% forest cover here. We're planting a lot of trees, we're aiming to grow that number, but it still lags way behind the European average of about 38%. And so we do grow homegrown timber, but we don't grow a huge amount of it. And the timber we do grow, we only put about 16% into the construction industry. And that means we're very reliant on imports, and that, of course, impacts price and cost volatility, and it can put off the more commercially minded developers, although we are beginning to see some changes on that front. So I mentioned earlier our headquarters are in London, but we have a bunch of global offices that serve our various projects around the world. And I thought I would just get some insight here that all the markets that we predominantly work in have their own timber industries, and these are in various different climate zones. So our kind of European and New York offices are very much in the temperate climate zone. Our Hong Kong, Australia, West Coast offices are in the sort of subtropical zone. And we've recently opened an Indian office, which is kind of a tropical zone. And this manifests itself in all different species. You know, timber is a collective noun, if you like, for a lot of different types of wood. So just quickly running through, the green on the maps here is the sort of where these things are growing. So we've got our evergreen broadleaf hardwoods, like our teaks and mahoganies, and they're predominantly from the rainforests, and with the exception of maybe eucalyptus, which thrives in Australia and New Zealand and China. Then we've got our deciduous broadleaves, so hardwoods from the temperate zones and from the dry forests and savannas in the tropics, so our oaks and our birches and so on. And then we've got our needle-leaf conifers, softwoods, so our pines, our spruces, our larches, which like cold weather, so they thrive in boreal regions and temperate climate zones. So with this bit of context, I just wanted to dot around some of these markets and just see how that makes an effect. I'll start in Hong Kong. It's a quick stop for timber, unfortunately. It's, I guess, because of a function of the density of it, it was a British colony, so it probably wasn't growing any of its own timber. And it's just got a fantastically stringent building department that's impossible to get anything past. So unfortunately, above 6 meters, you're not allowed to use timber at all in Hong Kong. So I'll move swiftly on from there, unfortunately. You can hop over to China. Wow, that's bad, the image at this resolution. Hop over to China. Unfortunately, their facade policies are pretty similar to Hong Kong's. You can't really use it in the facade over there. But more recently, they have upgraded their structural codes to allow you up to about 5 stories in timber structures. But that's actually not the case in the 20 largest cities, the tier 1 cities, so it's a significant part of the market. But despite there being some activity in timber over there, it's predominantly a kind of stagnated market, and that's mainly due to historic deforestation and a kind of long-standing logging ban that has really put the onus on masonry and timber and masonry and steel and concrete. To the point where only about 1 in every 2,000 houses is timber framed over in China, from my reading, which is a shame. And hopping quickly over to Australia, it looks pretty sparse on an aerial image, but there's also an awful lot of wood in Australia. 17% is not a big number, but the land area means they've got about 100 times the forest area that we do in the UK, and only about a third of the population. So they have a lot of timber for their needs. Unfortunately, wildfires have been a real problem there over the last few generations, and they have a similar issue to our kind of UK spruce industry in that a lot of the timber they grow ends up going into pulp and wood chip, and they don't use much of it in construction. We are beginning to see that change. We're beginning to see some sort of novel hardwood products, engineered timber products, which are really interesting. And from a regulatory point of view, they have some very stringent prescriptive standards, as do a lot of the world. But they also do have a performance solution avenue. If you're willing to fight very hard for it, they do allow you to think outside that box. And that can lead to some interesting possibilities for timber. So an example of this is our Atlassian project in Sydney. This is a commercial headquarters. It's going to be the largest timber hybrid structure in the world. We're doing the facade and structural engineering on this. And it's really changing the norms and getting mass timber into the sky in Australia. And it's not all timber. I think this is the key here. It's hybrid. We're using a normal concrete core, and we're using a steel exoskeleton. But we're using those carbon-intense materials strategically, and we're putting in refuge floors every 4 stories, and that allows us to build basically a code-compliant mass timber building between those floors and take away a massive portion of the embodied carbon of the development. But this sort of ambition, unfortunately, is fairly rare. Atlassian are a really, really motivated client. They will occupy their own building. And they had the foresight to actually bring us, EOC, in before there was a brief. And we actually designed them an engineering-led reference scheme for this project to really test how far we could go with embodied carbon terms. And that became part of the architectural competition brief, which then shot Architects One, and we're working with them now to detail this through. And on the facade engineering front, unfortunately on this building, there's not a bit of timber in it. We couldn't for combustibility reasons, as is the case with a lot of high-rise buildings. In fact, even the PVs you can see on these shelves, we've had to fight extraordinarily hard to prove from a combustibility standpoint. So jumping around the Pacific from there, there's been a lot of talk about North America and the North American timber industry. They have a huge amount of homegrown timber, 38% forest cover. It's ingrained in their culture, lumberjacks and logging, and 90% of their housing is timber framed. So they have a huge amount of wood. I don't really understand the statistic because it still appears they import about 80% of their wood, majority from Canada. I can't quite work out the numbers there, but apparently that's the case. And in facades, the facades, the predominantly timber is more or less ruled out in facades. It depends state by state. In high-rise and medium-rise, it's very, very common in low-rise construction. But some successful lobbying and some targeted testing led to a code change in the IBC last year, which, as alluded to earlier, has led to a massive boom in mass timber primary structure buildings in the last few years. Some early adopters. So that's really encouraging. And as a practice, we've seen most of this activity on the West Coast. This will be Google's first mass timber building. It's in Sunnyvale, California. And the design of this was really, really interesting. The intent was very much to have a timber building. We're doing the facade engineering, by the way, not the structure. And they wanted a timber facade, but combustibility rules there ruled that out. You can't have timber on this sort of building on the outside of the building. So what we've done is take a CCF unit, and what a CCF is, if nobody knows, is a closed cavity facade. And what that allows us to do is put a very, very clear sheet of glass on the outside, and then use a timber blind system and veneer system to sort of showcase timber. So it's not sat behind a solar-controlled piece of glass. And then we've got another double glazed unit behind that, and that's in a sealed unit. And this is the first CCF in North America, and it's pretty much done now. And you can really tell that it really reads as a timber building despite it being glass. And the other benefit of a CCF in the California climate is that theoretically, because of the additional thermal performance you get out of the system, is the norm over there is to run perimeter trench heaters around all the floor plates to deal with the kind of comfort issue in mornings. But actually, you can get away without that with a CCF. So it does actually economically work as a system. And it's nice to think that despite only being a kind of small component, the blinds and the veneers, we have taken some metal out of a relatively large building and replaced it with wood, and it kind of achieved a marginal gain, if you like. And this marginal gain concept is something I really think is important. It's something that Arup coined when they were talking about circularity principles on their Triton Square job, which has been really impressive and successful job in the press recently. And it was borrowed from cycling originally, really, but it's the idea of just improving every project we do. If we just make a little bit of an improvement, then over time we will get there. And there's no market that kind of demonstrated this more, out of the ones we work in at least, better than France. So just over the channel, France has got a lot more wood than us. It's about 31% forest cover, and it's got a really good forestry industry, very famous for oak, for example. Their codes are stringent. They're really stringent. They're quite conservative and prescriptive. But what they do have, as was alluded to, I think, by Kelly earlier, they have specific codes for facades and timber, which is very rare. We don't see that anywhere else in the world, if you think about it. And that allows them to use it. And above all, the government is really pushing very, very hard for timber. Their policy is they want to increase timber volumes by 60% in their developments by 2030 as a nation. And they're pumping huge amounts of money into these big public schemes to showcase the material, like the 2024 Olympic Games. So they're changing the culture over there. And it's not just policy, it's being driven from industry as well. So there's these pacte bois. These are the movers and shakers of the construction industry on the private and the public side, coming together and vowing. I think that the numbers are they're going to have at least 40% timber in all of their developments by 2025, and that includes the Paris region, Ile-de-France, and a lot of other regions in France. So there's a huge amount of ambition coming both from government and from industry. And when we talk about embodied carbon and lowering that, of course, in our the big ticket item is obviously primary structure, but we've got to remember the role that the facade has to play. In a business as usual steel concrete building with, say, an aluminium facade, these are totally notional figures, but the facade might represent 15-20% of the embodied carbon of a development. Whereas if the primary structure becomes a timber frame, all of a sudden the facade's sort of 25% maybe. And as soon as we're recladding a building, which is becoming the norm, at least in London at the moment, the facade replacement becomes like the lion's share of what's happening. So how do we lower the embodied carbon in our facades? So it's really good to see the timber unitized systems and everything being presented today. That's a really good start, and it's something we can do in the UK now. It's within regulation. But what I find really interesting in France in particular is there's a lot of focus on the opaque cladding, a lot of focus about using timber in opaque areas. And as our glazing ratios are rightly coming down, there's a lot more opportunity for this. And we're quite familiar with the SIPS panel in the UK used for housing and small projects, but what they're doing there is much more large scale, used on much larger buildings and a lot higher quality and higher level of engineering. And it can be used on a range of different buildings. I just really think it's interesting that they're thinking about timber in a different way. They're not thinking about it necessarily as something to look at and to look nice. They're thinking about it for all its other credentials, the fact it's economical, it's flexible, and it's sustainable. And hopefully this case study will showcase that. This is out of our Paris office. It's the refurbishment of the UNESCO headquarters. So this is a Jean Prouvé facade from the 60s, which is well past its kind of useful life. It's single glazed, it's got no thermal breaks, all the metal coatings are deteriorating. So, but because it's heavily listed, they needed to put back something that was identical. So we kind of had a few options here. First was to take it down, recycle it, and put something new back. The second was to try and reuse this cladding. And specifically, that would mean removing the cladding from the outside because it was poorly performing, take them away, clean them, remove the asbestos and the bad stuff, and then integrate that cladding back into a better performing system. And so for that backing wall that the cladding might sit on, we had two options. There's the go-to aluminium curtain wall. We had more options this, but these are the two that were kind of shortlisted. And then we had an option that just wouldn't even be considered in the UK, which is a large format timber panelized stud SIPS panel with the metal on the outside. So we had 6 kind of options with various levels of reuse and the kind of metal versus timber as the backing wall. So we went away, we did some carbon counting, and no surprise, reusing the cladding was obviously going to be a lot better for the environment. 80–90% savings to take it off carefully, take it away, clean it, recoat it, and bring it back. No surprises there. And what we found actually is that the design of the facade originally was quite ahead of its time in terms of design for disassembly. It was all screwed and layered, and actually it was well, it hasn't happened yet, but it's relatively easy to take apart. And when we actually did an LCA on this, you could begin to see that for the baseline business as usual case of down to the kind of using timber in a hidden sense and reusing everything, we got a 530-ton CO2 equivalent saving on the building with a system that wouldn't even be considered here. And hopefully that just showcases that timber doesn't need to be the showpiece. It can plug away in the background, and it's basically posh carcassing in this situation, but it's doing a lot for the sustainability credentials of the scheme. So, having zipped around the world extremely quickly, I'll try and pull together some thoughts of what potentially we could be doing differently here. So, some takeaways for the day. We should use timber where we can, and that doesn't necessarily mean we look at it. It could be hidden, but it's a sustainable material. We should be using it. And I feel we have an onus on us as designers, facade engineers, to always at least put it on the table. If it's feasible, let's put it on the table. And we should clarify what sort of buildings we're talking about. There's obviously a huge amount of confusion over the Grenfell inquiry and over the consultation from 2020. The Grenfell inquiry won't report until next year, and that consultation is not going to happen before then, we don't think. So we're not going to be able to use timber in relevant buildings for the short, if not long term. But this is a map of building heights in Manchester, I think, and you can see green and yellow is kind of, well, green is low-rise, and the majority of the building work in the UK is low-rise construction, and we should focus on that. And as facade professionals, certainly, we're getting more and more involved in lower buildings. And it will be the tallest commercial timber building in London that we've been doing the structures and facades on with Thistleton, as Anthony mentioned earlier. But it's not a tall building. It's the scale of a lot of London, and therefore we really hope this black and white building, when it's finished very soon, will set a really good precedent going forward for that scale of building and the appropriateness of timber for it. It's also really encouraging to see that the large house builders, L&Q and so, are clubbing together and doing some proper LCA studies on timber in low-rise construction and housing, and finding what we all know to be true, that brick and block, this is just for walls by the way, but brick and block is obviously a lot more carbon heavy than timber and timber framing, and actually beginning to change that culture of traditional cavity walls. And we have a huge retrofit problem in the UK. At some point we're going to have to invest a huge amount of embodied carbon in these old buildings in order to save on the operational carbon that we need to. And so I see this as a massive opportunity to design a really robust, reliable, tested, proprietary system in timber and maybe bio-based materials to have some responses to this retrofit that aren't going to cost a huge amount of embodied carbon. It's billions of dollars or pounds, we're in England here, billions of pounds in this, and it's not happened yet. I don't understand why there isn't a timber product for recladding buildings that isn't there and at the top of every shelf. And I touched on earlier, I think there was generally a common theme when we were going around the world earlier, that the countries that are better at timber are the ones that are growing their own and have their own kind of supply chain. And I really hope that the UK timber industry will provide more. And there's some glimpses of hope that there might be some engineered timber in the UK at some point soon. But it'd be really nice if we had that industry and that therefore started lobbying and becoming a powerhouse. Another takeaway is we need to play to its strengths, and we need to use timber efficiently. And we need to make sure it's doing a job that it's good at. We've got to remember that material selection is very much horses for courses, and hybrid solutions really are the way forward. If we're going to design something optimal and efficient, we should be using the materials that are good at the various roles. And despite timber being more sustainable than other things, we've always got to remember that in environmental terms, it's always better to build nothing than it is to build a timber building. And therefore, when we're using timber, we should still be optimizing, still be minimizing the amount of material we're using as best we can. And an example of rethinking and with timber, it's not the stiffest material. And so when we're designing with timber, in principle, we should be accepting bigger structural depths and embracing it, embracing shorter spans. Unfortunately, in the curtain wall, in the facade, we can't really reduce the span. It's kind of got to go floor to floor, and we're not going to reduce floor heights anytime soon. So a very simple step that we took on black and white, coming back to that job, is fortunately in timber buildings, we have a nice big slab edge to fit to, a nice deep spandrel. And therefore, it's a simple move, but to just fix the facade a second time, prop it with a very light restraint bracket. And that allowed us, from a commercial perspective, to keep the facade very thin, the same, if not less, than an aluminium system. And therefore, you're not uphill battle with NIA and floor area, and then we could start to do some more interesting architectural things by changing the drainage hierarchy of the system and taking out some vertical elements at the spandrel and starting to show off the timber behind and so on and so forth. But it's just little things that you can do to bring in timber. And yeah, that's just the detail. And I think another takeaway from today that's been talked about a lot is about thinking circular and about the circular economy. There's been inconsistency today. The debate about sequestration is still raging on. We still don't have a robust argument for the end of life for timber. It's still pretty much up in the air, despite it being a ridiculously versatile and adaptable material. When we're talking about new build, we're taking steps on lots of jobs. Again, this is one that Anthony showed earlier with Thistleton, where we've very much designed the building as a kit of parts and something that can be reconfigured in the future and disassembled. And we hope that goes some way in the Module Cs and Module Ds of the LCA to justify some sequestration and justify some benefit. But unfortunately, we still have a culture of ripping down buildings, and we have a huge existing building stock, and it's very difficult to retrospectively apply circularity principles to the timber that's already in our built environment. And just to contextualize this, looking at UK wood waste, I think somebody said it earlier, about half of the wood waste in the UK comes from construction and demolition. And of that, 73% is actually timber. It's not chip or pulp, it's timber, of which about 20% is actually just clean, unprocessed wood, which you'd have thought we could do something with. But the reality at the moment, and why sequestration is such a debate, is that we're turning 90% of it into wood chip, and we're burning an energy recovery for well over half. So at the moment, the Module D argument just doesn't work in reality with our current sort of wood recycling infrastructure. So we want to get, you need to get creative. This is a nice precedent from Paris again, where the architect BFE for this nursery building, doesn't look like a nursery, but it is a nursery, used, they just looked in the local community about what was being demolished, and they found a housing estate that were taking out all the oak windows and doors, and they've turned that into a beautiful facade. And the facade is actually somewhere we can do this. If you're talking about shading, screening, even rain screen, we can often justify or work out the warranty situation and use these reclaimed materials. So it's something we should be looking at. And finally, a final takeaway, and everyone said it, is we really need to collaborate and we really need to innovate. And I guess that's the purpose of today, and it's been a fantastic day to share and so on. And to overcome that, we really need to get over this issue of IP and share what we're doing and not keep it behind paywalls and so on. But there's a lot to be optimistic about on that front. There's a lot of really innovative and exciting groups that have started up. The Part Z movement have had a massive win in the last week when Duncan Baker MP put the proposed embodied carbon bill through Parliament for the very first time. So that's out there now. It's been spoken about in Parliament for the first time just last week. And other initiatives, as I mentioned earlier, the Timber Accelerator Hub, for example, who are talking to government and trying to get their disparate departments to talk to one another and to talk to insurers and to talk to construction professionals to actually start discussing these big issues. And also looking at like in the US, creating a targeted, agreed testing program that will build, again, that evidence in the case for timber. And on insurance, we also hear rumors that there are potential alternative insurance models out there. There are developers talking about mutual risk transfer vehicles, which take away the insurance problem and becomes a self-insurance sort of model. So there are ways over this. We all need to share, whether that's our funding, our time, our passion, our fire test, our LCAs. We all need to be sharing this and putting it in a common place to build that evidence. And finally, I thought Zak have done a fantastic job picking this location just over the road from Parliament. I really, really hope they've been listening to the debate. I really hope they take stock and they understand their part to play in this. And I really hope that the British leaders and the French and American leaders all sit down one day, maybe in one of the lovely buildings we've been looking at today, and have a conversation about timber. Thank you.
You can close and then I'll close.
All right. Thank you, Hugh. That was a really interesting talk there. I think it summarised the event quite well, and you had a good mixture of structure and facade information on there. So it's really good. I hope everyone's had a good time. We've come to the end of the do. So I'm going to wrap up for a little bit, and then my colleague here will wrap up as well. I've learned a lot. I hope everyone else has learned a lot as well. I said earlier today that the gene pool of people who understand and know timber is quite small, and we're the bottleneck in some ways in the demand that is here and is coming. So hopefully today that gene pool has just grown a little bit bigger, and everyone who either knows a lot learned a little bit more, or doesn't know a lot learned a lot themselves. So it's really good. I think there's a couple of thanks I'd like to put forward. One is putting these slides and content together is a mammoth task. So I really think we should give a round of applause to our speakers today. I think they've been really good. And next to that is organising these events is also a beast to get through. It's a really difficult thing to cajole everyone together and get them on stage and herd me into the right place. So thank you.
In the midst of a pandemic.
Of course, yes. So if we could give a round of thanks to Zak and the organisers for today, that'd be great. It's been an intense day. It's been a lot of learning, a lot of happening, and I think well done for everyone here who's made it to the end. So I'd like you all to give yourselves a round of applause.
Hello. Yeah. One more round of applause. Last one for Alan Dowdall, our lovely moderator for today. Thank you, Alan. So this was an experiment. It was one of these ideas sitting at home bored during the pandemic. What to do next? Let's do something new. You had all the time in the world. You're not traveling as much. This idea came out, and I can't believe that we've been able to pull this off. It was just an idea. Let's do a timber envelopes event, and then it grew from strength to strength. I would like to thank the industry for supporting us. There are countless number of people to thank. We are retards in the timber industry, so we had to learn everything from scratch. Of course, the pandemic didn't help. Wave after wave, this kept delaying, and then finally we pulled this off. So I'd like to thank all the people who helped us in making this experimental topic, at least from our point of view, a great success. I hope all of you enjoyed. Would love to have your feedback on the same. We have live streamed this event. Of course, we didn't share it publicly, but with all the attendees, we will be sharing the link next week. So we won't be sharing the PowerPoint presentations, but we'll give you the YouTube link, which you can use to review the presentations. Also, I forgot to mention in the morning, most of you will have a USB stick on your lanyard. So it has all the brochures from our event partners. If you've not got one, just request the same at the entrance. So thank you all for being here present. I also want to announce that, okay, timber is not experimental anymore. It is reality. It is the way forward. Something else which we are working on, which we will soon be doing it in London, is the use of carbon fiber in architecture. So that's something which is picking up big way. It's again a long shot. It's a future material, but it is picking up a lot of momentum. That's something which we are working on, and very soon you'll be hearing from us launching that. So we'd request your support and guidance on the same. It's a brand new, fabulous material. Several applications of that, from the envelope to bridges, but it's only dedicated to the construction industry. That's something which we want to only focus on. So I hope to see you all at this event, at the next events, which are in Dublin, Manchester, and London. The London one I'm very excited for this year because of our collaboration with SFE and SIPSI for the Society of Façade Engineering Awards and dinner. So thank you all. I hope to see you at another Zak event. Thank you.